So this first video is going to be relatively simple. We're going to create a new Unity project using the newest version of Unity 2022 with the Universal Render Pipeline package. Then, since all of the art for this project is pixel art, we're going to create a preset for importing textures so that whenever we import pixel art, it's already going to be set up with the right settings. And I'll show you how, if you already have existing art in one of your projects, you can actually apply a preset manually to existing art. So on the left here, you can see that I have Unity Hub opened up. So we're going to go to the blue button, New Project. So up here at the top, we can see Editor Version. For the project, I'm actually, for the time being, going to be using 2022.1.20.f1, since when I create a project with 21f1, I get some immediate errors with the 2D URP package. So once again, for the reference project, I'm going to be using 2022.1.20f1. So let's go ahead and choose 2D URP as our package and give it a project name. So I am going to call it Platformer Crash Course _ tutorial, just to differentiate this project from my reference project. And you can put the location anywhere you wish on your computer. I just have all my projects grouped up in a location called Unity. So let's create the project, and it'll take a second to load for the first time. So hopefully when your project opens up, you should see a clean interface. And if you go to the console, you should see no error messages appearing here. That's what you want to see, just a clean project. So next we need to create a preset for importing textures, all the PNG sprite images that are going to be into the project for characters, icons, backgrounds, so on and so forth. We want to have a consistent import preset for all of them. So let's go ahead and create one before we import any art in the next video. So I'm going to go up to the Edit menu at the top left, go down to Project Settings, and then on the list here, there's one called Preset Manager. So we want to add a default preset, and you can just type in texture here in the search, and you'll find Texture Importer. So let's create that preset manager here. So next we need to create a preset for importing textures. So we'll have the textures set up to have the pixels per unit, where 16 pixels is 1 unit on the grid, which means every one of these grid spaces will be 16 by 16 pixels in our actual game. So in order to create our texture preset, let's first bring a image file into the project. So you can use any JPEG or PNG image. I'll just use the Unity logo here and bring it into the project. So now I can select it in the projects window, just left click, and over in the inspector, you will see all of the settings for this image. So we can turn the current settings into a preset quite easily. In the top right, there's this icon that looks like a couple of slider bars. If you click on that, you can create a new preset from the settings that are down here below. So the settings we are going to want for all of the textures in this project are going to be pixels per unit on 16. So that'll make it that when we bring images with this pixels per unit in, that the grid spaces are 16 by 16 pixels instead of the standard 100 by 100 pixels. We want to change filter mode to point here, and compression to none as well. Now I'm also going to take the max size for the images and take this up to 4096. The reason for that is that with a lower max size, that some images may not look correctly if they were bigger in file size, but I found that 4096 is definitely sufficient for basically any pixel art I've seen. So with those settings, once again, 16 pixels per unit, filter mode point, max size 4096, and the compression set to none, I can click apply here. That'll apply it to this specific image. And then once again, clicking on the sliders at the top right, we can get the select preset window and create a new preset. So I am going to save this in our project, but let's go ahead and create a new folder here to store any presets that we might have to import textures and other objects in our project. So I'm going to right click, go to new folder, presets, then jump into here. And for the file name, I'll call this Pixar Texture Importer Preset to specify that this is the preset we want to use when we are working with pixel art more specifically. So let's save that in here. Okay, now if we open up the presets folder, we can see this preset. You can see the settings here, 16 pixels per unit, filter mode point, and so on. Now let's apply it to the project so that any new textures will automatically assume these settings. The quickest way to do that is in the inspector, you can click Add to Texture Importer Default. But there's actually a area in the project settings where you can customize it in more detail. So let's go up to the Edit menu at the top left, Project Settings, And then down here, preset manager between player and quality. You can add a default preset for many different items inside of your project. If you type texture, then you can of course find the texture importer, which is what we want. But keep in mind that you can have presets for many different types of files in your project if you need them. For the preset here, I'm just going to select from the list and just choose Pixel Art Texture Importer. Over here on the left, the filter section, if you need to have different types of texture importers for different types of files, maybe different file extensions, JPEG versus PNG, then you can write filters over here for that. But we probably aren't going to need that for this project. So you can just have a blank for the filter and the preset Texture Art Texture Importer. So at this point, we don't need the sample texture we brought in just to create the preset. So I'm just going to delete that from the project. So that's going to wrap things up for the first project setup video. So now we're going to need to download all of the art packs from our project with these links, which I'll include in the description, of course, so that you can get to them. I've made sure that all of these assets have at least a free version, so you shouldn't need to pay to follow along with this part of the tutorial. So first off, on the first link, the character we're going to use, this animated pixel adventure by RV Ross, has a lot of different animations, more than we're going to even set up in the tutorial. So you have plenty to add in if you want to go beyond the scope of the crash course. And when you get to the download section, you're going to specifically want the Adventurer version 1.5, Adventurer hand combat.zip, and Adventurer bow.zip. So download all of those onto your computer. Next up, we have the Fantasy Knight by A.A. Matt Neeks. So there's only one zip file to get here, the free Knight version 1.zip. Go ahead and download that. For a text font from Manigore, we have M5X7. Fits the pixel art aesthetic pretty well. So go ahead and download that. And you're going to want the .ttf file. Next, for the tile set, the ground, and I believe the background as well when we set up a parallax background, we have the Cute Forest tile set, also by A.A. Matt Neeks. So go ahead and download that. And you're looking for a free Cute tile set version 1.zip. Next, from Henry Software, we have the Pixel Food Pack, which we can use for a bunch of health pickups in the game. So get the free pixelfood.zip and download that. Next up, Kairai's free 16x16 RPG icon pack. So I needed an arrow projectile, so I used one of these two ice arrow sprites and created an alternative rotated version of that to be the arrow projectile for the game. But this is where it originally came from. I'll also have a link to download just the modified version that I have so that you have that as well. But if you're ever going to create some kind of inventory system, this would definitely be a good starting pack because there's a lot of useful icons. These could also be used for UI elements as well. Okay, and then to have some cool monsters, we have Lewis Mello's Monster Creature Fantasy Pack. Let's go ahead and download that. So for this, you want to get all three of the versions. The base version has the original animations, but version 1.2 adds extra animations. Version 1.3 adds more animations on top of that. So you just want to combine them into the same folder so that you have all of the animations to work with. And then lastly, for music and sound effects, we have Eufolka's legendary JRPG Battle Music Pack. So grab the full zip file. I'll only be using 1 or 2 tracks from here, but played around with it. They seem to be pretty good in general, so you could definitely use more of them. And then lastly, for sound effects from Leopaz, the RPG Essentials sound effects. So we're going to download that as well. Okay, and then this file should be the last one. And you can see on my desktop, I now have all of the zip files. The Adventurer has 3 files, the Monster Pack has 3 as well, and the rest of them are all individual zip files. So in total, that should be 3, 6, plus 7, so 13 total zip files. Okay, so to add them in, I'm going to right-click, Show and Explore for the assets in the project. So let's jump into the assets folder. And I'm just going to set things up here to have the same directory structure as my reference project, except for the presets. The presets we put outside in the main assets folder, since you can have different types of presets. So that's going to be the only difference here. So in the assets for our new project, I'm going to right-click, create a new folder. I'm going to call it Art. And just really quickly, I'm going to create copies of all the same folder names over here on the right. And we'll come back to the tile palettes part in a later video. So let's get a zoom in on these folder names if you want to match them and make sure they're exactly the same as in the tutorial. And next, we just need to start bringing in the art assets into here. The font, the music, and the sound will put in a different folder right after this. So in the Adventure pack, I'm going to grab each of the zip files. So the contents of them, we're just going to extract them straight into this folder. So you should have one called individual sprites and the version 1.5 sheet. So open up the other adventure packs and bring in the same files and just drag and drop them in the same way as well. The new sprites from the new animations, they just go straight into the individual sprites folder. Should happen automatically. So this is what you should have for RV Ross Adventurer. Next, let's do the monster pack. So open up the folder and one at a time, get the contents of the Monster Creatures Fantasy. So I'm going to jump into the directory here and grab the 4 monsters, Skeleton, Mushroom, Goblin, FlyingEye, and all characters.png and drop them in. Make sure you do that for each of the versions as well. So you should have to do this 3 times to bring in all of the animations. Okay, like so. Okay, next we can do the free night. So get the color 1, color 2, the promo, and the comparison, and just drop those in here. And that's it for that one. Next, Kairai's RPG icon pack. I will drill down, get the sprite sheet, the icons, the sample, and the readme, and drop those in there. Okay, and next, the free pixel food from Henry Software. So for this one specifically, we want to drill down a little bit. So free pixel food, assets, free pixel food, and then all we actually need here is the sprite and sprite.meta. So I will drag those into here. And if we open up the folder, you can see this contains all of the food items that we can use as pickups. Okay, and lastly, for the visual art, free cute tile set. So right here, free cute tile set version 1. Open it up, and there should be 6 or 7 PNGs. Drag those all in there, and then just double check all of your folders. Make sure that you have the content in each of them. So it looks to be good for now. Okay, so now drill back out to the assets folder, and we will create a new one. I'm going to right click, do new folder. Let's call this UI. Jump into it, create a new folder, right click, new folder fonts. Open that up and just drag the M5X7 TTF font straight into here. And that's all you need to do for the fonts. So let's go back out and let's create one more directory for audio. So right click, new folder, audio. And here we'll create 2 new ones. Right click, folder. So we want music. Right click, new folder, SFX, sound effects. And then let's open up the music pack. So inside of here, the only one I plan to use for right now is Battle 1, but feel free to check out the other music. You can use whichever one you want for your game, of course. So let's drag in 10 Battle 1 8-bit style and just put that in there. Go back out, and then sound effects, the last thing. We just need the RPG Essentials free sound effects. Open it up, drag in all of these folders straight into here. Okay, and that should pretty much be it. So the only final thing we're going to need is a projectile. So as I mentioned, I made a slightly modified version from the Kairai's pack. So let me just go grab this from the reference project, this straight arrow modified PNG. I will just drag that in as a copy. So once again, I'll put a link so that you can have this one modified file as well. Now, when we check our art, you should see that the settings for all of the textures, the 2D sprites, have been set up with our presets. So clicking on this, you can see pixels per unit 16, filter mode point, compression none, max size 496. So if you see that, you know that our preset is working as intended. If we jump into any of the packs as well, you can click on any of the other PNGs, and you can see we have the same settings, 16, point, no filter, so on and so forth. So if you're up to that point, good. Now, obviously, a lot of these sprite packs are eventually going to be switched from sprite mode single to multiple as we split up the sprite sheets into different animations. Don't worry about that just yet. That'll be like the one thing we do manually for each one. So for this section, before we get into actually building the project, the last part of setup is getting a couple Unity packages downloaded inside of the Unity editor that we're going to use for the game. So the import system is just the newer way of getting controls to work from your players. So when you press a key or you move your joystick, depending on what kind of input device you have, the import system is what takes care of all of that. And then the Cinemachine is great for doing follow cameras, creating camera shake effects on a player getting hit or something. So both of these are super useful packages for editing projects in Unity. And then the last thing we're going to do is turning off reloading the domain when we hit play, which when we're editing will allow going into play mode to be much faster and just make for a speedier creation of the game. Okay, so first off, getting the packages, we go up to Windows, Package Manager. At the top left, instead of in project, we want to switch to Unity Registry. Then on the right here, type in Cinemachine. So you can just put CINE and it should pop up here. Click on the install button. And then on the search bar, type in input, which should pop up the input system, currently on version 1.4.3. So let's install that as well. And for the input system, this completely replaces the basic Unity input. So it's going to have to restart the editor in order to update the system to use the new stuff. So let's just go ahead and hit yes here, and Unity is going to reboot. Okay, and back in the project, you can click on console next to project. Just make sure there's no errors still. And to verify that both of the new packages are in there, we can change in the package manager to in project and make sure the input system is here with the check mark and Cinemachine also here. And that should be good to go. So once again, as I mentioned, we can turn off reloading the domain to make going into play mode faster. So let me hit play here, and you'll see that it takes a second. Let's go back out and in one more time. Yeah, you'll see that each time it has to reload the domain. So it takes a second for the Unity project to actually go into gameplay mode. So if you want to make that faster just for editing, then what I like to do is go to Edit, Project Settings, I believe. Go to Editor. Scroll down towards the bottom here, and then there's Interplay Mode Settings. So I'm going to Interplay Mode Options, check Reload the Scene, but I'm going to uncheck Reloading the Domain. When we have Reload Domain turned off, then that means that every time we hit play, it's not going to completely reinitialize the game, and that can be a performance saver. But as you can see, having those turned on, Reload Domain and Reload Scene, would make it as close as possible to when you have an actual build of your game. But I haven't really noticed much of a need to actually have these on while editing. So having reload domain turned off can actually just make it much faster to enter into play mode. So back in here, if we hit play now, you'll see that it's almost instant. You don't have to wait for that little loading screen. If in the future you ever notice a need to have them on, go ahead, turn them on, but we shouldn't need it for this project. So in this video, we're going to be building a basic background, and we're going to do that using 3 game objects that each have their own sprite on top of them. And then after that, we're going to make sure that anything that is in the background has its own layer, so that anything like a player, an NPC, or the actual tiles that the player is going to stand on all show in front of the background no matter what. So let's go into our project. You can see in the hierarchy that the default scene is called Sample Scene. Let's go ahead and rename that. So I'm going to click on the scenes folder inside of the project window, find the sample scene.unity, click it, and then F2, and we're going to rename it to be gameplay scene. So since the scene has been modified, we got to reload it. So hit reload, and you can see the name is updated inside of the hierarchy itself. So next, let's create a game object to hold our background images. I'm going to right click in the gameplay scene and choose create empty. So this creates a game object that has nothing but a transform. I'll rename this to be background, but this is actually not going to hold the background images itself. It's just going to be a parent object that will basically have a list of the background items. So right clicking on our background parent game object, I want to choose create empty. I'm going to rename this game object background1. So with BG1 on the right in the inspector, we're going to add a component to it. So click add component and search for sprite. We're going to be looking for the SpriteRenderer, which allows us to assign an image to the game object. So as you can see, a game object is composed of multiple components. One that every game object has is a transform, but others like SpriteRenderer are optional. So the SpriteRenderer, we can put an image into the sprite slot in order to have it show. So inside of our project window, look for the art directory and then go into FreeQt Tileset. So this is going to contain the background images that we set up in a previous video. So let's take BG1 and then assign it to sprite. And there you can see our background image. If it has the right pixel preset settings, then you shouldn't see any blurriness between the pixel. It should render every pixel crisply. Okay, so if we zoom out a bit with middle mouse wheel scrolling out, you can see that this barely fits our camera currently. So we might end up having to both shrink the camera size, but also to make this background image tile as we walk across our platformer level. So take the draw mode setting in the inspector and change that to tiled. And then we can set a width for this background. So I'm going to take width and set it to 500. Now you can see that this background is going to tile over and over and over again, more than likely big enough for just about any platformer level, but you can always extend it further if you need the size to be bigger. So let's do the same thing with background 2 and background 3. To save time, I'm going to take BG1 in the hierarchy and hit Ctrl D on it to make a duplicate copy. Then I'll just rename it with F2, BG2. And you can see we already have the sprite renderer. So I'm just going to change the image here from BG1 to BG2. Now you can see it's currently showing in the background. So if we want to make sure that that's showing on top of whatever's behind it, you can change the order in layer to a higher number. So I'm going to take the order in layer here and I'll just make it 1. So now the cloud part of the background shows in front of the sky, which is what we would expect. So let's do that one more time. Take BG2, Control D to duplicate it, F2 to rename it, and do BG3. And now take the grass background, BG3, and put that in the sprite slot. Now, to make sure that this always shows in front, I'm going to take the order in layer and set it to 2, even though currently the grass is already visible. So for right now, things are looking pretty much correct, but one problem we're going to run into is that these backgrounds are on the sorting layer default. If we click on the default dropdown, you can see that everything is going to be on this default sorting layer, and that's not what we want, because we actually want the background to always be below the default so that things on default or a higher layer are going to show on top. So click on the default dropdown and then choose Add Sorting Layer. Where it says Sorting Layers on the right under the inspector, click plus, and let's make this layer name Background. Now click on the 2 lines horizontally and move this above default. This now means that background shows below default. So if you have anything on the default sorting layer, it's going to render on top. So now we need to go to each of these 3 backgrounds, or you can hold shift down and select them all at once, left clicking on each one as you add it. Or you can left click on the first one, hold shift and left click on the last one to select the range between BG1 and BG3. And now change the sorting layer to background. So since we have 3 items selected, if we click on each one individually, you can see it's been assigned to all of them at the same time. Of course, you can also assign it individually as well. Now the last thing I'm going to do is click on the main background game object and make sure the position settings are all set to 0, 0, 0. So the parent's position is also going to change all of the children's game object positions, and I have no need for it to currently be moved from the 0, 0, 0 starting position. So with that, we should be able to scroll across our game and see the background extend pretty much forever, and that's how we'll set up the basic background for our platformer. So in this next part, we're going to be creating a basic player game object with the ability to move left and right. So we'll need a sprite renderer to show our player on the screen, a rigid body 2D, which is the physics component for a character like a player, and will help us to handle movement and physics. And then to get the input from the player, we're going to have a player input component. That's something we get out of the input system, which we installed earlier. And we're going to be creating a player controller script to actually cause the movement to happen based on the input we get from the player input component. And I'll also put here that we're going to talk a little bit about prefabs, since we might want to create a copy of our player in other levels or scenes of the game. So prefabs are super helpful for doing that. Okay, so in our gameplay scene, right click and create a new empty game object. I will just call this player for now. So we're going to need a sprite renderer component to show our player. So sprite renderer. Now we need a sprite, which we will get from the art assets folder. And we want to use the RV Raws Adventurer. So let's go dig into individual sprites. And we'll look for the idle sprites. Now, when you see the preview images like this, it's visual, but it's a little hard to find what we're looking for. So I'm going to take this little slider bar in the bottom right of the project window and move this all the way over to the left. So now we can see things in a very clear alphabetical order. So just go down until you get to Adventurer Idle, right past Adventurer Hurt. And we'll take the 00 frame and assign that to our player sprite renderer. So of course you could drag that into the sprite renderer sprite slot directly. Another way is that you can also drag the 00 frame onto the game object that has a sprite renderer inside of the hierarchy. So click on the player game object and then drag adventurer idle 00 into the sprite slot, and we'll see our character on the screen. So next we need to add another component, which is rigid body 2D. Rigid body without the 2D is for a 3D game, but obviously we're making a 2D game, so that's why we use 2D. So we're going to leave the body type in dynamic, So we're going to leave the body type in dynamic for this course, which allows gravity to automatically apply on our game object. Now, there are several ways of interacting with a dynamic body, such as using the add force method, which we're not going to do because we want to have precise control over our character's left and right and jump movement. So we're not going to use forces, but rather we're just going to be setting the velocity on the rigid body. But for gravity, we can have that handled with the gravity scale down here. So if I go ahead and hit play in dynamic mode, you'll see that our character already starts falling. So whatever our gravity settings are on the project are going to apply to this character and any other character in dynamic mode. One setting I do want to change though, down here under constraints, freeze rotation. We're never going to want our platformer character to have the sprite rotate around in circles. We just want to have that frozen in place. So that means that the transform on our player is not going to rotate, so you'll never see anything like this happen to our character, as long as the freeze rotation constraint is checked. So now we can shrink both of these. And before we get to creating the player controller script, let's save this game object as a prefab inside of our project. So click on the assets folder, right click in the project, create a new folder for characters. So I'm going to call it characters. Double click on it. I'm going to right click and create a new folder for the player. And while we're at it, I'll just create a enemies folder in advance as well. So a game project is going to have a lot of different files in the end, so it's just a good idea to try to keep things organized from the get-go, so it's not confusing later. So in the player folder, let's jump in there. To create a prefab, we simply need to drag the game object from our scene into the folder. So left click, hold, drag it down here, and you'll see a prefab object will be created down here. If you click on it, you can see the components, just like how we had dragged it from the scene. And you also see in the hierarchy that a game object linked to a prefab is blue. It also has an arrow on the right, which you can click on to edit the prefab. So how prefabs work is this is a game object saved in the project assets. So anywhere we need it in a scene, you could just drag it into the scene, left click, hold, drag. And each instance in our scene is going to be based off the basic settings inside of the prefab. So when I drag it into the scene, it is a copy of whatever's in our project folder, but you can change it from that point. So if you need to, let's say, triple the scale on X, make it a chunky boy here, you can do that. Now this doesn't actually update the prefab. If I click on the first one, you can see that the other player is still scale 1. And if we double click on the prefab in our project, then you can see this still has a scale of 1 by default. So you can have an object that's based on a prefab and then customize all of the settings as you need for the game. Maybe a character needs to have more or less HP than the basic prefab version of it. Okay, so I'm going to delete the extra player 1 from the scene. Now, once you've created a prefab, if you add another component inside of the scene itself, that component is not going to be automatically updated on the prefab. So at this point, if you want to add something to a game object that applies to every prefab instance, it's a good idea to work in the prefab itself. So you can click the arrow and open the prefab for editing. Now let's do add component, and I'm going to type in player controller, which Unity isn't going to recognize as an existing component, so we're going to use new script to create it. So just new script, player controller, create an add. So now if we click on the assets folder, we can see our C# script automatically created here. But I want to put all of our scripts into a scripts folder so that we know where they're all located. So I'm going to right click in the project, create a new folder. I'll call it scripts here, and I'll drag player controller into it. So now double clicking on scripts, we can, well, it needs to reload the script assembly, so give it a second. Now we can double click on the player controller, and it will open up in our code editor. So by default, that's Visual Studio. I'm using Visual Studio 2022 community version just for reference. And what you should see here is public class player controller, which is inheriting from mono behavior. So anything that's going to be a component you attach to a game object in Unity needs to be a mono behavior, which gives certain functionality to it, like the ability to call start and update methods. So these are part of the lifecycle for your Unity game. Every mono behavior technically has these methods and they run at different times. So start would be when the game object becomes active for the first time in your scene, and update will run on once per frame of the game. And this version of update can vary depending on how fast your computer is, but we can use this for anything that wants to be updated as fast as the game and the current system it's running on can process. So now that we have this script open, I'm going to jump back to Unity for a second because we need to add the player input component. So add component and type in player to find player input. So click on this. And because I'm not editing the prefab, you'll see a little plus next to the icon for it, which means that this is an added component that doesn't exist on the prefab. So if you want to add this to the prefab now, you can still do it by clicking on the 3 dots on the right and then do added component, apply it to prefab player. Then if you jump into the prefab, you should see it here as well. So if you forget to edit on the prefab, it's okay. You can still apply changes to the prefab from the instance if you need to. So every player input is going to need a input action asset. So the input actions are going to define which keys do what in our game. So to create one in our project, click on create actions. And I'm just going to call it player import actions.import actions. And I suppose we'll save it inside of characters and then players and just save it in there. So when you create the import actions, you'll see action maps, player, and UI. So the UI is going to handle things like button clicks later on, and then player is going to be for moving the player game object. So you can see by default we have move. You can extend that and see the different key inputs that you can use to move the player. So WASD on the keyboard or left stick on a gamepad. To look around, you can see using the right stick to move. We won't be doing anything with this because we'll just have a follow camera always stuck to the player. And then fire, which would generally be used for things like firing a bullet or, in our case, a sword attack. So because we don't have any projectiles that we want to fire with at least the left mouse button yet, I'm actually just going to click on the name here and rename it to attack. So now this is no longer a fire action, but the attack action. So if we close out of this player input and hit save to update it, you might notice that in our list of functions that would be sent to the game object by default, on fire changed to on attack. So when you're in behavior send messages and you want to respond to one of these things happening on our player input, you would just implement a method with the same name in your game object. So if you create on attack, this will be called whenever the on attack left mouse button is pressed on our player input. But the thing about send messages is that it looks for all of these functions to be called on any of the components on this game object. If you do broadcast messages, then it would go to children game objects as well. So it's possible that a function would get called that you didn't intend to get called when a button's pressed, or you might not know exactly where it was being called. So instead of using send messages as our behavior, we're actually going to use invoke Unity events. So this will create a new dropdown down here. If we click on it, then you can see further dropdowns. So we're looking for player, and then player has this attack callback context. So attack is the event. Callback context is the parameter that's going to be passed to the function from our player controller script in order to handle the event. And then we can click on plus down here later to add the function in to be called when attack happens as an event. So when you do things this way, instead of just responding to a message by having the same function name, you have to directly set the function you want to call when these events happen. But that also means you can very clearly see exactly what's going to happen on each of these events triggering. So now let's jump back to our player controller script. We're going to need a function with no return type, so that's void. And I'm going to call it on attack. For right now, though, the event that we're going to handle with this video is move. So you can see that this gives us the parameter callback context. So we have to make sure that our method has that as a parameter. So back in our player controller script, so down here at the bottom, I'm going to create a new method. So void is going to be the return type, and then I'll give the name of it on move. But we have to get the callback context parameters. So what you're looking for here is input action dot callback context. And we can just call it context here. Okay, so now it has the parameter. And now we need to read a vector2 value from the context. So the way we know that the data that we're receiving is a vector2, the up, down, left movement, basically X and Y, is if we check the input actions, you can look at the action and see the control type. So this is giving us a value as a vector2. So we can get the movement input here. But rather than making it a local variable, I want to declare it at the top of the script. So I'm going to call it vector2, which is going to have an x and a y value as floats, move input. And then down here on move, we'll set that each time on move is called. So move input equals context dot read value. And the type of value we're reading is a vector2. So you can see Visual Studio 2022 is automatically trying to complete that for me. So I'll just hit tab and have the line kind of write itself. Okay, so we have our vector2 value. So that's going to be the x movement input and the y movement input. So whenever our move input is checked, I want to see if this value is not equal to vector2.0 to make sure that it's moving. And if it's moving, then I want to set is moving to true. Otherwise, I want to set is moving to false. So I'm going to do this as a property, which means I'm going to make the first letter capital. So is moving is equal to move input does not equal. So that's a exclamation mark equal vector2.0. So this is going to give us a true false statement, and we can use that to set different values. Then we just got to end the line. So we're going to get an error because is moving does not exist in the context. So if we click over here, I can hit control period in order to generate a property automatically. So I'm going to generate that at the top, is moving, and we can just leave this as a automatic get and an automatic private set for now. So we'll come back to this later, but we'll be able to use this property in order to change other things, like whether we're playing the idle animation or the moving animation on our animator component later. Okay, so now the important bit is that move input is going to be set on every frame. So we want to take that and we want to multiply our movement input by the time between frames and then the move speed of our player in order to generate how fast it's going to be moving left and right. So let's create a public variable, which allows us to set it in the inspector to change it and customize it for our character. And we'll do float, so has a decimal point if we want it. And then we'll do walk speed. Later we'll have a run speed. So the walk speed we'll set to 5F for now. And then we'll use this speed, adjust it in order to control how fast our character walks. So when we want to do a physics update, which is anything to do with a rigid body generally, then we want to do that on void fixed update. So let's do void fixed update here, just like so. Okay, then we want to set the velocity on the rigid body to actually make our character move, but we haven't gotten reference to the rigid body component on the player controller. So if we look at our player game object, you can see the public walk speed variable showing here. That's good, but we still need this rigid body component. So how do we get another component on the game object, but then to use it inside of our script? So we can go to the top of our script and type in rigid body 2D, the type of component. I'll put RB to reference that this is a rigid body. And then we're going to add one more method, another life cycle one, to our script. So void awake. So awake will happen when this component exists inside of our scene, but start only happens once it exists and is enabled. Start comes after awake and will only be ever called once. So if we want something to be found as soon as possible, we want to put it in awake. So RB, and then we can do equals get component rigid body 2D, just like it says here. I'm going to hit tab just to make that quick. So rigid body 2D is the type. We're getting the component, and this automatically assumes the game object that we're currently on, and it takes no parameters. So this means on awake, the rigid body is going to be set. It's going to reference that rigid body that exists on our player game object, if it exists. Otherwise, it will throw an error. If you want to make sure that anytime you add a player controller, that a rigid body exists, then what you could do is go up here to the top and do square brackets, require component, type of rigid body, 2D. So make sure that's actually set to 2D here, because that's going to match this one. And this will mean that you can't add a player controller to a game object unless a rigid body already exists. And if there is a player controller, then you can't remove the rigid body from the game object until the player controller has been removed. So it's not required, but if you want to be more certain that this component exists on the game object, then you can just put this little line at the top to do that. Okay, so now what we need to do on fixed update is do rigid body dot velocity, and we're going to set this equal not to move input directly, but to a new vector 2. So because we're controlling the walk movement of our player, we're going to set the walk velocity to move input.x. That's the x or horizontal input that we get from our player's input. We're going to multiply that by the walk speed for now. And then we need to make sure that our movement is consistent. So I'm going to do times time dot, and let's do fixed delta time. So minor correction here for the x movement on our velocity. When you set the velocity, it already factors in the per second speed and updates that on every frame. So we don't actually need to multiply this by time.fixed delta time because that bit is already being handled by the rigid body's internal movement itself. So just do move input.x times walk speed. If you see the movement being really slowly, it might be because you're still having the times time.fixed delta time or times time.delta time. So we can hit comma, and then we want to find out the y velocity. So right now, the y velocity is going to be completely controlled just by gravity. So we don't want to change that. We want to keep it the same as it was before. So do rb.velocity.y, and then end it. So the vector2 takes two inputs. Here's our x, and here's our y. Okay, now we can jump back to the game view. Let's try hitting play, and you can see our character still falls. So for right now, I actually want to turn off the gravity so that we can see just our movement. So let's expand the rigid body component in the inspector, take the gravity scale, and set it to 0 temporarily. So if we hit play, try doing WASD, and you'll see we still don't have any movement. That's because we haven't linked up the onMove method to the Unity events for our player input. So now we can go down to player input, and let's expand the events, make sure that behavior is set to invoke Unity events, expand player, find our move callback context event, hit plus. We can drag the player controller script into here, or you can drag the game object from our scene hierarchy into the slot here. I'll just do the quicker way, player controller into the slot. Now click on no function, find our script name, player controller, and then you're going to want to do the onMove callback context, but we can see that that's not there right now. The reason for this is that the function is currently hidden because it's still private. So back in the C# script, go down to where it says void onMove and just put public in front of it and save the file. So now going back to the move event, click on no function, controller, and you want to choose onMove the dynamic callback context. So now that the Unity event has the method here to invoke, we should be able to see movement on our player when we hit play. So once again, for the walk speed, set to 5. Make sure it's not multiplying by times.delta time in the fixed update. Let's hit play, and we should be able to see some solid movement for our player. If you want to change this temporarily to increase or decreasing it, and see if you like it better, you can change the number. So walk speed set to 3 while we're still in play mode, and you can see that it immediately changes our speed. You can try 7 if you want a character that walks faster. When you exit out of play mode, it's going to revert back to the default value you had set before you hit play. So anything you change in play mode is just for testing, but shouldn't actually change your project permanently. And if I was to re-enable a gravity scale to 1 right now, I hit play and I move left and right, it's going to fall, but also still being able to walk left and right. So if you set up the velocity set correctly, it shouldn't be interfering with the up-down movement due to gravity. The left-right should just work on its own. Okay, so up to this point, if we go into play mode, we should be able to move left and right, but our camera is not following our player at all. So we installed a package called Cinemachine, which makes it really easy to have a follow camera. So to turn our camera into our Cinemachine camera, we need to right-click in our gameplay scene, go down to Cinemachine. This menu should exist if you've already installed the Cinemachine package in the package manager, and then choose 2D camera. If you didn't see that option, make sure you go up to Window and Package Manager and install the Cinemachine from the Unity registry. So now we should see the main camera has a Cinemachine icon on the far right and a new object, Cinemachine Virtual Camera 1. So on this virtual camera, first what I want to do is go down to Add Extensions and then choose Cinemachine Pixel Perfect. Since we're working on a pixel art game, we want to make sure that each pixel renders crisply as we're moving left and right. And then we need a follow target. So we're going to click on this icon over here to select and choose player from the scene. So now if we hit play, we should already have a follow camera where we can follow our player around the screen. And it's looking good. We don't have any choppiness as the camera follows the player. Now you might notice that when I start moving and stop moving, there's a little bit of a delay. That's intentional by default. And if we expand body, we can customize settings like that. So that delay is coming from X damping, Y damping, and Z damping set to 1. If you turn all of these off, set them to 0, then the follow camera is always going to stay right on top of the player. But you can see this doesn't quite look as nice. Sometimes you do want the camera to have a little bit of a lag. So we can return the damping to 1 for all 3 of those. So hitting play again, you can see that while we have body expanded down here, that it will actually show this overlay to show more exactly what's happening. So the crosshairs is where the camera is currently at, and the yellow square is the target, which it's trying to reach to. Another setting we can try playing around with is look ahead time. So now with a look ahead time of 0.5, it's going to move the target to where the player is expected to be in the future. So I think this might be 0.5 seconds. I'm not totally sure on that. But yeah, that's basically the idea. But you can see that when I go from not moving to moving, that this target moves instantly. What we might want to do is set smoothing so that it takes a little bit of a time for the target to actually reach its final point. It might make the animation look a little bit smoother. Exit out of play mode, and then we'll take the look ahead time and set that to 0.5 and set the look ahead smoothing to 6. So we can go ahead and hit play, and we should still have that look ahead time. There are other settings we could play around with, like dead zone width. So if we set this, then while our character's inside of the dead zone, it won't move the camera at all. I don't particularly like this as much, so I'm actually going to leave dead zone off completely so that the camera's always trying to follow the player as the player's moving in one way or another. But you're more than welcome to customize all of the settings here to control how the camera's going to look at your player during the gameplay. So that's basically it for all we need to set up for Cinemachine to have a cool follow camera following our player. This will also work when we have gravity going up and down. So, I mean, we could test that. So I'll turn the gravity back on the player, setting the scale to 1. Then we'll hit play, and you can see the follow camera actually follows our player down. And it still has that look ahead time, so it's looking where the player is going to be rather than where it is currently. So let's turn the gravity scale back to 0, and that'll be it for this part. So in this part, what we're going to be setting up is the parallax background, where when you have your main character walk left and right, the background elements are going to move at different speeds. So you can see that the ground that is close to the player appears to move the least fast, the clouds behind it are a little bit faster, and then the sky far in the background seems to move the fastest. So in order to set this up, we need a component attached to each of the objects that we want to apply the parallax effect to. That's going to mean each of these individual 3 background pieces. So I'm going to add a new component, and we'll call it Parallax Effect. New script, create an add. I'll make sure that I move the script into the scripts folder before I go to edit it. So now in Visual Studio, I'm going to open up the Parallax Effect. So first off, I want to point out the original for this script is by Adam C. Jonas on YouTube. So he has a very lengthy video talking in detail about how this parallax effect works exactly. If you're interested in that, I would go check out his video. This will just be mostly to get it working. So first off, we're going to need 2 references to game objects in our scene. So the first is going to be the camera. So let's get a reference to public camera cam. And then we're going to need the transform of the follow target of the camera. So that would generally be the player in our scene. So I will just put a public transform, and I'll say follow target, since that's most relevant for our script. As our camera moves, it's going to follow the player across the screen. And based on the movement of the camera, we're also going to be moving each of the objects that the parallax effect is attached to. At the start of our script, we want to remember the position of the parallax game object. So we'll have a vector 2 starting position. And we'll set this on the start method because the time when it's relevant is when the object first enters and is enabled in the scene. So that's where we'll set that. We're also going to want to get a reference to the starting Z value. So float starting Z. For a 2D game, the Z axis is going to be the distance into the background. So when something is really far from the camera or the player into the background, that's because it's going to have a very negative Z value. So we want to remember what the starting position of that Z value was as well. So when our script starts, we can set those up. So starting position is equal to transform.position. So normally transform.position gives you a vector 3, but we can just automatically cast this to a vector 2 and shave off the Z axis. So for the Z axis, we'll get that as starting Z, which is transform.position.z. And then when the frames update in our game, we want to move the position of our parallax object based on how far the camera has moved from the starting position. So we'll do vector 2, new position, and this is going to be for the parallax object, is equal to the starting position plus the camera move since start. So we care about how far the camera has moved, and we're going to use that in calculations for determining how far this object should move. And that's going to be modified by something called a parallax factor, which we'll set up in a minute. And so once we have the new position, we want to set that on the transform. So transform.position, once again, this is of the parallax effect object, is equal to a new vector 3, new position.x, new position.y, and then the starting z value. So essentially here, even if we're changing the xy position, we're not moving the position of the z value. Okay, so the camera move since start, that's going to be a vector 2. And we're going to put camera move since start. Now this is going to be a value we want to calculate on every frame. You could just put vector 2, name of the vector down here, and set it in the update method. But there's another way of doing things, which is kind of cool, which if you do equals and then a arrow in front of it, then that's going to mean it updates itself on every frame. And you don't need to put it directly in the update method. So we're going to take the camera position, the new one, and we'll just cast that as a vector 2, since we're setting a vector 2 as well. So cam.transform.position here, and we're going to subtract the starting position of this game object. So starting position, and we're figuring out in a XY only basis, how far has the camera moved away from the starting position of this parallax object. So this is basically meaning that at the start of the scene, there's no parallax effect, and as the camera moves away from that starting position, it's going to apply a different amount of movement to each of the parallax effect objects inside of our scene. But each object is going to get a different amount of parallax because they are different distances into the z-axis. So one object might have a -1z and the next might be -2, and then the amount of parallax movement you get is going to differ between them because of that value. Okay, so the next thing we need is this parallax factor. So that's going to be a float parallax factor. And that's going to be set on every frame as well. So this is going to be equal to the absolute value of the distance between the parallax effect object and then the follow target object. So mathf.absolute value, or ABS, the absolute value of, let's call it the distance from target. And we're going to divide that by a clipping plane value, which we'll set up in a minute as well. So the distance from the target is going to be pretty straightforward as well. So that's going to be float distance from target. We'll do the equals arrow sign again to make it calculate on every frame. And that's going to be the parallax effects position. So transform.position minus the follow target transform.position. And both of these are on the z-axis specifically. So we only care about the distance into the background that this parallax effect is going, not the xy positions here. So you know what? It probably makes sense to rename this to be z distance from target. Just make that a little bit clearer. So now for this clipping plane value, I'm just going to paste that in quickly. So it's going to select whether we use the far clipping plane value from the camera or the near clip plane value from the camera based on if the distance from the subject is positive or negative. So if the parallax object is in front of the player, it's going to have a negative value, and then therefore it's going to use the near clip plane. If it's behind the player, it's going to use the far clip plane value. And then we add that to the z position of the camera. And that's the value we feed in down here for the parallax factor. And of course, since I renamed this to be z distance, gotta change the variable there. So before we finish the script, one mistake I made that we've got to fix is when we do the cam move since start, it's multiplied by the parallax factor, not divided by. If you do divide, it's going to look wrong. So make sure you change this into a multiply if you haven't already. And now we can go back to our game view. So make sure that on all three of the backgrounds that you have added in the parallax effect component. So if you don't have any on them, you can just select all three of them, do add component and parallax effect to add them all at once. Now we can drag the main camera onto the camera slot. So just drag that there. If you have all three selected for the backgrounds, then it will add it for all three of them at once as well. So same thing for the player becoming the follow target. Click on each of the backgrounds once to check. And now we need to set the Z positions of these different backgrounds. So when something is further into the background, like the sky, it's going to appear to move faster than the foreground, like the hills, which are closer to the camera. And then the hills, which are much closer to our target, are going to appear to move slower. So move the hills just a little bit past the player. We could do something like negative 0.4 as the Z value. It doesn't need to be a huge amount. And then the clouds, further than that, let's try negative 0.7. And then the sky, the furthest, we can try at a value somewhere around negative 0.95 or negative 1. So now if we go into play mode, you'll be able to move around left and right, and you should see the sky in the background moving the fastest. The clouds move a little bit faster than the ground, and then the ground is moving the least. It's still moving, just not as much as the clouds and the far background. And as you go in the reverse direction, it appears that the sky in the background is now moving the opposite direction to the right. As we move to the left, the sky moves to the right, and vice versa. So that's basically how we can achieve the parallax effect on the background in our 2D platformer game. So in this video, we're going to get into the animations and the animator controller for our player object. So we'll be setting up a walk, idle, and run animation. We're also going to be showing how to flip the player around from left to right, depending on which direction the character is moving. And we'll set up the animator controller so that we can switch between these animations automatically based on the input we're receiving from the player input component. So if you haven't already, switch back to 2D mode in our Unity game. Let's enter the prefab of our player object, and let's add in a new component. So this is going to be the animator component. I'm closing everything else we don't need right now. Add component, animator. So an animator requires a runtime animator controller, which is where we set up all of the animation states and the connections between them for our player's animation. So I'm going to go into Assets, Characters, Player. I'm going to right click in this directory, create, and then go down to Animator Controller. I'll call this Animator Controller AC Player. So click on the player in the prefab hierarchy and set AC Player as the controller for the animator. Now let's open up the animation and animator windows. So go to the top of Unity and choose Window, Animation, Animation again, and that gives us our animation window. For right now, I will press and hold on the name of this window, and I'll put it next to the console at the bottom left. Let's also open up Window again, Animation, Animator, and I guess we can leave this in the default, which is next to Game and Scene. I might move it later by holding it and dragging it and dropping it, but for right now, that should be okay. So when our character is idling, not moving, we want it to play an idle animation, not just show a single frame. So to set that up, we use our animation window to create an animation clip. So to begin animating player, create an animation clip, hit create, and put it in the player directory. So we can see assets, characters, player. We want this animation to have a name. I'm going to call it player_idle, save as type anim for animation. Now you'll see this keyframe sheet where we can set up the animation by putting in frames at different keyframe times for the animation. So by default, there's 60 samples for a second of animation, but pixel art games are not generally going to have animations that change that fast. I'm going to take the samples and change it to 10. So now we have 10 samples for 1 second of playtime. Let's actually take the animation window and I'll put it in the top right next to the inspector so that we can have the project window and the animation open at the same time. So let's go into Art, and then RV Ross Adventurer, individual sprites. And let's find all of the individual sprites for the idle animation. So we come down here to idle 012. So it looks like we actually have 2 versions of idle we can choose from. So I'm going to take frames 0, 1, and 2, and idle 3, which is actually right below idle 2, which is a second version of the animation, and drag all of these frames into the animation window. Just select them all, left click, hold, and drag them. And when you put them at the start here, it's going to automatically add in the property for this animation, sprite. So we're changing the sprite on each update, which is 10 times a second. So we have this animation here. We can also click on the animator window, and you'll see that this has been made the default animation for our character. And if you want to see this animation play, click on Scene View. Notice how I was in Game View on accident before. But in Scene View, you can actually play in the animation window, and you can see these animations go out and play. Now, there's this gizmo, kind of from the player input, that is showing on top of everything. That is in the way. So if you click here in the scene window, the scene view, you can turn down the size of 3D icons. So I'm going to shrink that down quite a bit here so that it's not so in the way. And now we can hit play to watch our idle animation. So if you want, you can actually change the idle animation out to the second one. So I'm going to select all 4 of these frames, and I'll put them at the start here, just swapping the frames out. Now we can hit play, and we can see our second idle animation. So this one, he has the sword out, and the first few ones, he has the sword sheathed. So you might prefer to use the idle too. So let's just go ahead and do that instead. For now, I'll go ahead and swap back to the default idle animations. So let's hit play and make sure that's working. So idling with the sword sheathed. Now we can create the other animations. So let's click on the dropdown for the animation names and choose create new clip. In the same directory, assets, characters, player, let's do player underscore walk. And that's .anim by default. Okay, so with the player walk animation, scroll down in the individual sprites folder, and we should be able to find Adventurer Walk 0 to Adventurer Walk 5. Select them all and drag them into the animation sheet. You can hit play to test the animation here. Make sure it's working nicely. And let's create the run animation as well. So same process, click on the drop down, create new clip, player run, save. Change the samples to 10 for now, and then find Adventurer Run inside of the art assets. So frame 0 for run to frame 5. Drag those in here, hit play to test while you're in scene view, and there we have our run animation. So now let's open up the animator, and we'll work on figuring out how these animations are going to go between each other. So to save you a step in advance, I'm actually going to right click in here and do create substate machine. So especially with a platformer controller, the animation states here can get kind of out of control. So one way to keep things more organized as we add in 10, 20 animations is to group different types of animations based on a state machine, or a substate machine in this case. So make sure on the top right that you're an inspector, and I'm going to take this state machine and I'm going to rename it to be ground states. So anything that has to do with movement on the ground, I'm going to put in the ground states. Attacking will be a separate thing, but if we have these internal substates like idle, walk, and run, which are going to be controlled by if the player is moving or not, then that will be logic controlled inside of this ground states. So we can double click into it and you'll see a substate machine, which looks a lot like the main state machine on the animator, but it's nested inside of it. So now I'm going to take these 3 animations, which are automatically added onto the sheet here, select them, Control C to copy them, double click into ground states, Control V to paste them in, and this is where we'll actually be keeping those animations. So right now I want to make the player idle the default state here. So with entry, right click on it and choose set state machine default state to player idle. Click up here to go back out to the base layer, the main state machine. For the entry point for the main state machine, I also want to make that the ground states. So I'm going to set state machine default state to ground states, and we have to select the actual animation. So I will choose player idle. Now that they've been moved into ground states, we can take these animations and delete them from the sheet here. So everything based on ground movement is going to be controlled inside of here, and it will just make it a lot cleaner to look at in the long run. So let's double click into ground states, and we have player idle, player walk, and player run. Now, how are we going to decide which animation to go between? Well, if our character is moving, then we're not going to be doing player idle. We're either going to be doing player walk or player run. So we can set up transitions between these animation states. So right click on player idle and make a transition to player run. Right click on idle again and make a transition to player walk. So in order to determine which of these transitions are going to be controlled, we need parameters which we can set on our animator controller. So in the animator window, click on parameters, and let's add in a new parameter. This will be Boolean, and I'll call it is moving. So is moving is going to be off by default, which will mean we'll be in player idle. But let's make a transition that when is moving is true, we either transition to player run and player walk. So now on these transitions, let's add a condition. So in the inspector window, conditions, add condition. Is moving is true, then we can move to player run. Click on the transition going to walk, add in, is moving is true. Now, obviously, this means that player idle could go to player run or player walk based on the same condition. So we need an extra condition to make sure that we're actually walking when we should be and running when we should be. So I'll add in a new Boolean, and this will be is running or is running pressed. So on the transition from idle to run, add in the condition and then choose running is equal to true. For transition between idle and walk, add in a new condition, is running is false. So if the player is moving but not running, we will turn into walk. And if the player is running and moving at the same time, then we'll transition to run. Now for these transitions, we also want them to happen instantly with no lag between the animation. So expand settings in the inspector, take the transition duration, set this to 0, and uncheck has exit time. So transition 0 means that it will happen instantly, and has exit time being off means that it can happen at any time during the player idle animation that we transition to run. So that means that we'll switch immediately, which is what we're going to want for most of the animations on our 2D platformer character. So click on the transition going to player walk, uncheck has exit time, transition duration 0. Now we also want to be able to go back to idle when our player is done walking or running. So let's right click on player run, make a transition to player idle, right click on player walk, make a transition to player idle. And the condition here, add a new condition, is going to be is moving is false. And that's for both of them. Is moving is false, turn off has exit time, transition duration 0, go back to the transition for run to idle, and turn off has exit time, and transition duration as well. Now a walk should also be able to turn into a run. So that's going to be depending on if running is set to true, then we transition from walk to run. So right click on player walk, make a transition to player run, click on the transition, turn off exit time, transition duration 0, add a condition, is running is true. Likewise, in reverse, if running is false, then we'll turn from player run to player walk. So click on the transition, turn off has exit time, transition duration 0, add a condition, is running is false. And just go through each of them and make sure that all of the settings are correct. Now, in order for all these animations to be selected correctly, we're going to need to set the animator parameter, and we can do that inside of our player controller script depending on what keys are pressed down. So if we have the move key pressed, then we can do is moving true, and if we have the run key pressed, then we can set is running to true. So click on player, and then find the player controller script, and let's edit that up inside of Visual Studio. You might recall from the first video where we edited the player controller that I already added the isMoving property. So when we set this property, we can also just update the animator controller as well. So if we're not going to use an automatic get or automatic set, then we're going to need a variable inside of our script, which we can make private to store the value. So I'm going to make a private Boolean underscore isMoving lowercase on the I. And this can default to false, since that's what we would expect at the start of the script. And now for our get and set, we'll reference this variable. So for the get, I'm going to add in the curly brackets so that we can add some code. When I hit enter, you can see it already recommends what we should set for the return. So return is moving. So that means that this get value is going to return whatever this variable is set. So that means this public property is going to return the private variable value whenever we call isMovingGet. Okay, now we also need something for the set. So add in extra brackets, and then isMoving is going to be equal to the value we pass into the setter. Looks like we don't need that semicolon there for the get function. But the other thing we want to do here when we set the value is that we also want to set it on the animator component, which we currently don't have reference to. So below rigid body 2D RB, I'm going to do animator and then animator lowercase, and we'll get that component on awake. So animator equals get component of type animator. And now that we have that, whenever our script is running, we can set the parameters on that animator component. So animator dot set Boolean, and then we have to pass in a string name. So for right now, we'll just set this directly. And I believe they called it isMoving, lowercase on the I. And we'll set that to whatever value we just passed into the setter function. Alternatively, you can pass in this value. Effectively, it's going to be the same thing here. So the advantage here is that whenever we set is moving, like down here on move, is that we're also going to be setting the parameter on the animator. So one setter function kind of kills two birds with one stone. So that's going to handle the is moving parameter on the animator, but we want to do one more, which is running. So let's go ahead and create a private Boolean is running, which will of course be false by default. And then we'll create a property to adjust that. So private Boolean is running. For the get, we'll do get return is running. And then for the setter, we'll do set is running equals value. And also animator.setBool is running, lowercase on the I, to the value we pass into this is running function. So the thing is, though, we still don't have a key to actually make the character run. So we have nothing to respond to in our player controller script. So we can set up a key as a action on our player input. So where it's actions, let's double click on the input action asset. And then let's add a new action for our player action map. So click on the plus and then let's say run here. We need a key binding for our keyboard. I will go down to binding and let's check keyboard and mouse controls. For the path, click on the drop down. And the quick way to do it is just to hit listen. And now press the key you want to use for run. For me, that's going to be shift key, or more specifically, the left shift. So I will select left shift keyboard from the list here. And that's all we need to do to set up the action. So now the run action can be controlled with the left shift key on our keyboard. So let's exit out of that and save our import actions. For the events on our player input, let's drop down here, player. We now have the run event, and we can attach a function that takes a callback context to this run. So inside of our script, just like with onMove, I'm going to create public void onRun, import action dot callback context. And what we're going to want to check on the context is, did the button just start getting pressed down? Or in the case where it got released, was it just released? So if context.started, then now we know that run is pressed down. So we can set is running the property to true. And we can do else if, and we can do the second condition for when it gets released, context dot, I believe it's canceled. So if the context is canceled, the button is no longer being pressed down, then is running, which of course is calling our property setter function, which is going to set the value not only on this player controller script, but also on the animator. Now, a little trick, if you want these private Booleans to actually be visible in the inspector so that you can kind of see it more visually, then you can serialize the field. So just like with the public variable, you can see it in the inspector by putting in square brackets, serialize field. And we can copy this down here to the is running as well. So you have to do it with the variable. You can't really serialize the properties to make them display in the inspector. At least not normally. This would be more of the proper way to do it, to serialize the field, not the property. Okay, so now we can go back to our game and take a look at everything. So if I expand player controller, you can see these is moving, is running variables are here. And we need to set the function to call for the run event. So I'm going to click plus, drag player controller down there into run, select from the function dropdown and choose player controller on run. So we should have on move and on run. Interestingly, and that's probably because I edited it on the player instance, not the prefab, but you can see that player move doesn't actually have a function right here. So if I go out to the instance, I can expand events, expand player, and you can see that this is kind of bolded. That means that it exists on this copy of the object, but not on the prefab. So got to be careful about that. We can, of course, click on the top right and do modified component, apply to prefab player, which will take whatever changes we've made here and apply them to the prefab. Just be careful that all the changes are something you actually want on the prefab. So now jumping into the prefab, we can see our events, player, and we have on move, and we have on run. So exit the prefab, click on our player instance, hit play, and let's try moving around and see if is moving gets set here. So you can see in the player controller script it is. If I hold shift, it does get set on is running as well. And you can actually see the animations are changing. So this is walk, and this is run when I hold shift. Now the movement speed is still the same between them, but that's an easy fix. To make sure that these variables are being set, you can also take the animator, drag them down here to the bottom. While you have the active object running, these values are going to be set in real time. You can see which animation is playing in real time. So I hit right, and you can see player walk is playing, and it's looping over and over again. If I hold shift down and I move, you can see it transitions to player run. So we got player run going on there. You can see the parameters being set over here on the left, is moving and is running. So these are synchronized between our animator parameters and the values on our player controller script. So that's exactly what we're looking for there. So let's hit play to go out of play mode. Jump back into our script. So at the top, we had walk speed. So to make our player run faster when we have run pressed down, let's create a run speed. So public float run speed, and I'll set that to 8F. The F, of course, just being for float. And now we just need to have some way of selecting between which walk speed we're going to use. So let's create a property that will use the current values for is moving and is running to determine what speed we should set the current velocity of the player at. So I'm going to call this public float current walk speed, current move speed. And this is going to be this is just going to be a getter function, actually. So rather than getting a variable value, we're going to run a calculation here. So we take the booleans of our script, and we'll use that to return the right walk or run speed, or even idle speed. So if is moving is true, then we also want to check if it's running. So if is running, and I'm just accessing the properties here rather than the variables directly, then we're going to return the run speed, of course. So return run speed, and if it's not running, then it's walking, so else return walk speed. But what if neither of those are true? If neither of those are true, then we're going to want to return 0 because that's the idle speed. So return 0. I could just put a little comment here. Idle speed is 0. So now what I want to do with this is go down to where we update the velocity. So I'm just copy pasting the name of that property. And let's see, where we have fixed update RB velocity is equal to the walk speed on the X. I'm just going to paste in there the current move speed. So depending on whether we're walking or running or idling, that's going to determine our X movement speed. So let's go back out to the game now. Hit play. And now here's our walk speed. If we idle, of course, the speed is nothing. And if I hold shift down, well, there's our run speed. So run, walk, idle. So you can see how this actually is a differing value now. So the last thing we need to do is to flip the player depending on if we're walking to the left or the right. So in our script, what we're going to want to do, whenever we get the movement input, we want to set the facing direction based on if that movement input on the X value is positive or negative. So let's call a new function here. I'll do set facing direction, and I want to pass in the move input in order to determine which direction it's going to face. So I'll hit control period, generate a method right below. There we have our private void set facing direction, taking move input. So what I want to check is if the movement input dot x is greater than 0, then I want to face the right. Else if the movement input dot x is less than 0, I want to face the left. So whenever we update the facing direction, I want to make sure that they're not already facing the right direction. So in this case, I want to see if it's facing left before we force the player to start facing the right, because we're going to be reversing the local scale, and we only want to do that when it's necessary. So as a extra condition to ampersands for and we're going to do exclamation point is facing right. So if it's not already facing the right, in other words, facing the left, then we're going to reverse that to face the right when the movement input is greater than 0. So it should be facing the right. Then down here, and is facing right as one of the conditions for if we should switch it to face the left. So let's generate this as a property. Control period to do that is facing right. And then down here, we can do is facing right is true. And is facing right is false. So we can scroll up to the top and find the is facing right. You don't have to do it this way. You could just put it in the function we called down here, but we have to reverse the local scale to make sure that the character is completely facing the left or completely facing the right. And what I mean by that is any other child components are also going to automatically face the right direction because they inherit the direction from the parent's scale. So let's go up here to the top, create a field variable. Public bool is facing right. And that's going to be equal to true by default because our player faces to the right by default. So as long as that's true, we want this to be true as well. And then let's create our get and set. So for the getter, return is facing right. And then for the setter function, let's add that in as well. A couple extra lines. We'll do is facing right is equal to the value. But then right above that, I want to check if the value is a new value. So if is facing right does not equal value, so as in it's a different value, then what we're going to do is to flip the local scale to make the player face the opposite direction. So that is going to be the transform dot local scale is going to be flipped by doing times equal, and we're going to multiply that by a new vector 2, -1 on the x, 1 on the y. So this means we leave the y scale alone, but we're going to flip the x value on the local scale. So whatever direction it was before, it's going to reverse that direction for all of the components, all of the child game objects on this player. Okay, so now set facing direction is going to take the movement input. It's going to use that to determine which direction it should be facing. And if that does not match the current direction, then we're going to flip the direction. And then in the setter for is facing right, whenever we flip the value, we're also going to flip the scale, making our character face the opposite direction. Okay, so back out in game view, let's hit play, and let's try pressing the left key. And you can see our character flips to the left. If we press right, our character flips to the right as well. Why am I flipping the scale instead of just flipping the sprite using the SpriteRenderer right here? So let me show you an example, and we'll go into this obviously more in future videos, but I'm going to create a child game object. You can see its scale is 1, 1, right? So let's add in a SpriteRenderer for this child game object. And let's just throw in some random sprite here, and we'll offset it by a certain amount. So this is offset to the right. Just imagine this was like our sword hitbox in the future. Okay, so I'm going to hit play. If we had flipped the sprite rather than flipping the direction of the scale, then when I pressed left, our sword hitbox wouldn't flip with the character. But when we flip the scale, now that means we're flipping the location of the sword hitbox. So this is going to make setting up directional based child components much easier because now our positions for those are going to be based on the parent's scale. But if you just flip the parent sprite renderer like this, you can see that doesn't actually flip the hitbox, which would make flipping from this to this a lot more of a pain in the future. So that's basically why we're doing that. I can delete that extra game object for now. So taking a look at the list here, that's pretty much everything I wanted to cover with this part of the course. We have the idle, walk, and shift run animations setting up with an extra action. We can flip the scale, which flips the player, not just the sprite, but also any child game objects. And we have the animator set up to handle all of this logic inside of that ground states substate machine. So now I'd kind of like to talk a little bit about managing strings between your animator and your player controller script. So when you add in parameters here, they're going to have a string name, and that string name needs to match whatever you have set up inside of your scripts. So when you set bool is moving, it has to be exactly like it is in that animator component. Now, you might also be creating a bunch of enemies that have similarly named parameters across your game. And if you keep having to manually type in strings like this every time you use them, it can become really easy to make a typo or for things to kind of go wrong. So what I actually like to do is to create a separate C# script that will store all of the strings I use across my animator components in the game. That way, I only have to check a single place to see if the string is correct. I don't have to dive into each of my game objects. I just type once and forget about it. And then whenever we reference those strings in places like the player controller script, we're just referencing a variable. So that's guaranteed to link back to the player animation string script. So inside of Visual Studio, I'm going to right click on our scripts folder in the project and add in a new C# script. For the name, I will call this animation strings and hit add. Let's get rid of the namespace and the extra curly bracket there. So now that we have this class set up, I just want to create a bunch of static string variables we can reference across our project. So in player controller, where we have the strings hard-coded in here, I'm going to take the value here, select it, Control X to cut it away, and I'm going to type animation strings dot is moving. So whenever we are talking about if a character is moving or not, we're just going to use this string value. So I'm going to control period to generate a field. And then I'm going to right click on the name of this field, go to definition, and you can see we have a static string. So a static is going to have one instance on our game, which is what we want because we want this variable to be referenced with the same name no matter where we have it. So I'm going to have this value set equal to the isMoving that we had before. So just Control V pasting that in there. And now we have one place to manage this string value across our entire project. So I'm going to do the same thing with isRunning. I'm going to select this. I'm going to cut it away. Animation strings dot is running. Going to control period to generate the field. Going to right click on the name, go to definition, and then that's equals, and just paste it in the is running string. So I think this is helpful if you want to keep your naming consistent between the different characters in your game. Obviously, other characters like a knight enemy might be able to run as well. So using the same variable names for that will help keep your animators organized. So you'll be able to look at one of your animators and you'll know which property responds to which because you kept a consistent naming scheme. Also, if you just keep referencing the string value here, if you have other places on your player controller script you need it, using the same reference to the string value, means that the actual value is going to be the same whenever you reference it. So obviously not required, but I find it to be a pretty clean way of managing strings on your Unity project. So this is where I'm going to be putting all of the future animation strings, and trust me, by the end there will be quite a few. Just from the complexity of a 2D platformer controller, there's a lot of states to manage. So there's going to be a lot of animation strings that need to go into the animator. So in this video, we're going to be talking about how to set up tile sets and then creating ground tiles for our player to stand on. So we'll be creating a palette in Unity, generating tiles from the sprite sheet of the tile set. And then once we have ground, we'll be able to add gravity back in and a capsule collider for our player so that we can collide with the ground. I'll also be adding a composite collider to the tile set. I'll also be adding a composite collider to the tile maps, so that when we walk across those tiles, we should never get stuck on each of the individual tiles. Okay, so to open up the tile palette window so that we can start working on a tile map, we go up to the window menu, go down to 2D, and then open up the tile palette window. So I like to dock this over on the right where we have the inspector. So I'm just going to drag the window right onto the spot, left click, hold, drag, and let go to dock it there. And you can see we have a create new palette button. And then this preview area is going to be where each of the individual tiles show up. And at the top, we have various tools for working on tile maps. So first, I want to locate in my project where I have the tileset PNG image. So if I recall, that would be under FreeCute tileset. And then there is this tileset image. So currently, this has not been split up into individual tiles. So we're going to need to left click on tileset.png in FreeCute tileset, go to the inspector, and we'll see that this tileset is in single sprite mode. We want to change that to multiple and go into the sprite editor. So we'll have to apply the changes since we put it in multiple mode. And now when we open up the sprite editor, looking at it, you can probably imagine that this can be split up into different squares, which is exactly what we're going to be doing. So these are 16 by 16 tiles. And so we need to slice this entire sheet up based on that size. So click on slice, change type to grid by cell size. And for the pixel size, do 16 by 16. And what you should see is these tiles are going to get sliced up perfectly. So we just need to hit slice and apply in order to convert the one image into a whole bunch of different individual images that we can use as our tiles. So you should see tile set 0 through 41 if you expand the tile set. Now in the tile palette, we can create a new palette. So this is a separate Unity asset from the PNG itself, and I'll just create it with a similar name. I'll call it Forest Tileset, since that's basically what we're working on. And everything else, I believe we can leave as the default. So let's go ahead and hit create. And now we'll need a folder in order to store our palettes. So I'm going to go to the assets folder. Let's go into art. And because all of the palettes are actually based off of images, which are going to be in the art folder, I think that this is a good place to put the new folder. And I would just call this palettes. So let's double click into there and hit select folder. So now the palette is stored in the palettes folder, but we're also going to need a folder to store tiles. So in palettes, I'll right click in here and let's do create a folder, and I'll call this tiles. So now I'll double click into the tiles folder, and I want to create another folder so that I can keep all of my tiles separate. So for the forest tiles, I want to go into one folder, but if I add more tile sets in the future, I want to keep those separate in a totally different folder. So just maintaining the project, keeping things organized. Let's right click, create folder, and I'll call this forest tiles or forest tile set, up to you. So now let's go to the free cute tile set folder. Let's find this PNG that has been split up, the tile set, and let's drag this onto the grid. So once you left click, hold, and drag, you should see the white outline of where it's going to be storing everything. If you need, you can unselect it and control middle mouse wheel to zoom out here. That'll make it a little bit more clear exactly where everything's going. And now I can drag the tile set back into here. So you can see that this grid for the tile set can expand to basically any size. So if you want to add multiple images to one tile palette inside of Unity, you can do that. So I'm going to let go of my left click hold, and that is going to give us the prompt to generate tiles into a folder. So let's go to art, palettes, tiles, forest tiles, and select this as the folder. So this will take the image, and for each of the split up squares, it's going to generate a tile asset based on this image inside of our tiles folder. So if I go into forest tiles, you can see the actual .asset files for these tiles. And those are what are being individually referenced here on the tile palette. So now if I have a tile map in my scene, I can use this tile palette window in order to draw onto it. But you can see there's no active tile map, so we can't draw yet. So we have to create a tile map with a grid. So make sure you're in scene view so you can see what you're doing. And let's right click in the hierarchy and create a new, I believe it's 2D object, tile map, and then rectangular. Okay, once you do that, you might be able to kind of see, if you have the tile palette open, that you can draw onto it. But let's make sure we're doing things correctly first. Let's click on the tile map, go to the inspector, and you'll see we have a tile map and a tile map renderer. So we don't have any physics colliders right now, which means that our player would be able to pass straight through it. So just to show the difference, let's go to tile palette, and I'll click on one of these tiles, and we can draw on the grid. So you should see that one square equals one size on the grid. If it looks way too small, then on your inspector for the tileset file, the pixels per unit might not be set to 16. So because it's 16 per unit and it's 16 by 16, that's why we have a 1 by 1 unit square. Anyway, let's, on the tile palette, use the tools. Let's use the brush tool with this square and draw some ground. Just left click and hold, and you can keep dragging it around the screen like that. Control Z to undo, of course. Now in the inspector, we click on the tile map. We can of course see there's no tile map collider. Let's add gravity back in for the player. So I'm gonna jump into the prefab for the player, and where we have the rigid body, let's set the gravity scale to 1 and go back out of the prefab. So now go back out, click on the player. We can see that the gravity scale is still set to 0 here. So this is a custom value overriding the prefab. I'm going to right click on it and revert it to whatever the prefab settings are. So the bold text goes away and the value returns to the prefab's default. Now let's hit play. And once again, we can see we can just fall straight through the ground. The fix is pretty easy. So click on the tile map, add component, type in collider, and we're going to need to look for tile map collider 2D. So you add that into there, but you'll see that each of these tiles have their own collider in a sense, because you can see the border on each edge of the tile. So that can cause some problems as your character kind of walks across it, especially if you're adding forces with it. So what I'm going to do is add collider, and let's do a composite collider. And for the tile map collider, check used by composite, And what you'll see is that all of those lines between the tiles disappears. So now this is actually just one solid collider managed by the composite collider. So in a lot of cases, it'll seem like that doesn't do anything, but having a bunch of colliders between each tiles can cause some issues. So what I'm also going to do is change the rigid body 2D that's added in by this composite collider 2D, and I'm going to change it to static mode. This ground is never going to move, so we don't need it to react to any physics. So let's just close all of those. And if we hit play, our player is still going to fall through the ground. That's because our player does not have a collision shape yet. So let's jump into the prefab for the player. Scroll down to the bottom, add a component, and let's go with a capsule collider 2D. So you might see kind of a circle shape appear around your player. If you scroll down to the capsule collider 2D component, there's this button, Edit Collider. Click on that, and then adjust the size of the collider to whatever you think would be a sensible shape for the player. So I'm just going to pull these sides in. I'm going to pull the top in as well, clicking on those little green dots. I'm going to make it a little small on the player. We might also be using this collider to determine if an enemy hit collides with the player. So you can see this adventurer, he has like a helmet area. Maybe I don't want to make it so that if an attack goes right above his head, that it actually collides with the player. So by reducing the physics collider shape, you can favor the player a little bit more than the enemy. Okay, so now let's go back out, and if we think our shape here is good, we can hit play. And now when our character hits the ground, we should be able to see that it does not pass through the ground because it is now colliding with physics. Now, if you have the capsule collider, and for some reason you still go through the ground, make sure it's not set to is trigger mode. So normally it's a collision shape, but if you turn it into is trigger mode, then it's used more for detecting if something's in the zone, but not actual physics. So if I check is trigger, you can see character falls straight through the ground. So this would be more for determining like a player's hitbox with a sword attack later on. So now that we've verified that the tile map object is working properly, the character is able to collide with it based on physics, we can kind of go crazy with the tile set. So go back to Tile Palette, and you can start drawing up a map using these tiles however you wish. So for these tiles on the left side of this kind of floating platform thing, obviously those are going to be the left side of our main platform. So if you add those down, you'll be able to kind of generate the actual shape of your platform. You can see just by kind of selecting these and painting them on, you can really kind of create different shapes. So it doesn't need to be a copy paste of this own original shape, but you can actually left click, hold, and drag a box around all 9 of these tiles if you do want to create platforms that are just exactly like that. So just left click and I draw all 9 tiles at once. I could do that a couple times even. These green outlines you can kind of see, those are the physics shape for this platform. And there are other tiles here for more niche cases. So if I take this one from up there, you can kind of see I can curve around the ground. If you want to add a bunch of a single tile at once, you can use the filled box tool. U on the keyboard to select it. Then you can left click, hold, and drag a box to add a bunch of tiles. If you also want a tile to not have a physics shape, so the player can actually just walk through it and it's more of a background tile, then what you can do is you can add another tile map to the grid and not have any tile map collider on it. So if I right click on the grid and we do 2D tile map rectangular, I'll rename it to be no collision just so it's obvious. Now we click back on tile map and you can select the active tile map you want to draw onto. So if I don't want any collision, I just click on no collision. And now let's drag in and now let's just fill in some background tiles like this. Now this is also showing on top of the tile map below. So I can change the sorting layer. Maybe I take no collision and I just give it a -1. And now it will show behind anything 0 or higher in the order in layer. Alternatively, you can move stuff to their own sorting layer if you want to add those in. But let's hit play and kind of test. So we can collide with the ground, but if I go over to the right, this no collision layer, those are still tiles, but we're able to walk straight through them. So it definitely appears like they're more of a in the background tile there. Also note that if you have multiple tile map layers like this, you can also kind of combine them. So you can have 2 tiles layering over each other. And wherever there's any transparency on the top tile, the background tile can kind of come through a little bit. So that can make it a little bit more interesting as you're building out your game levels. Okay, so doing a little bit more play testing, you'll see that if I walk over to the edge with the player, that the player actually shows behind the wall sometimes. So I don't want that to be the case. So a quick fix for that would just be to take the order in layer and make sure that that's below the player. But if I want it to be consistent, then I probably actually want to use a different sorting layer. So I'm going to add a new sorting layer for the ground. I'll add it into this list. Let's put it between background and default, and I'm going to call it ground. So now if I click on tile map, I can change the sorting layer to ground, and no collision, also change it to ground. So now this is -1 on ground, still going to show behind the main tile map. I could rename the tile map to be ground as well, just to make it a little bit clearer what that is. If I hit play now, and we walk over to the left, you can see that when the player's coming up against the edge of the wall here, that it's still showing in front, which is probably what we want in most cases. So one last minor problem we want to fix before we exit the video. You can see the parallel background. It looks fine in general, but if we go down on the map, you can see that the background image kind of gets cut off here. So what we can do is just make the background bigger. So I'm going to take BG1 to BG3. Let's go to the inspector, and I'll take this scale and set it to, let's say 4x, 4y. So now that's going to be much, much bigger going downwards. And we can leave it like that for now. I don't think I ever intend for the player to physically go below this point. So let's go ahead and hit play, and we can move downwards. And we'll see that the background still exists here. It's only if we go much further down that the background would fall out of view. So if we walk around, it's generally okay. Got to make sure that there's some background image here on the no collision layer so that we're not seeing green there. But aside from that, so far in testing, it's at least working for the most part. You might notice that if you walk towards a wall while you're falling, that the character doesn't actually fall here. That's something we'll have to adjust in another video by checking if we're on the wall and making sure that we can't just stall the player here, because that doesn't make any sense at all. But aside from that, this should be roughly where you end up in the video. You don't have to copy this exact map, just draw whatever you want using the tile maps. As long as you have working ground and working collisions with the player and the ground, you should be good to go for right now. So this next part is going to add a whole bunch of things to the player controller, and we're going to be working on air states, so the ability to jump and move around in the air. So as our character gets more complicated, it's going to be doing things like touching the ground, touching the walls, which it already does, but we also want to see if it's going to be in the air. So we're going to create a new script component, which can be used across multiple characters, such as enemies as well, which is going to check the directions to see if we are doing things like touching the ground or touching the wall. And then we can use that in our other scripts, such as the player controller, to determine how our movement should work. So first we'll set up a check for checking if we're grounded, which when we check that we're on the ground, we can allow things to happen like a jump action, allowing us to jump into the air, which means we're going to start setting up the air states, working on things like the fall jump animation, depending on if our velocity for y is above or less than 0. And so we'll need to set up a switch where we switch between jump and fall as a animation. So the first thing we're going to be basing this on is our new touching directions script. So at the bottom of the player controller, and let's do this in the prefab, let's add a new component, and I'm going to call this touching space directions. So we'll go down to the bottom of the inspector, do new script. We'll create the script. I'm going to call it touching directions. No space by default. Create and add. And now we can go ahead and open up the script in our editor. So first I'm going to move the script into the scripts folder. So let's go ahead and take care of that. Okay, so in the script, we're going to use the rigid body in order to cast in certain directions to see if the character is grounded, if it's touching the wall, and if it's touching the ceiling as well. So we're going to need reference to the rigid body 2D in order to do that. And that's going to mean that on awake or on start, we should get reference to that. So I'm going to go ahead and do get component rigid body 2D to make sure that we have that referenced in our script. Next, for the casting, to check for the ground, the wall, and the ceiling, I want to do that on void fixed update because this is a physics-based function. So I want to be consistent with anything else to do with movement, collisions, or velocities. So we won't need update, and instead we're using fixed update. So the first thing we're going to want to do is to get the collider that we want to use in order for checking the ground, the wall, and the ceiling for whether the conditions are met for what we would be considered to be touching each of those, which is going to be a cast from that collider in the direction and a certain amount of distance. So we're going to have collider 2D. We could call this the touching collider or touching col. So this is going to specifically be a capsule collider 2D. So I'll call it touching col for collider. Now any kind of collider 2D can do a casting, but with a capsule collider, it is easier to get the results for side and top. But when you have specifically a capsule collider, it's easier to work with the corner cases. So if you have a rectangle, then on the edge of a corner, it could end up saying that you're on the wall and the ceiling, or the ceiling could be mistaken as the wall because that singular point technically could cast to the left as a wall or cast up as the ceiling. So to get around that, using a circle or a capsule collider means that these corners don't exist. And if you cast up, it's going to be using this middle point, or cast left, it's going to be using this middle edge, and so on and so forth. So you should never get a result where it accidentally interprets the wall as the ceiling or the ceiling as the wall, which is potentially going to be important in the long run. So to make the math simpler for us, I'm just using a capsule collider 2D as a base level requirement. So we'll need to get this capsule collider somehow. The quick way is just going to do a void awake and then touching collider equals get component capsule collider 2D. As long as this touching directions component is on the same level as the game object, the player, or the enemy, then this should work fine. You could always make this public and set it manually in the inspector if you need to reference it on a different game object or child game object or anything like that. But this should work just fine for now. So what we need to do with this collider is to cast it in a certain direction to see if we're on the ground and later on the wall and so on and so forth. So if we're casting for the ground direction, that's going to be vector2.down, of course. So to go with this cast, we can also set up a filter to make sure that we are only colliding with the right layers or objects. So let's go up to the top and I'll create a public contact filter 2D, and I'll call this cast filter. So we'll set this up in the inspector, and we can just put this down here as a parameter. So cast filter, and then on this version of cast, we also need a raycast hit results array. So we should only need to create this array once and then let it update on each update call. So let's go ahead and create that up here at the top. So this is going to be a raycast hit 2D array. And let's call this ground hits equals a new raycast hit 2D array. We need to give it a size. I believe that it will automatically resize up if for some reason the number of hits is above this, but we could just use a small number for default, like 5, which means it has space for the first 5 results. But once again, I think it can go and automatically increase. So ground hits as the next parameter. And then the distance is going to be ground distance, which is a float we'll set up at the top. And I'll put that right under the cast filter. So public float ground distance. And this would be in terms of units, I believe. So we don't need it to be very big. It could just be something like 0.05f or something a little smaller than a single pixel. Okay, so this cast function, it's going to store the results in the ground hits array, but it's also going to return an int, which is the number of collisions that this cast detected. So if we're trying to determine if it's on the ground, and this cast filter would check to see if it's on the ground/wall layer, then we can assume that if the number of hits come back greater than 0, that it is in fact touching the ground. So we can just take this and see if it's greater than 0. So I'll add to the end here is greater than 0, which gives us a Boolean. And we could do is ground equals the results of that. So if there's 1 or greater hits from this cast function, then it is on the ground. Otherwise, it's not on the ground. So this is a property we haven't set up. So I'm going to control period, generate property, and we'll fill this in a minute with extra details, a custom setter function at least. Okay, before we get to that, I want to change void update to void fixed update, since I believe that this would be considered a physics function. So it should probably run at the same time as all the other physics functions, like when your rigid body is checking for collisions. I think it's fair to put this in fixed update. So it'll run a certain number of times per second, which I believe defaults to 30 or 50. So back to the property, I want to create a private variable so that we can have a custom get and a custom set function. So private bool underscore is ground lowercase on the I equals, I guess we'll say true by default. Presumably we'd put the character on the ground to start. So I don't think having it set to true by default would cause us any problems. So private bool is grounded. And we'll also rename this to is grounded. The character isn't the ground, it's on the ground. So the get function, gonna set that up really quickly. Curly brackets, and then inside of that, return underscore is grounded. Okay, then we need the setter function. So curly brackets, put a couple lines, And we're going to say is grounded equals value as our default. Now, just like on the player controller, what I also want to do with this, if we go take a look at those set of functions, is that I want to set the animator parameter for the Boolean on the animator. So when we change it on the script, we're also changing it on the animator, which means we're going to need to get a reference to the animator component inside of this as well. So let's add in animator. So below Capsule Collider 2D, let's add in animator. And then on awake, animator equals get component animator. Now we can do animator dot set boolean, and this will be the name of the variable, which we're going to use the animation strings class in order to store that. So animation strings is grounded, and we'll set that to the value we just passed in to the setter function. So let's generate the field is grounded, go back to animation strings, and make sure that this is set to whatever we want to put on the animator. So is grounded, lowercase on the I, just being consistent. And I think we are not going to need the start method, so I'll just get rid of that. So this is where we're at for now. And last thing, so that we can see it in the inspector, I'm going to serialize the field is grounded. So it's a private field, but serialized field makes it so that we can view it in the inspector. And there we can see the field down there at the bottom. So now we'll need to set up the animation parameters and add in the is grounding. Just to show when you don't have the animation parameters set up right, if we hit play and we go to the console, we can see that it will keep telling us that the parameter doesn't exist and that it isn't able to be set because of that reason. So you do at least get good feedback when something's not working. So for parameters, let's add in the Boolean is grounded, and we can hit play and move around, and you'll be able to see that it'll be set depending on whether it's grounded or not. So it's set both in the touching directions script and out here. So let's walk off the edge, and you can see is grounded is not set to true anymore. So our cast downwards is working. So next let's create our outer state, the air. So let's jump out of the ground states and create a air states. So right click, create substate machine, left click on it, and I will call this air states. So we're going to need animations to go along with this. So I'm going to go out to project, and let's open the animation window, click on player, and then let's click the drop down for the animations, create new clip under characters player. We want player jump.anim. So save that, samples to 10. Let's open up the art, RV Ross Adventurer, individual sprites, and let's find the jump animations. So we have 4 frames here. I'm going to select them all and put them in here. So if we hit play, we have a jump animation. Now this should not loop in our project. This should be more of like a one-time animation. And then for the remainder of the frames, while character's jumping, we can just have it stuck here at this frame. So if we find the animation in the players folder, you can left click on it, jump, and then go to the inspector and turn off loop time so it will not loop. Let's create another animation. So create new clip, player, I'll call it rising. So there may be cases where our character gets into the air but didn't actually jump there. Or after the jump animation, you might want it to still be stuck in this player rising state until it starts to reverse direction due to gravity and start falling. So for rising, I'll have 10 frames there. And we'll use the same frame for jump 3. I'll just drop that in there. And so that'll just be like this. Okay, so next let's add in a new clip, and we'll call it player falling.anim. So similar thing, as long as our character is falling y velocity towards the ground, so like a negative y velocity, then we'll be in this falling state. So let's find player fall, if that exists. And this is 2 frames. So let's add that in there, and we can see our falling animation. Okay. So back on the animator, we'll need to take all 3 of these animations and copy them into air states. So let's copy and paste them in. So on the base layer, we can also delete those animations. They're only going to be stuck in air states. And now we need to set up some transitions between our ground states and our air states. So the obvious thing to do here is that if we're not grounded, then we're in the air. So we should transition from is grounded to air states. So I'm going to make the transition here. And let's just say state machine air states in general. So the exact state will be selected, but we're transitioning to the different sub-state machine. So now we can select this transition and add the condition, which is going to be is grounded is false. Likewise, we can go back to ground states, right click, make transition, ground states, state machine, ground states. and then click on the transition, add condition, is grounded is false. So is grounded, false. Okay, now let's jump into ground states. And if we take a look now, there is this incoming when ground states is false that we can transition into here. Take a look at the base layer. We can see that there is this transition coming in, up base layer, down into entry. Now currently it's set is grounded as false. I meant for that to be true actually. So set that true, make sure that back out here that is also set to true. So that can be a way to come in, which is going to default to idle, but we have no way to actually exit this substate machine yet. So what we can do is take each of these three animations and set the condition that if is grounded is false, that we just exit this substate machine, which on the upper layer will allow us to transition into air states. So let's take player idle, make transition to the exit, player walk, transition to the exit, player run, transition to the exit. Now we can click on each of these, turn off has exit time, turn off transition duration to 0, add a condition, is grounded, is set to false. And it's the same thing for all three of them. So has exit time, off, transition duration 0, is grounded, false. And one more time. So is grounded to false. Okay, so now when we're in this state and is grounded is false, we're going to come back up, which is going to transition into air states by default because that's a condition for going from ground states to air states. So now when we get to the air states by default, you can see that it's going to go to our entry point. But what we want our entry point to be is going to be either player rising or player falling. Now, generally, if we got into this substate machine without pressing the jump button, then that would mean the character's walking off a cliff, which would mean we'd be in player falling. But we also want it to immediately be able to switch to player rising if the Y velocity is greater than 0. So let's set up transitions between player falling and player rising. Make transition to player rising, make transition to player falling. And we'll take the has exit time off, transition duration 0, and add in a new condition. So for both of those, has exit time, transition duration 0. So for the condition, let's add in a float, Y velocity, and we'll see if that is greater or less than 0. So player falling to rising, add condition, Y velocity is greater than 0 because that's going to be rising. And then on the flip side, Y velocity is less than 0 for playing rising down to player falling. Okay, now we need to set up this parameter inside of our scripts. So I'm going to go back to our script project, open up animation strings. Let's just type in the string for the Y velocity. So internal static string, Y velocity, and we'll call that Y velocity over here as well. Then we can use this in our scripts. So the place that makes most sense to set the Y velocity is going to be our player controller. So in player controller, whenever we update the velocity down here, I just want to do animator.setFloat animation strings.y velocity, and we'll take the RB Y velocity, RB velocity Y, not X. And then that should be what we need for that. So as long as our player controller is updating, the animator should get this value and be able to switch between falling and rising. Okay, so let's test things so far. Let's see if we can get between ground and air. So we can see we do have ground and air, but when is grounded is set, we're not exiting the air tree. So it kind of works, but not exactly. So we need a way to exit the air states now, of course, similar to how we needed to exit the ground states. So that's just going to be the same thing in reverse. Player rising, player falling, we can make the transition to the exit. When is grounded is set to true. So is grounded true. Down here, is grounded true. Make sure you turn off has exit time and transition duration to 0. Has exit time, transition duration 0. Okay, now let's hit play. And you should be able to see that we can end up on that ground state. But if we walk off the cliff, we can also get to the air states. So for falling, that's working perfectly. Okay, now we need a jump button, which would allow our player to jump into the air, switch to the air states, and it's going to set up some kind of trigger to make that transition between our ground and our air state. So if we click on player, let's go to the player input component, double click on the actions, and for player, let's add in a jump key. So add action, I'll call this jump. For the binding, let's set a binding. So click over here, listen, put in whatever key you want jump to be. So that could be spacebar, I suppose, for now. You can always change it later. And I'll use this in control scheme, keyboard and mouse, of course. So right now I'm only setting it up for keyboard and mouse. You can add extra button presses for gamepads and so on and so forth if you want to. So let's hit the X, save the changes. Now we're going to have a new event in player, which is going to be jump. So we need to create a function to run when jump is triggered that takes a callback context. So in our player controller, let's create something like public void on jump, import action, callback context. And what we care about is when we first press down the button. So if context.started, then we're going to want to set the jump trigger. Now there's a couple extra conditions I want to check here. I don't want to be able to just jump while I'm in the air, or maybe you do want to add in an aerial double jump later on, but not for now. If it's started, we also want to make sure that the character's on the ground for our normal jump at least. So we have that component touching directions, which we could use to reference if the character's on the ground or not. So let's reference that up at the top. I'll put in touching directions and touching directions lowercase. And then I'll call the field touching directions lowercase. Let's make sure that we get this on awake. So scrolling down to the on awake, touching directions equals get component touching directions. We might also want to add this up to the required component since it looks like our player is going to be dependent on that component. So comma type of touching directions. So now to set up a player component, we have to have both of those in advance. And one more end parentheses. Kind of just clear up the start and update methods. We don't need them yet. And now we'll come down here to on jump. So we want to add in the extra condition. Touching directions dot is grounded. So another condition we're going to want to check later on when our character can actually take damage and die is going to be that it's also alive. So if our character's on the ground but not living, then we also don't want to allow it to just jump randomly if we press the key for that. So for right now, I'll just add a to do and say check if alive as well. But we'll worry about that later on when we have a damageable character component. So for right now, just if it's touching the ground, then that's good enough. And we're going to set the trigger for the jump. So for right now, let's set a trigger on the animator so that we can transition into the jump animation. So animator.set trigger. And let's do animation strings, and I'll call this jump. And because it's a trigger, we don't need to set it true or false. It's either the trigger is set or it's not set. So let's add in this field on the animation strings, double click into it, and I will just call this jump. Now the other thing I'm going to do is I'm going to set the Y velocity of the character straight inside of the script. So this is going to change the animation, but for the physics, let's just change it inside of this class itself, since the player controller is about the movement of the player. So rb.velocity is going to be equal to a new vector2, and that's going to be whatever the x velocity is, rb.velocity.x. But the y velocity, we're going to change that into our jump speed. So we'll call that jump impulse. Since this is kind of a one-time force, it happens instantly, so it's an impulse, not a force. And I'm going to control period, generate the field. Let's right click, go to the definition. Also cut this and move it to the top. I want this to be a public float, not a private one, because I want to be able to set the jump impulse in the inspector. So let's just give it an arbitrary value like 10 for now. So this will mean that we're setting the y velocity to 10, and the rigid body will handle decreasing that when ever the gravity updates. So now we need to take this jump trigger and use that to move into the jump animation. So let's go back to the platformer. Let's add in a trigger with the same name as our string, jump. Click on ground states, and let's add in another transition out of the ground states. So I'm going to right click on player idle to exit, player walk to exit, and player run to exit. Let's click on each of them, and you'll see that there's a list of transitions. So we have the original if grounded is false. But let's do one for when jump is triggered. So jump as the trigger has exit time off, transition duration 0. And we do that for all three of them. So condition jump has exit time, transition duration 0, and player run turn off has exit time off, transition duration 0, condition jump. We'll go back out to the main states and create a transition for going from ground states to air states. Now this is going to be a little different because we want to go straight into the jump animation, which will return to rising when jump is done. So from ground states, right click, make transition to air states. Now this time select the specific state. States, player jump. And if we click out on here, that's going to be the condition if jump is set. Then we go straight into jump. Okay, so now we can see if we jump into air states that we have two separate transitions here. One where we go into jump and the other where we go to the entry, which defaults us to falling. So after the jump animation is done, we want to transition into rising because that's the default idling state after the jump animation is done playing. So right click on player jump, go to player rising, click on the animation. Has exit time is going to be checked this time, and we want exit time at 1, transition duration of 0. So once the player jump animation is completely done, we're going to immediately change into the player rising state, and we don't need any conditions for that because this should happen automatically. Okay, now let's go ahead and hit play and see where we're at. So I'm going to hit space for the jump, and we don't get any reaction there because we haven't set the Unity event. So let's exit out and go into the prefab for the player. Find the events under player input, player, add one for jump, and then let's drag player into the box. From the list of dropdown, find the player controller component and do on jump. Okay, now let's hit play and let's see if space works. So we have our space, and note how the jump plays once, then we're in the rising state until our velocity changes towards the ground. And once that happens, we go to our falling loop. So as you can see, our jump sequence is now executing correctly. And we can still walk and run on the ground. If we fall off, we immediately end up in the falling state. But if we jump, we do jump to rising and then eventually to falling when the velocity is at the right moment. If you go back out to the main scene and click on the player, then you can see these values changing on the parameter for the animator on the player in real time. So you can get an idea of exactly what's happening just watching these. So as you can see, a lot of the movement of our player is already basically working at this point. But one thing that we do have a problem still is that if we try to move while we're at the wall, it's going to stop our falling. So what we need to do is when the character's at the wall, we stop our left-right movement from actually executing. So back in the scripts, let's jump into touching directions and go to the bottom. So we're going to set up something very similar here for is on wall or is on ceiling. So let's set up some properties. Is on wall, and that'll be equal to a cast. We'll also do is on ceiling, which will be equal to a different cast. So we're going to do touching collider dot cast, and we need a direction for the wall. So the wall could be on the left if we're facing the left, but it could also be on the right if we're facing the right. So this is going to be some kind of calculation. We'll do wall check direction here, and we'll figure that out in a minute. Cast filter is going to be the same. We'll do wall hits, which is going to be an array of raycast hit 2D, just like with ground hits. And we'll do wall check distance. And we'll make sure that this returns at least one result in order to be considered on the wall. So we can just copy paste this down here for is on ceiling. Wall check direction is going to change to vector2.up since ceilings are up. And then we'll change wall hits to ceiling hits. And wall check distance to ceiling distance. Maybe I'll rename wall check distance to wall distance as well. No need for it to be longer than necessary. So now we need to set these up. Let's start by generating the properties. So I'm going to go up here. We have is grounded, and basically is on wall and is on ceiling are going to be the same thing. So I'm going to copy paste all of this twice. So let's do private boolean underscore is on wall. The property name is on wall. For the return, we do underscore is on wall. For set, we do is on wall equals value. And then for the Boolean that we set on the parameter, we're going to do is on wall, an animation string we haven't set up yet. So let's repeat the process for is on ceiling. Underscore is on ceiling. So the property name is on ceiling, capital on the I. We return is on ceiling for the getter. And we set is on ceiling with the value. And then the Boolean we're setting on the animator parameter is on ceiling. So now let's select these errors and do control period, generate the field on the animation script. Come down here, control period, generate variable is on ceiling. And then that should clear up our error messages there. You can see down here at the bottom that these are set to. So on animation strings, we just need to give them a value. So we can just use the name of the string here, is on wall and is on ceiling. Okay, so that takes care of that. While we're at it, let's actually add those parameters into the animator parameters list. So on the player, let's go to the prefab. I'll add the Boolean, and then we'll have, let's just copy paste the string. So is on wall, and then add another Boolean. Let's copy paste the string, is on ceiling. Oh, we can also move them around so that, you know, it's kind of organized better. So is on ground, is on wall, and then is on ceiling will be a sequence here. Okay, so for the wall check direction, let's generate that field up at the top. And this is going to be a vector too. So what I'm going to do for this is the equals arrow thing, where we are going to set the property. So because for this game, we're using the local scale to flip to the left, we're going to check if the local scale is greater than 0 or less than 0, and use that for the wall check direction. So let's do GameObject.transform.localScale.x is greater than 0, question mark. So we're checking the true false statement. If this is true, then we expect that we're facing the right. So we will put vector2.right as the direction. Otherwise, if it's false, then we do vector2.left. So this will just keep itself updated, and we'll use that for our cast direction down here. So now we need the arrays for wall hits and ceiling hits. Go find the first array. I'm just going to duplicate this a couple times. So wall hits, ceiling hits. We'll just have those stored. Yep. Okay. Make sure that's lowercase on the ceiling. And then we need the wall distance and the ceiling distance. So once again, very simple. We could just do out the top public float wall distance. So for the wall distance in my demo project, I'm a little bit more strict with this by default. So I'll put it as 0.2f. So close to or touching the wall. And then we'll have public float ceiling distance, and we'll default that to 0.05f by default. And now on the animator, we should be able to have is on ceiling, is on wall, and use that to determine which state our character should be in. Once again, because this is separate from the player controller, we can just use this for our enemies as well. So super handy. But what we actually need the is on wall for is to stop the player from moving. So on the player controller, we already know we have reference to the touching directions component. So we can do and we'll do touching directions is on wall as a false statement. Then we'll be able to run or walk. So if the character is on the wall, then we can't run or walk, which is going to default us back to idle as our base speed. So let's go back out to our base scene, hit play, click on the player. Let's jump at the wall, and we'll see is on wall set to true. And therefore, we can no longer hug the wall to stop our character from falling. You'll notice is on wall set both in the touching directions script, but also on the animator parameter. Now, just as a FYI, if you wanted your character to be able to do wall jumps, then using this is on wall check would be a great way to do it as well. Well, maybe you could stop the player's movement completely when it's on the wall, rather than allowing it to fall. And then you could do a jump if the character is on the wall. And maybe that jump pushes it off of the wall instead of a straight up jump. So that is almost it for the basic movement of our character. One thing that we might not like is that while we're in the air, our character can still move in exactly the same way as on the ground. So if we hold shift down, we can air run as well, which is a little bit weird. I mean, it kind of works. But if you want to be able to set up custom speeds for the air as well, then we can just use is on grounded to check if we're in the air, and then set another speed as a float on our player controller. So let's go into the player controller and do public float, and I guess I could call it airwalk speed. And I'll set this to something a bit lower than the ground speed. It's like 3F. Don't want to give too much control to the character's movement when they're in the air. And then let's go into our move speed calculation, and let's add another check. So if touching directions is grounded, then we're going to take all of this old stuff and move that in there. But otherwise, we'll do air state checks, and we'll do if is moving and is touching directions dot on wall. So there would be a few ways of setting up the logic. For now, I guess, since the conditions are the same for whether we're on the air or the ground, we only want to move if we're not touching the wall, but we are moving. Then we can add another if. So we'll do if touching directions is grounded, then we can check for these. So I'll just paste those in. Else, air move, And we can just do return air walk speed. So there won't be any running in the air. We'll only be able to move at this slower rate. But that might be more appropriate for our character. But feel free to customize your character's movement however you wish specifically. Let's go back out to game mode. We'll see that we have the air walk speed. Hit play. And let's jump into the air and see if we can run. So I'll hold shift down. So is running is checked, but it doesn't matter because we're in the air. So we can only run on the ground. As soon as we get into the air, we only have that slower air move. If you want it to be a little faster, feel free to bump up the number. But that's pretty much it. So we have the basic ground and air movement for our player working. We can switch between our jump states. We have airwalk speed, ground speed, run speed, and all of the states seem to be transitioning good. So if you got to this point, we're already well on our way to creating our platformer character. So next we need to build the attack animation for our character, which is going to include making the animation itself, making sure that the animator can play that animation when we have an attack triggering event actually happen in our game. And we'll be creating a state machine behavior script, which is a special script that attaches to not a player game object, but rather the animation state itself in the animator. So if we take a look at the animator, any animation state can have a behavior added in. And that's what the state machine behaviors are referring to. So we'll be creating a force lock behavior, which will make it so that when we're in an attacking state, the player will not be able to move its character around. So the first thing we need to do, of course, like with every other animation, is to create the animation clip in the animation component. So jump into the player prefab, open up animation, and then click on the drop down and create a new clip. We're going to create it in characters player. I'm going to call this player attack 1. So the reason this one has a 1 attached to it is that eventually we'll have a sequence of 3 animations where we can have 3 separate attacks in sequence, which will have a sword swing and then 2 more sword swings to follow it up. So player attack 1 is the animation name. Save it, and I'll change the samples to 10. Now let's find in our RV Ross Adventurer pack the animations we want to use. So I scroll up to where we have attack 1, and I'm going to select all of the animations that have that name. So that's attack 100 to attack 104. So 5 frames. Put that in there, hit play, and then we can see our animation play. So I do want to note that this animation is not going to loop. So I'm going to click on characters player, and we're going to take that animation, go to the inspector, and turn off loop time. Now we need to jump into the animator, go back to the base layer, and we're going to take this player attack 1 and move it into a new substate machine. So I'm going to right click, copy it, and then on the graph, I'm going to right click, create substate machine. Click on the substate machine, go to the inspector, and let's call this ground attack. I'll delete player attack 1 from the graph, go into ground attack, and Control V to paste the copied clip in. So with this ground attack substate machine, we're only going to be able to transition to it if we're from the ground state. Otherwise, we would have an air attack. So ground states is going to be able to transition to ground attack when our attack trigger is set. So I'm going to right click on ground states, make transition, ground attack, and let's go straight into the ground attack state machine. So I'm going to right click on ground states, make transition into ground attack, and let's choose state machine, ground attack. So we'll let the state machine figure out what the default state should be. And then ground attack can make a transition back to ground states, state machine, ground states. This won't have any requirements. We simply need to have some exit from ground attack and we'll automatically go back to ground states. So now to create the trigger from ground states to ground attack, let's click on add trigger. And I will call this the attack trigger, all lowercase. And we'll add that as a condition. So let's go up to attack. True. Now I also want to be able to exit the ground state when attack is made. So I'm going to double click into ground states and let's add a new transition from player idle, player run, and player walk towards the exit. So right click make transition for each of these. Then click on the stack of transitions, add the condition, do attack, turn off has exit time, set the transition duration to 0, and do that for each of them. So attack, has exit time, transition duration 0, and attack as the trigger. So let's go back out to our main scene and we'll see the player input component once again. We'll need to create that attack trigger if one doesn't already exist. But if we take a look at events and player, you'll see that I already set up attack at the beginning of our tutorial. So let's go to actions and double click import player actions and make sure that you have an attack or fire action, whatever you want to call it. You just need a attack button to use. In this case, the default button, let's see, is left mouse. So that's what we'll be pressing in order to make our sword swing. Feel free to change it to any key you want. Now we need to create the function and add it to our attack event. So I'm going to open up player controller, edit script. Let's go down to the bottom and add in public void on attack, import action, dot callback context. So we'll do if context started. We don't need to check for ground because the same trigger will be used for air attacks as well. And we'll do animator dot set trigger, and let's say animation strings dot attack. So now we just need to generate that field, right click, go to definition, equals, and then I'm going to type in the string name of attack here. So that'll be our attack trigger string. Now, if we want to be more specific about what these strings are being used for, we could rename it across our project to be jump trigger and jump attack. I think that's going to make some sense here. So I'm going to right click and do rename, and then I'm going to change it to jump trigger and hit apply. I'm going to right click on attack and then do rename attack trigger and hit apply. And with this method of refactoring, wherever we had the string referenced, it's just going to update the variable name here. But the string that it's pointing to here remains the same, so we don't need to update our animator controller. So now that we have the function created, go back out to the main scene, and we need to add it to our player input events. Going to make sure to do that in the prefab, and then click on events, player, add one for attack. Let's drag the player game object here, and then select the script, so player controller on attack. And now that's linked up. So let's exit the prefab, hit play on the scene, and see if we can get left click to trigger our attack. So left click, and there's our animation. Now you can see that after the animation is done, it just freezes in place. It should be exiting the state. So let's exit the play mode, go to base layer, go into ground attack, and then player attack 1. I'm going to right click, make a transition to the exit, click on the transition. This is going to have an exit time, and it's going to be at exit time 1, which means that when the attack animation is done, transition duration 0. So if we attack and we haven't attacked again to move into player attack 2 or player attack 3 state, then at the end of this attack animation, there's no further import, so we just return to our main ground state loop. Later on, we'll have player attack 2, which if we have the trigger set again, we can jump into that and then return if we click no further buttons. But this should be good for now. So let's go ahead and hit play. I'm going to left click to attack, and you can see that when our attack is done, the animation returns back to our ground states and loops through player idle. So we have a sword attack. Now it won't do anything, and currently we're able to walk while swinging the sword. Now, being able to move while attacking could be a pretty OP way to build your character, but visually, I don't think it makes all that much sense. So we want to lock the player's movement when we're attacking so that we can no longer move. So to do that, let's create a behavior that we can attach to our player attack state machine. So go back to base layer, double click on ground attack, and let's add it to the substate machine, not to individual attacks. You could add it to every single attack if you want, but if we add it at the state machine level, then while we're in any of these attack states, it's going to lock our movement. If we add it at the individual animations, then we can lock it on a one-by-one basis. So it should be relatively easy to adapt to your specific needs. So let's go ahead and create our behavior. So what I want this behavior to do specifically is to set a Boolean on our animator, which we can also reference from our other scripts, and we'll check to see if the player's movement has been locked due to the state machine. So we can create a more generic script for this than saying something like lock player movement. So I'm going to want to click add behavior, make sure that player attack 1 is not selected, and then choose set Boolean behavior. So we'll use this to set true false values on our animator parameters when we're inside a state machine, or you could also use it when you're inside a specific state. So new script, create an add, and let's go ahead and open it up for editing. So being that these are special scripts, state machine behaviors, I'm going to right click in the scripts folder and create a new folder. I'm just going to call this state machine to organize all of our state machine behavior scripts, and I'll drag set bool behavior into it. So you can see there's a bunch of commented out methods for this class, and these allow you to change different parts of your game object or animator at the points in time that are relevant to the animation switching. So down here at the bottom, what we want is on state machine enter or on state machine exit. That's going to refer to anytime we come in here to the ground attack state machine or anytime we leave it. So you could also attach it at the base layer for enter or exit if you wanted to, but we want it nested down one level. So only when we're doing a ground attack are we going to use the set bool behavior. So we want to uncomment override public void on state machine enter, and on state machine exit. If you wanted to adjust something on individual states, then you could use on state enter or on state exit instead. That would be referring to something like player attack 1 here. So inside of these functions, you can see we can get the animator component as the parameter, which makes it really easy to set a Boolean value. So we can just do animator.set Boolean, and then we need the name of the Booleans. So let's do animation strings dot, I'll just call it can move. And then we need a true false value. So I could call this value on enter, and then animator.setBool animation strings. So in onStateMachine enter, we can use the animator component to set a value pretty easily. So animator dot, let's say, set Boolean, and we're going to need a Boolean name to set. So I'll just put in bool name here, and then the Boolean value, we can say value on enter, and then we'll have something very similar on exit. So animator.setBool, bool name, value on exit. So let's create those parameters up at the top. So public string bool name, and then we'll have public bool value on enter, value on exit. I also want one more Boolean here, which I'm going to call update on state machine. So if I take this value down here, and let's do if update on state machine. So do that for both the on state machine enter and on state machine exit. Then these Booleans are only going to change if we're actually updating on state machine. So you might see where I'm going with this. We can actually use the same script for both on state enter and on state exit as well by just kind of duplicating the code. So let's uncomment up here. I'll leave on state update commented out because I don't want to change anything on every single frame that the animation is updating. We only care about on enter and on exit. So update on state, not state machine, then we'll do something. And likewise on state exit as well. So let's do value here, value here. So just copy and pasting those up there. We can put in public bool update on state up here. So everything will default to false, which means nothing's going to happen until we set up our custom values on the inspector of the state machine. But we can take this behavior and we can use it basically anywhere across our animators now that we need to set a specific Boolean parameter. Whether that's going to be the can move variable, like we're going to set up now, or something else entirely. So coming out back here to the state machine, you can see our script up here. So I'm going to put can move for the Boolean name, and I'm going to add a new Boolean called can move here. So this is the parameter we're going to set. We want to set it when we enter the state machine, not the state. So I'm going to check update on state machine. The value on state machine we want is that it's going to be false, and on exit we want it to be true. So let's also check can move to be true so that when our character starts moving at the start of the script, we can move until we enter something like the ground attack state. We don't want to disable the player's movement. So let's take this string and add it to animation string so we can use it across all of our regular scripts. So I'm going to copy paste can move. Let's go into animation strings, internal static string, can move equals, and we'll do can move. Now we want to check this value on the animator controller for our player controller. So let's use another property to do that. This property will only reference whatever value is set on the animator controller. So let's do public Boolean can move. We'll have a get, and that's going to return animator.getBool, and we'll do animation strings.canMove, and that's all we need there. So what we want to do now that we have access to whether the player is allowed to move or not is we want to limit our movement. So we can lock our movement in a couple places, one of which is going to be our current move speed. Then what we can do is we take all of this and wrap it in a if can move. So if can move, then we'll do all of this. Otherwise, I want another return 0. So we'll say movement locked as the comment. Now, another place I might want to do this is down here for jump. So down here on jump, we're already checking for the jump button to be pressed and if we're on the ground. But we might also want to prevent the player from being able to jump if we're in a state where it's impossible to move. So I'll do and can move here as well, just as another check. So we want to make sure that we're able to move before we allow the player to jump. I think that just makes sense. You can adjust things how you want for your final controller. So now let's go back out to our main scene, click on the player so that we can watch the parameters. I'm going to hit play. You can see that can move is set to true by default. whatever we're doing, jumping, walking around, on the wall, can move is still true. But if we press left click, can move is set to false. So if I swing my sword and try to move, you can see that can move prevents me from being able to move because we're using that parameter inside of our player controller script. So now a player that is attacking cannot move. And as we add player attack 2, player attack 3, that will also apply. So we have our basic attack animation set up properly, and we limited our player from being able to move while it's attacking. So in this video, we're going to be creating a night enemy for our game, which means we're going to start off with a game object and a new sprite renderer. We'll be adding all the associated things like an animator with an animator controller. And of course, we're going to take this game object and turn it into a prefab, because for enemies, we're definitely going to want multiple instances of them inside of our game. We'll create a rigid body and set it to dynamic modes. So the knight at least will work pretty similar to the player, where we have collisions with the ground and walls. However, we're going to want to change the layer physics to make sure that our player and enemy don't collide into each other by default. So just like the player will be creating horizontal movement by setting the velocity on the rigid body, we're going to need to check for collisions like the player. So we'll be using the touching directions component again. And that'll basically be the basics for the movement of our knight enemy. And then in the next part, we'll be working on its basic AI a bit. So inside of our scene, you can see that I did make a few changes to the tile map since the last video, just kind of cleaning it up and adding tiles or removing them where it makes sense or doesn't make sense. So this is what my game map looks like, more or less the same, just a few minor changes. So first, to clean things up, I'm going to move the player closer to the ground by default. And now let's add a game object for our knight in the scene. So we could right click and create a new empty, but I'll show you another way to do it. So let's go to the project folder, open up art, look for the free night pack that we downloaded, and I'm going to go with color 1 for our character. Let's do the no outline version, and we're going to work with the PNG sheets. So inside of this folder, we're going to look for the idle animation called _idle. You can see that there's about 10 frames of animation here, so we need to split it up into a multiple mode sprite sheet. So take idle, go to sprite mode, and choose multiple from the drop-down list. Let's go into the sprite editor, hit apply to change it to multiple. And now we need to slice it here by the number of columns. So we can just count the number of frames here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And with that number, we can go to slice, go down to grid by cell count, put in 10 for column, hit slice. Now, if you click on one of these frames, you might notice there's a circle here right in the middle. Can be used for things like sorting. So I actually want to change the pivot point to be more of the center torso area of our knight, just so that it doesn't cause us any problems in the future. So what I can do for one of these frames is just kind of click on the circle and move it into where I think the center point would be, roughly speaking. So you'll see it gets a custom pivot. So let's change the custom pivot values, rounding up to maybe the second decimal. So I will do 0.47. And then for the Y, let's do 0.23. So I want to take these numbers and I want to apply them to all the frames. So I am going to go up to slice again. And then instead of pivot center, let's do custom pivot. Put in 0.47 for the X custom pivot and then 0.23 for the Y. Then hit slice again. And now if we click on each of these frames, you'll see that that pivot point is in the exact location. So depending on how a sprite sheet is done, if there's like a lot of extra gap space, you may need to do this for your characters. For this specific 2D platformer game, it might not matter at all because maybe we just want the player to show in front all the time, so we don't need to worry about Y sorting or anything like we would with a top-down game. But I do think it's a generally good practice to keep your pivot point kind of centered on the character itself and not instead in a random center point that's actually way above our knight character's head. So let's hit apply to the sort. And just remember that when we do more of these animations, slicing up these sprite sheets, that we want to keep this custom pivot value consistent. So just remember to keep applying this as we slice up this knight character. So let's click X. And now we can expand idle. We'll see our 9 frames. Let's just drag idle 0 onto the scene. And you'll immediately see the knight character. So when you let go, a new game object is created and the sprite renderer is included inside of that, already attached with idle 0 as its sprite frame. So that's one way you can quickly bring your characters into the scene and save a couple of steps. Now you'll see that the transform for the knight is up here at that center point for the sprite frame. So that's kind of what I was talking about. When your center point is off center, it can look a little weird and it can mess with the calculations for your character. There is this setting here, sprite sort point. So with our night enemy here on the screen, you might notice that the transform location is a little bit off in its position. So that is going to have the center point for our sprite frame. And remember that the sprite frame center point was above the head. So this shouldn't cause us any direct problems. All we have to do is make sure that the visuals line up. So later we'll create things like a sword hitbox, and we'll just make sure that that's offset down here, possibly to the right, and make sure that the transform on that object lines up with our visuals, rather than necessarily being a direct offset of up here where we have this transform. This is just a result when you have a lot of extra gap space in your sprite frames for the sprite sheet. But once again, this should be totally fine. We just draw the rigid body collider around the visuals, not around the center point for the transform. Okay, so let's quickly rename this and then turn it into a prefab. So I'm going to call this Night Enemy, and let's go into the Assets folder, Characters, Enemies. I'll right click, create a new folder for this enemy. I will call it Night Enemy here too. Enter to get into it. Drag Night Enemy from the game scene hierarchy into the project folder. And there's our prefab. Now let's jump into the prefab. I'm going to click the arrow next to the night in our hierarchy. And let's add a rigid body component. So add component, rigid body 2D. Okay, I'm going to make sure it's in dynamic mode. I'm going to freeze rotation because once again, we don't want the character to rotate like this. And for this character, of course, we're going to need a collider. So I am going to add a capsule collider 2D, expand the capsule collider. And now where we have the circle going around our character, we just need to bring in the sides until it matches our character in a capsule shape. And make sure to bring down the top bit too. So let's zoom in here. So the important bit is to get the bottom of the 2D capsule collider roughly lined up with the pixels on the ground of the character so that when it's walking, it'll line up with the ground. But aside from that, you can probably be a little bit generous with the size of the capsule collider so that it makes an easy hitbox for the player of the game. So favoring the player with a smaller hitbox and then punishing the enemies with a bigger hitbox. Okay, so now we can go back out to the main scene, hit play, and just test that the night character will stand on the ground. We can also try running into the night character, and you can see that we can't push him, but neither can we walk through him. So that's despite it being in dynamic mode rigid body. So that's actually what we would expect for right now. Okay, now let's jump back into the prefab and we're going to create a night script for our night. So I'm going to add a new script. I will just call this night, new script, create an add. So let's open up the script for editing. And just like with the player controller, we'll start off really basic. So I'm going to set up a public float walk speed variable up here at the top to set how fast the knight should move when it's walking. So we'll need to get reference to the rigid body 2D so that we can set the velocity on it. So in the awake method, do RB equals get component rigid body 2D. And then on fixed update, we're going to set the speed of the knight. So void fixed update, and we'll do RB.velocity equals a new vector 2. And that's going to be, for now, we'll say walk speed times vector 2.right. So for right now, it's just going to be walking to the right. And the y velocity is going to be rb.velocity.y. And to get the arrow to go away for the x direction, I'm going to do vector.right.x. So that's just going to be the +1 in the right direction. So if we hit play, we'll watch the knight just walk off the edge. You can see that the gravity is still working on it. So that's good. What we actually want this knight character to do is to walk towards the edge, and when it gets to an edge, to flip around. So we'll need two parts for that. One is going to be a wall check, and then in the next part, I'll also be adding a check for if there is a cliff edge, then we want to stop in reverse direction. So the wall check will be pretty easy, and then once we hit the wall, our knight will just reverse directions automatically. So in our script, we're going to go between walking to the left and walking to the right. So I want to maintain some kind of internal state for our knight that is a knight-specific behavior, where when it walks to the left or it switches to walk to the left, we have certain settings on our knight, and then when it switches to walk to the right, we have certain other settings. So those settings are going to be the local scale on the knight, which is going to determine its facing direction and which direction it makes attacks, and basically anything else that would have to do with the transform on the knight character. So one way that we can easily represent whether it's facing the left or facing the right as a human readable variable would be to create an enum. So I am going to create a public enum walk direction. So this can be one of two directions in our 2D platformer. So that's going to be right and left. So similar to how we were building the player controller where we have properties with getter and setter functions, I want to do the same thing but now with an enum so that when we flip to face the right direction, we can have certain other things set rather than just the enum value, such as the local scale and the transform. So I am going to create a private variable so that we can have a custom setter function on the property. So private walk direction, and this would be underscore walk direction, but then the property public walk direction capital, and that's going to return the walk direction, the variable, and then we need set walk direction equals value. So you can see that the name here conflicts with the name of the enum. So I'm going to take the enum and I'm going to rename it, right click rename, and let's call it walkable direction instead. Then when you hit apply, it will rename all three of these to walkable direction. So for the setter function, I want to add a couple extra lines of code. So I'm going to add the value set below because I want to check what the old value was before we set the new value. So I'm going to check if the current walk direction does not equal the value. Then we need to change some other things because we're flipping the direction. So inside of here, I want to change the local scale on the game object. So GameObject.transform.localScale is going to equal a new vector 2. And the x value will be the current local scale flipped. So GameObject.transform.localScale.x times -1. And then y is going to be to keep the same local scale. So GameObject.transform.localScale.y. So now we can also check the walkable direction specifically. So if the value is equal to walkable direction.right, then I'm going to want to take this and have a vector that we can use for things like controlling the movement direction for the rigid body, or for determining which direction the knight is going to be looking to check for walls. So I can create another field. I'm going to call it walk direction vector. And if the walkable direction is to the right, then we're going to do vector2.right. Else if the value equals walkable direction.left, then we'll do walk direction vector equals vector2.left. And then let's go ahead and generate a field for this. So control period, generate field. And there we have our walk direction vector. So as for checking for the wall direction, because we're still changing the local scale on the game object to flip the character around, you might remember that on the touching directions component as well, we set it up so that basically whatever direction the local scale is facing is already going to set up our wall check direction. So as long as we keep building characters by flipping the local scale when we need to change left to right directions, then it's going to be fine. But we're still going to need to check if we're on the wall using the touching directions component. So we'll need to add a reference to one up here in the script. So touching directions, and then on awake, we want to get reference to that. Touching directions equals get component touching directions. And that's going to mean that we need to add it to our prefab as well. So on the prefab for the knight enemy, add component touching directions. And now switch back to the knight script. Since this script working is dependent on this component being there, I'm going to add require component. Let's do require component type of rigid body 2D. And I'm going to do comma type of touching directions. So now that we have reference to this component, we can go down to where we're setting the RB velocity on the fixed update. And we're going to check if the touching directions is touching the wall. So is on wall. So if the knight is on the wall, then we're going to flip the direction around. However, I also want to add in one more condition here, which is that our knight can only flip the direction while it's on the ground. So if our knight character happens to be falling, I don't want it to reverse its direction mid-air. So we're going to do touching directions dot is grounded needs to be true. So is grounded and is on wall. So both of these conditions need to be true. And then we can flip the direction on our knight. So I'm going to create the new method, control period, and this is going to be relatively straightforward. We're going to check what the current walking direction is. So if walk direction is equal to walkable directions dot right, then we're going to make the walk direction left. So walk direction equals walkable direction dot left. Else if walk direction is already left, then we want to make the walk direction right. But we can also add in an else here, where if for some reason the walkable direction was not set to right or left, which should be impossible because those are the only two options, then we can actually throw a error. So I'm going to do debug.log error, and I'll say current walkable direction is not set to legal values of right or left. Okay, now the other thing we're going to need to change is replacing this vector2.right.x in the velocity set to the current walk direction. So that is going to be our walk direction vector. So walk direction vector.x, because we're only changing the x direction here. Okay, so now out in our gameplay scene, I want to show you one thing that will happen with our touching directions check. Because we have no cast filter, anything that this character could collide with is going to be considered the wall. So we never had that problem with our player because there were no other characters to interact with, only the ground collision. But let's try changing the player's location over to the right of the knight. And when the knight comes over here, it probably is going to flip direction. So let's go ahead and hit play. And you'll see for right now that the knight actually isn't able to move at all. So that's because we haven't attached an animator to the knight, since the touching directions component does set some properties on the animator. So let's go to knight enemy, and let's at least add in an animator component. So add component animator, and then we'll create a knight animator controller. So in the project, characters, enemies, knight enemy, right click in here, create a animator controller. I'll call it AC knight, and then let's add it to the animator component on the knight. So I edited this on the instance, not the prefab. So let's click the three dots, added component, apply to prefab knight. Okay, now when we hit play, we also want to set up the parameters that are necessary for this touching directions component on the animator. So is grounded, is on wall, is on ceiling. So go to the animator, add those in, Boolean, is on wall, is grounded, and then is on ceiling. Okay, now let's hit play and see if that clears up everything. So we can see our knight is on the ground. We have no more console errors. And on the animator, the value is being set properly. But our knight isn't walking at all. So that's probably because our walk direction has not been set by default. So up at the top, let's take the vector2 walk direction vector and default this to vector2.right. So when the script starts, the knight will be walking to the right. Okay, so with the walk direction set, let's go back out to the game. So now in our scene, with the player to the right, we're going to see something interesting happen when our knight hits the player. Let's go ahead and hit play, and you'll see what I mean. So the flipping of the knight works successfully, and when it gets over here to the wall, we can't really see, the knight is going to keep flipping. So it is triggering the flip when his wall is checked, but you can see that the player is actually being treated as the wall itself as well. And that's because the cast filter on the knight is set to filter nothing out. So anything that would be a valid collision is also a valid check for the casts on this touching directions. So what we need to do is we need to set a filter for both the knight and the player, and we should do this when we set up other enemies as well. So for the knight enemy, let's jump into the prefab, expand the cast filter, and for the layer mask, we want to set this to a ground layer, but we don't have a custom layer created yet. So I'm going to go back out. Let's click on the grid and then the ground. And on the drop down for layer, we can add a new layer in. So let's do that. And down here, I will make it layer 6. Let's call it ground. While we're at it, we're also going to need some other layers because we want to check for when something is a player or an enemy. And we also want a hitbox layer for both the player and enemy. So let's do player, enemy, player hitbox, and then enemy hitbox. And those layers will come in handy a little bit later in the course. So for right now, we need to take the ground, so that's grid ground, and we'll change that to ground collision right here. For no collision, I'll just leave that off as default for right now because we don't really need it in collisions. though I don't think it would show up anyway because there's no collider. So let's go to the prefab for the night enemy and then take the layer mask and change it to ground. You also see player enemy, player hitbox, and enemy hitbox show up now. So with this set as the filter, it's going to mean that only collisions on something with the layer mask can cause is grounded, is on wall, or is on ceiling. Let's do the same thing with player now. Jump into the prefab, find the touching directions component, expand the cast filter, and change layer to ground. The other setting we need to check is use layer mask. So that will make it so that the cast filter will use the layer mask of layer mask ground in order to make sure that when it collides with something before we do is on ground true, is on wall, or is on ceiling true, that it has to be on the layer mask ground. So give the same settings to the player prefab as well. Open it up, change the layer mask to ground, and then check use layer mask for the cast filter. Now we can go back out, hit play, and what you'll see happen is that when our knight hits the player, it just keeps pushing forward. So is on wall is obviously not being set to true. So we've solved one problem, but we've ran into another, which is that our characters are able to directly collide with each other. Now, it very much depends on what kind of game you're trying to set up, but in this demo, I am going to make it so that our players and enemies can walk straight through each other. At least by default, they won't be able to push each other off the edge. So I'm going to open up the prefab for player. I'm going to change the layer to player. Now let's go back out. I'm going to click on the knight enemy, into it, and then change the layer to enemy. So to edit the physics settings on the player and enemy layer, let's go up to Edit Project Settings, go down to Physics 2D, scroll down to the bottom, and we'll see our enemy and player layers. So wherever these line up and have a checkbox, we want to uncheck that to disable collisions on that layer. So we don't want enemies to collide with enemies, so I uncheck that. Don't want players and enemies to collide with each other, uncheck that. And don't want players and players to collide with each other. So if you uncheck those three, and we hit close, hit play, and the enemy should be able to walk straight through the player. Also, the player can walk straight through the enemy. So that's what we're looking for. There is one minor thing happening here, though, which is that the knight shows in front of the player sometimes when it's like walking straight onto it. But what I'm going to do is I'm going to take it so that the player is always showing in front on its layers. So let's go into the player prefab and change the sorting in layer to 1. That means that while we're on the default layer, the player will just show on anything that has a default value of default and order in layer 1. So now we hit play, and the knight now walks behind the player. So we're prioritizing the player to show on top of anything else in the game. Really quickly, to show that the wall check is still working, I'm going to take one tile, put it on the ground layer, put it right here, hit play, and this should get a hit when the Collider 2D, the Capsule Collider, is casting forward. So it casts the whole shape of a circle forward, and it's obviously going to hit on this lower part. So this still counts as a wall, and the knight will be stopped there. And of course, the wall over here, as you can still see, is making the knight switch around. So to wrap up this part, I'll just remove that extra tile, hit save on the project, and we're pretty much good to go. I should change this tile there and curve it out there. So in this part, we're going to work a bit more on the knight. First, we're going to set up some animations, including the walk animation and attack animation. We'll create a detection zone script, which will allow us to find the player. And if the player is within our sword swing zone, then we're going to switch to the attack state and start swinging the sword at the player. So this is going to mean that we're going to set up an enemy hitbox for a zone where we can hit the player. The knight will also need its own hit animation and death animation, which will come into play later when our knight has a damageable component. And so we'll be setting up the animator controller in general. So let's start by working on the animations for the knight. I'm going to go to the animation window. Let's create a new animation for the knight. I will call this, we'll go into characters, enemies, knight enemy. So I might call this animation knight_idle for the first one, changing the samples to 10. Let's go into art, free knight, color 1, no outline, PNG sheets. And let's grab the 10 frames for the idle animation. And let's just put them in there. And so when we hit play, we can see our subtle idle animation. Because the knight is always going to be walking, we may not see this animation very much. So the next animation we're going to create is going to be knight run. There's no walk animation inside of the knight package, so we'll just use the run animation instead. So just like with the idle animations, we're going to have to split up the sprite sheet and set the pivot offset. So let's go to the inspector. And first I want to check what it was on idle again. So let's click on one of these frames, and we can see we had the pivot set to 0.47 and 0.23. So I'm just going to use those same numbers when we create our run. So let's click on run, change it to mode multiple on the sprite mode, sprite editor, apply, and let's slice this up. Looks like 10 frames. So I'm going to do slice, grid by cell count, 10, and then we can see our 10 frames are sliced evenly, what we want. Let's go to custom pivot and do 0.47 and then 0.23. And if we hit slice, we should see our pivot is positioned nicely on the middle of the night rather than the middle of the sprite frame. So let's hit apply. And now we can take those 10 frames and bring them into our night run animation. Before we do that, I'm going to change samples to 10. And now let's take the 10 frames of animation and drag them in there and hit play to test it. So there's our run animation. Looking good. Okay, next we need night attack. So create clip, night underscore attack, and do the exact same steps. So up here at the top, we have attack 1. I'm going to go to sprite mode in the inspector, multiple, sprite editor, apply. We have 4 frames. So let's do a slice. It's already in grid by cell count. We just need to change the columns to 4. And the setting for the pivot is set to 0.47, 0.23. So we can slice it. And that should work well for us. So let's hit apply. And we can actually leave this window open for a second because we're going to need to do it for the death and hit animations as well. So click on hit. And this is actually a single frame, so we don't need to put it in sprite mode multiple. But let's take the pivot and set it to custom. 0.47, 0.23, positioned nicely there in the center. Hit apply. Let's find the death animation. And then we do need to make this sprite mode multiple. So change that. Sprite editor, apply. Let's slice the sheet. So it looks like we have 10 frames. So put 10 in, double check to make sure it looks good. And we still have the custom pivot settings, 0.47 and 0.23. So slice, check the pivot. Should be kind of centered on where the night starts, at least at the beginning of its animation. You can see it's pretty good right there. And we can hit apply. So now we can take these sliced sprite sheets and add them to the actual animations. So samples 10 for night attack. Let's get all of the frames, all 4 of them, put them in here. Okay, now let's create a new clip. So we'll have night underscore hit. Let's get the hit frame, pop it in there. Samples, I'll set to 10 just to be consistent. Let's create a new clip, night underscore death.anim. So death animation, 10 frames, bring them all in, and then change the samples to 10. And you can always hit play to test the animations, make sure they look good. So the death animation is not going to loop. The attack animation is not going to loop as well. So we need to grab those animations from the characters folder. Let's go to characters, enemies, night enemy. Take the attack animation, go to the inspector, turn off looping, go to death, turn off looping. And the hit, I think we don't want that to loop as well. Idle and run will loop because those will go for an indefinite period of time. Now let's go to the animator for the night, and we can see all the animation clips have been added in here. So first off, we're going to want to change the entry point to walk. So if I click on entry and do set state machine default state walk, I'm going to just remove the idle animation from the sheet. Although it technically exists there, although the animation is created, we don't actually need it. Attack is going to stay out here, hit will stay out here, and death will stay out here as well. But for walk and run, I'm going to want to bring these into their own internal state. And actually night run is nothing there. We don't have an animation for that. So what we really want is night run as our base animation. So for now, because the night is relatively simplistic, we're just going to have 4 states here. And I won't use any sub-state machines. So we just need to set up the conditions for when each of these things happen. So although we only have 4 animations here, we could still create a sub-state machine in order to kind of prepare for more things we might add in the future. For instance, the night does technically have a second attack, so having an attack sub-state machine might be handy in the long run. So we can right-click on the graph, create a sub-state machine, and I will rename this attack. And then we can take the night attack, copy it, and go into the attack state machine, paste it in, and then we'll edit it from inside of there. So now I will remove attack from the main state machine graph. Likewise, we could take run and create a state machine for it. So I might call this the move state machine. For instance, if the knight was ever allowed to jump or climb walls or anything like that, then having those types of things in a move state machine might make some sense. So I'm going to copy the knight run. I'm going to paste it into the state machine and remove it from the main graph. So before I do that, I need to set the move as the default state machine. So target knight run inside of the move state machine. For knight hit and knight death, I'm going to leave these things separate because I don't anticipate there ever being two hit or death animations, at least for this character. So I'll leave those outside of here instead. So the next thing we need to do is to make a condition where we go from move to attack. And that's going to be different for an enemy than it would be for a player because our enemy isn't going to be pressing buttons down. So it needs to know when to attack. And that is going to be when the player falls inside of its detection zone. So in advance of creating that detection zone script, let's add a Boolean variable. I'm going to call it hasTarget. So we can make the transition from move to attack, state machine attack, when hasTarget is true. So in the conditions, hasTarget is true. And then from attack to move, we can make the transition back to the state machine move directly when hasTarget is false. So hasTarget is going to be false. Inside of attack, let's also make a transition out of here. So transition attack goes to exit, and there won't be a condition for that. It'll just be exit time 1 and transition duration 0. So when the attack is done, at least for now, we can just automatically exit the attack state. And inside of move, we want to make a transition to the exit. So I'm going to right click on knight run, make a transition to the exit. And the condition for that is going to be hasTarget is true. So that's how we leave the state machine. And then the substate machine will transition into attack when hasTarget is true. So we kind of go up 2 levels to enter into the attack substate machine. And this is not going to have an exit time, and the transition duration is 0. So that's for knight run to the exit. So now I want to take this hasTarget string and add it to our animation strings. So I'm going to open that up. Internal static string hasTarget equals hasTarget. Also going to move the knight into our scripts folder. Okay. And now we need our detection zone in order to set hasTarget is true on the animator. So let's go to the prefab for our knight, open it up. I'm going to right click on it and create an empty as a child. So I'm going to add a collider. So you can type in collider and find any kind of collider 2D that you want. A really simple way to do this would just be to use a box collider, which is a rectangle, of course. So we can see our box collider right there. I'm going to offset this child's transform off to the right. So if we put this, let's say 1.5 units to the right, when it's facing the right, it'll be right here. But when the scale on the knight gets reversed because we're facing the opposite direction, it'll appear over here at negative 1.5, since the scale will also apply to these position changes. So when it's facing the right, we look to the right. When we face the left, we look to the left automatically. Now let's also make this box collider bigger because that's not a very big detection radius. So I'm going to hit edit and let's expand it. So I'll bring it all the way down here over to the right, and maybe we say that the field of vision, so to speak, of the knight can go right up to about here where his helmet's at. Can also make it a little bit higher. But maybe we could argue that above that, it would be hard for the knight to see since he's wearing a helmet. So I think this would be a pretty good shape for our detection zone. Now, really important, take isTrigger and turn that on. This is not being used for collisions. This is only for detection. Also, I want to take the layer and I'm going to change it to enemy hitbox. So this enemy hitbox layer is going to be used for detecting or colliding with players specifically. Let's go up to Edit, Project Settings, Physics 2D, and turn everything off for the enemy hitbox, aside from the player. So I'm going to turn off enemy, player hitbox, ground UI, water, ignore raycast, transparent FX, and default. So the only thing an enemy hitbox can detect or collide with is a player. So hit X there, and that's going to help filter out the objects inside of here for our detection zone. Lastly, we need to create a detection zone script, of course. So add component, and I'm just going to call it detection zone, new script, create an add, and let's open it for editing. So our detection zone is going to need to get reference to our collider 2D. So this could be a different type of collider than a box collider, and we don't really need to worry about corner case collisions, we're just detecting if something's inside of the collider. So a collider 2D, any type will work. So I'll just keep it generic like that. And we can just call it collider 2D col. So on awake, we want to find that. So void awake, and we do col equals get component collider 2D. So what I want to do is to maintain a list of the objects that are inside of the detection zone. So let's create and we'll make it a publicly visible list as well. So a public list of collider 2D, and I'll call this detected colliders. And at the start of our script, this will be equal to a new list of collider 2Ds. So we can get rid of start and update. We don't need that. Instead, what we're going to be responding to is void on trigger enter 2D and private void on trigger exit 2D. So when something enters the zone, we want to keep track of it. So detected colliders dot add collision, and then when it leaves the zone, detected colliders dot remove collision. So this should keep track of everything that is inside of the zone and was able to collide with this object, the detection zone object, on the collision layer. So back in the Unity editor, we can expand the detected colliders list. See that this is empty by default, so we should not manually add anything to it. Let's go ahead and hit play. And well, we're looking at the prefab, so it won't show anything. Let's exit the prefab, expand the night enemy, click on the detection zone, hit play, and you'll see that the player actually showed up there for a second. So when the player is in the zone, we can use that information to trigger the attack state inside of our night script. So I'm going to go to night enemy. Up at the top, I'm going to declare a public detection zone, and I could just call this attack zone. And we're going to set this reference directly. And we made it public so that we can set it in the inspector. And what we're going to want to do with this attack zone is check on each update whether there is something inside of the list or not. So down here, we can actually put this on the update function. So I'll get rid of start, and let's move update right up above here, above fixed update. Because this isn't a physics function, we can just let this run as many times as our system is capable of updating, rather than a fixed number of times per second. So we can update a property that will also update the animator component, and I will call this has target equals, and we'll do attack zone dot detected colliders dot count is greater than 0. And we'll just update that on every frame. So let's create the property now. Control period on has target, generate the property. So we have it up here. We'll need a custom setter, so I'm going to need to create a field for it as well. Public bool underscore has target, and that'll be false by default. At the start of the game, we shouldn't generally have a target, and we want to wait till we have it manually set up. So for the get, we'll do return has target, and then for the set, we will do has target equals value. And then we're also going to want to set the same value on the animator, which means we need to get reference to the animator component. So up here at the top, animator, and just like before, we're just going to get this on awake. So animator equals get component animator on awake. Super simple. So now we can do animator dot set boolean, and we'll do animation strings dot has target. And now we need the value, which is value, of course. So let's just even out these lines a little bit nicer. And now that this Boolean is set, we should be able to switch between attack states and movement states like run. Of course, let's also take detection zone and put that in the scripts folder and hit OK. Okay, so now back out on our night enemy. Let's take a look. We have the detection zone, and we should be able to set our has target function. So let's hit play and see if we get the attack to trigger. So we get a null reference exception. So that's because the night enemy does not have the detection zone specified. So I'm going to open up the night enemy. We'll come down to the night script. You can see attack zone is not set. So we need a detection zone. So I'm going to drag the child game object detection zone into that field, and we'll grab the component immediately, and we'll use that for has target. So let's hit play. And now we can see that when the player is in front of the knight will swing at us. So let's move the knight further back in our scene. Also decrease its speed for a second. Let's make the walk speed 1 so that we can kind of get it to trigger a bunch of times. So we have the animation there. Our knight's still walking, and the knight is still able to move while walking. We might be okay with that for the knight. But we do have a problem, which is that if the player walks into a knight swinging the sword that fast, he's definitely going to get hit. So we need to slow down the knight's attack animation in one way or another. So a quick way to do it might be to grab the attack animation state and then change the speed of it to something like 0.5. Now hit play, and you'll see that the sword goes much slower now. We might even want to slow it down to something like 0.33. Walk into it, and you can see that the sword is swinging much slower. So I'm going to put it at 0.5, but what I actually want to do is take the first couple frames of the knight's attack and space them out more so that the charge up of the attack is slower than the final part of the attack. So let's go to animation. With knight selected, go to attack. We can zoom out on the animation sheet, and let's take the first 2 frames and make them 2 frames long. So we have one at 0, 0 and 0, 2, but then the last 2 frames, the sword hit frames, only last 1 frame each. So if we hit play, you'll see that the charge up is now really slow compared to the final bit of the sword attack. So if we hit play, then we'll have quite a bit of time to respond to the knight swinging its sword. So after testing this a few times, I don't think I like the knight being able to slide across the screen while it's attacking. I mean, the player can't, so is it fair for the knight to be able to do that? So what we'll do is let's also add in a can move variable for the knight itself. So when the knight is inside of an attack state, then it won't be able to move. So let's go back out, click on attack, double click into it. And then in the inspector, let's add a behavior. So we have the set Boolean behavior. So add that in. For the Boolean name, can move. And we'll update this on state machine. So the value on enter is going to be false, and the value on exit is going to be true. So that means that while the knight is attacking, it can't move. So now we just need to add the Boolean here to the list of parameters. So can move. So this can move should actually be true by default, since at the start the knight is going to be moving. In advance though, let's go back to the base layer and add a similar Boolean behavior to hit and death so that the knight can't move while it's being hit. So set bool behavior can move, but this time it's update on state because it's just this one single state. It's not a sub-state machine. Value on enter is false and value on exit is true. Then add the behavior for knight death. Can move, update on state, value on enter false, and value on exit true. And that should be enough to have the can move variable properly updated depending on the states. So let's add another property inside of Visual Studio for the knight. So this is just going to be can move. So we can add it right below has target. So public bool can move, and this is just going to be a getter function. So get, and we're going to return animator.getBool. And the parameter we're looking for is animation strings dot can move. And that's going to be a true false. And so when we get can move inside of this script, we're just getting the parameter off of the animator. So we can take this down below to the fixed update. And if we're going to try to move the player, we want to check if can move is allowed. So if can move, then we will set the rigid body velocity. Otherwise, we can set the velocity of the x direction to 0. So equals a new vector 2, and this is going to be 0 rb velocity.y. So now when we hit play, we can walk to the enemy and see that when the enemy is attacking, it stops moving entirely. Now, that might look kind of clunky where it just stops instantly. So what we can do is we can actually have it slow down to 0, but over the course of a few frames. So instead of putting 0 for the RB velocity, we can instead do mathf.lerp, and we're going to take the RB velocity x, the current value, and we're going to move it towards 0 at a speed. So we'll call this the walk stop rate, let's call that. So each time it goes through here, it's going to move it towards 0 at a certain percentage between 0 and 1, 1 being 100%. On each call for this. So I guess that would be per each fixed frame. So I'm going to copy this variable. We'll go up to the top. Let's create a public float for that. Public float walk stop rate. And I'll default this as something like 0.6. So it'll stop pretty fast, and of course we can customize this and mess around with it a little bit. But now it won't stop to 0 instantly, but it will take a couple frames for it to actually go to here. So let's hit play now and test that. So it does seem to stop very, very fast still. So we can test with different numbers. So on the night script, let's take the walk stop rate, and I'm gonna try 0.2, and then let's hit play. Still rather fast. Let's try 0.02. So back in Unity, let's go ahead and hit play and see that basically the enemy is still stopping almost immediately. So let's go to night enemy. So the walk stop rate, I'm going to try 0.05, something much, much slower. Let's try increasing the night speed to 10. So now when we hit play, we can actually see that the knight does have to slide a bit before it can swing the sword. So that's kind of more what we're looking for. So the numbers we want to put on the script might be something a little bit more like 0.05 or 0.02 for the walk stop rate if you want to see a little bit of that slide while the knight is making a sword attack. And the walk speed, of course, we had that originally at 3. So inside of the knight script, I think I'll make the walk stop rate 0.05 and 3 for the walk speed as the base values. So going back to the default script values of walk speed 3, 0.05 walk stop rate, let's hit play. Okay, and we can see there's a little bit of that slide going on. That's probably a lot closer to what we want. So we have the walking. Our knight will take a swing at the player while it's within the zone and continue onwards after it has left the zone. So in this next part, we're going to be creating a damageable component, which will allow a character like the player or the knight enemy to take damage. So we'll need a method which allows us to take damage by a certain amount. And we'll be able to set up a death trigger on the player and the knight. We are going to have to make sure that the death transition cannot transition into itself. We'll talk about more about that in a bit. And we can create a custom state behavior to fade a character out when it reaches the death state. So to start working on our damageable character component, let's open up the player prefab and add a new component to the bottom. So this will be a new custom script. I will call it damageable. And let's hit enter and create an add. So at the start of this script, I'm going to start by creating 2 properties. One is going to be public float max health, which will create a basic getter and setter function for. So get is going to return underscore max health, and then set is going to set that max health variable. So the reason for having a field for the max health property is just so that we can show it in the inspector and edit it for each of our characters. So private float underscore max health. And we're going to add serialized field to this. And then our second property is actually going to set a animator parameter as well. So let's start by creating the field private float underscore health. And we can default this to 100. We can also default the max health to 100 as the automatic value for any damageable character. And then let's create the public property public float health. So our get function is just going to return underscore health. And then the set function is going to take the health and set it to a value. But if the health drops below 0, the character is no longer alive. So if the new health is below 0, we can set a third property, is alive, to false. So let's generate this property as well. Private bool is alive, which is actually going to default to true by default, of course. Will return is alive, and the setter is going to set the is alive field. But we're also going to set the parameter on the animator is alive as a boolean to whatever this is alive value is. So let's get reference to the animator just like other scripts. Animator, and then down here below the properties we'll do void awake. And then animator equals get component animator. So now that we have that, we can do animator set bool, and we'll do animation strings dot is alive, which we haven't created yet. And we'll set that to whatever the new value is. Okay, and let's make that lowercase, so it's just a field, not a property. And let's jump into animation strings. So I accidentally created it as a property. So I'm just going to rename it to be a static string. Is alive equals is alive. Now while we're at it, we should take these animation strings and copy them into our animators for both the knight and the player. So let's click on the player, go to animator, add a boolean, paste in is alive. Let's go back out, find the prefab for the knight, add a parameter, is alive. While we're at it, we can also take the knight and we'll add in the damageable component since it's going to be a damageable character. And there we can see our max health. We should also be able to see our current health, so we have to serialize that field. So let's go back to damageable and make sure that these fields are serialized, both is alive and the health. Okay, next I'm gonna get rid of the start update methods, and let's go ahead and create a new function, public void hit, which is actually going to take a int damage value. So using an integer means there's no decimal points, of course. If you don't want to be able to take decimal point damage for your game, and there's no reason to have, let's say, like 5.5 hit points, you can actually take these fields up here and just make them floats instead, which is what I did in the original. So I'm going to change all of these floats to integers, so we're only going to be dealing with whole numbers. So whenever a character is about to be hit, I want to check if the character is alive before applying damage, so a dead character can't take any more damage. But I also want to check if the character is currently invincible. So I want to do and is not invincible, which we'll set up in a second here. And then we can start by applying the damage. So health minus equals damage. So is invincible. Let's generate that field up here. And what we're going to do is whenever the character gets hit, there'll be a certain period of time where the character cannot be hit again. So by default, this will be false. If we want to see it in the inspector, then we could also serialize it. So to make the character invincible, we simply come down here and set is invincible to true. But currently this would mean that the character will never be able to be hit again. So we'll need to have a timer going so that after a certain amount of time, the character is able to be hit again. So we are actually going to need the update method after all. So we'll do public void update. And if the character is currently invincible, we're going to run the timer. So first we'll check if time since hit is greater than invincibility timer. If that's the case, we'll remove the invincibility. So is invincible equals false. And we'll also set time since hit to 0, which means we're going to reset the timer. So to make the timer increment, we need to do time since hit plus equals time.delta time, which is the time between frames. And now we need to actually generate these fields. So I'm going to generate the variable time since hit. And instead of invincibility timer, let's call it invincibility time. So let's generate that as well. Okay, so these are saying int, but I want to retype those to float. Since you definitely can have a fraction of a second, it definitely makes sense to use float here. So the invincibility time by default, let's say it's something like 0.25 seconds. And then the time since hit is going to start at 0. So this invincibility time, I would want to customize that in the inspector. So let's just make this a public float, invincibility time. And then you can customize how long a character should be able to be invincible between hits for. So that is pretty much setting up the is invincible. So now let's test all of this by seeing if we can make the character die. So I'll take is alive and let's print out a debug value where if is alive is set, we'll print out what value it was set to, which will tell us if the character is registering as dead or alive. So in the update, let's run the hit function and I'll take 10 damage at a time. So pass in 10 as the argument. And if this ran on every frame and was able to actually hit the character, then it would take an incredibly small amount of time for the character to actually die. But with a 0.25 second invincibility time, that should mean 10 hits times 0.25 seconds. So you'd be looking at 2.5 seconds. So we'll see if the character basically dies instantly or in 2.5 seconds. So let's go to the game, out to the main scene. We'll hit play, and let's see how long this takes. So nothing's happening, and there we can see both characters is alive were set to false. So the reason it showed up twice is because it's both the player and the knight enemy, both using the same script with the same settings, so that's why we got two messages. So the last thing we're going to want to do for the video is to be able to transition to the death state for both our player and the knight. So I'm going to take this any state and I'm going to make a transition to knight death. And the condition for this is going to be that is alive is set to false. So for the transition, there'll be no transition duration and no has exit time. So as you can see, is alive is set to false by default. So make sure you check that in the parameters. So let's go ahead back in the game, hit play and test things out. So we're watching the knight enemy and you can see is alive gets set to false and we enter the knight death state. But you can see a major problem here, which is that the animation isn't playing. And the reason for that is that when you have an any state connection to a animation state, is that when you have any state connected to a animation state, is that when you have any state connected to an animation state and those conditions are met, it will keep trying to go to those conditions. So you could use a trigger that the is alive was set to false as a one-time off thing. But because we're using a Boolean here, what we need to do is to go into the settings for this transition and uncheck can transition into self. So once the character is in this death animation, it will only play one. Then it can no longer re-enter the death animation unless you're in a different state at that point. So if we hit play, then you'll see the death animation actually plays now, and the character will be stuck in that death state, which is what we're actually looking for. So now likewise, we'd want to have something very similar added to the player. So I don't believe we've created the death animation for the player. So in the list of animations, we're going to want to create a new clip. So let's do player death, and we'll put it in characters, player, and save it inside of here. So 10 samples per second. We'll go to projects, art, RV Ross Adventurer, individual sprites, and find the die animations. So this is 7 frames. We drag them all in, hit play, and this will be a one-time thing, not a loop. So we got to find the animation and turn off looping. So let's see, player death, inspector, turn off loop. Okay, now back in the animator for the player, we'll see the animation is already added here. So we can do the same thing. Any state, transition to player death. With the transition, turn off the transition duration, turn off can transition to self. And for the condition, we're going to need to choose is alive, is true. And so that should basically give us the same result as with the night. So let's see if they both play. Okay, this animation did not. So also for the player, make sure that you check is alive at the start. Now let's go ahead and hit play. So is alive needs to be false as the condition, and make sure that is alive defaults to true over here. Now let's hit play and see what happens after 2.5 seconds. Okay, so we get the death animation for both characters. That's what we're looking for. Now you can see one problem here, which is that this character is still able to move, even though he's in the death state. So let's take player death, add a behavior, set bool behavior, can move, update on state, value on enter is off. And I'm also going to leave value on exit to off. It should never technically exit the death state, but let's not re-enable it for no reason. And as you can see on night enemy, we already set that up before. So let's hit play one more time and test it. So we're in that state and we can no longer move, but we can swap left and right for our direction. So let's add in one more condition on our player controller script. So let's go to player controller. And let's use one more property. We could add a reference to the damageable component here, or we could just get the property off of the animator. In this case, I'll get the property off of the animator. So public bool is alive, and we'll have a get return animator.getBool animation strings is alive. This way we just don't need to directly depend on the damageable component for the script to work, as long as something's setting the is alive variable. So with this is alive Boolean, we can go down to on move, and we can check if the character is alive before we set is moving to be equal to this and allowing the facing direction to be set. So let's just cut that, paste that in there. So I can also do an else. If the character's not alive, it's not moving. So we'll do is moving is false, just for the sake of completion. So let's do one more quick test inside of the game. So in our normal states, the player can move and flip directions, but when the character is now in the death state, can no longer flip the direction or move. So that's what we're looking for. The last thing for this video is that when one of the enemies dies, that we want to fade it out of the game and then remove its game object. So we can create that as a state behavior that we can throw on any state or a state machine. But generally, we'll just use that with the night death animation. So I'm going to add a new behavior script, and I will call it fade remove behavior. New script, create an add. So we're going to need onState enter and onState update as our override methods. So let's go ahead and uncomment those. So what we're going to do here is we're going to take the color of the SpriteRenderer and we're going to remove its alpha until it reaches 0. And the speed we're going to be doing that is going to be dependent on a timer. When the timer is up, we'll remove the game object from the scene. So up at the top, we're going to need a public float, which is going to be fade time. And I'll default that to, let's say, 0.5 seconds. Since it's public, we can edit it in the inspector if we need to. Then we'll need a private float, and I'll call it time elapsed. Of course, this will default to 0. We'll also need to find the sprite renderer so that we can set the color on this sprite. And let's get the game object obj to remove. So when we enter the state, we want to start the timer. So time elapsed, we will make sure that that is 0. The sprite renderer, we'll get that from the animator's game object. So animator.getComponent sprite renderer. And then obj to remove. I guess we could just do animator.getComponent game object, but a quicker way would probably just be animator.game object. Now on state update, we'll do time elapsed plus equals time.delta time. If the time elapsed is greater than the fade time, then we're going to destroy the object to remove. So something we're going to want to get out of the sprite renderer and cache up here at the start is going to be the starting color. So let's do a color start color. And once we have reference to the sprite renderer, we can get that from the sprite renderer. So start color equals sprite renderer dot color. So on every update, we want to update the sprite renderer's color, removing the alpha as we approach a 0 alpha or complete invisibility. And then that's when we remove the game object. So we want to do sprite renderer dot color. It's going to be equal to a new color, which is going to be start color dot red or R, comma, start color dot G for green, start color dot B for blue, as the RGB values, but then the fourth value, alpha, is going to be a calculation. So I'll create a variable called new alpha, and let's do float new alpha, and we'll calculate that here. Okay, so the formula here is 1 minus time elapsed divided by fade time. So how this works at the start is the order of operations is going to do the division first, time elapsed divided by fade time. If it helps make it clear, we can wrap it in parentheses, but that's not necessary. So whatever percentage the time elapsed is out of the fade time, we're going to subtract that from a full alpha value of 1. So if time elapsed is 50% of the fade time, then it's going to be 1 minus 50%, and our new alpha is going to be 50%. But to finish this off, I actually want to take the starting alpha and multiply that by this. So let's do start color dot A times whatever the results of all of this is. So if the color on the sprite renderer enters into this state with a alpha value of 1, nothing changes. But if the alpha value is below 1, because you wanted to have a partially transparent character, for instance, then we're going to be adjusting the new alpha value by a percentage of that. So if we started at 50% and this comes out to 50%, then the new value is 25%. But if this is 50% and this is 1, then the new value is 50%. So we set the new alpha down here on the color every frame, and then once the time elapses, we destroy the game object. Okay, so as you can see on the inspector for that state, the only thing we really need to set up here is the fade time. So how long you want to take for the object to completely fade to invisibility and remove itself from the scene. So let's hit play and test it. So when we get to the death state, you can see the knight not only plays this animation, but he also fades out, and if you look in the hierarchy of the scene, is completely removed from the game. So I'm not applying this to the player. I would probably presume that when the player dies, you'd have a game over screen or something like that, rather than removing the player completely. But you could also apply the same script to the player if you wanted to. So we're already at the point where our knight can take swings at the player, but there's no hit collider to actually damage the player. You'll remember that we already made it so that our characters will die after 2.5 seconds, so we should go ahead and undo that so that we can actually properly set up damaging through an attack. So let's go back into the damageable script real quick, and I'm going to remove that call to the hit function on update so that we're not just damaging for no reason. So since we already have the attack state set up for the knight enemy, I think we should start with the knight, and then we'll add similar components to the player so that we can have a sword swing attack for our player, of course. So let's jump into the prefab for the knight enemy. We already have a detection zone for finding where the player is at, but let's create another child game object for the sword attack area. So I'm going to right click on knight enemy in the prefab, create empty, and I guess we can call it sword attack. So next I'm going to go to the animation tab, And I'm going to change to night attack. And then let's find the frame of animation where we think the sword should be hitting the player. So I would say right here makes a lot of sense. So for this frame, and maybe the two in front of it, we'll make it so that we enable a trigger collider that will allow us to attack the player, calling the hit function on the damageable component. So for that to work, let's keep the animator at this point, and let's do add component, and you need some type of collider 2D. So if you want to keep things super simple, you can stick to a box collider. As an alternative, you could use a polygon collider and kind of match the shape of the sword swing a little bit. So if I do polygon collider here, you'll see that this gives us a 5-point polygon. If we edit polygon, we can move each of these points over to the right and kind of match the shape of our sword swing visuals. Of course, it doesn't need to be perfect, and we're just kind of going for an approximate shape here. So it defaulted to 5 points, but we can add another point just by clicking somewhere halfway between the line, press and hold, and then drag it out to the location you want that point to be. So the shape is very flexible here. Technically, I think the trade-off is that these polygon colliders aren't as performant in the game as a simple box collider would be. For a 2D game, I can't imagine that would have a problem when you only have a few enemies doing this. So I think in these circumstances, it's totally fine to use a polygon collider if you want a more custom shape for your sword hit. So when you're satisfied with your sword collision shape, we can just turn off Edit Collider in the inspector. And the next thing we definitely want to do is take isTrigger and turn that on. While we're at it, I'm also going to take another look at the detection zone box. So the knight can swing all the way over here. So I think it makes sense to edit the collider here and increase the shape of its detection zone. So basically, whenever the player is roughly within range of a sword swing, it'll try to make the attack as well. So we can test it with this shape for the detection zone. So next we want to go to the animation tab, and we're going to want to add a property for the animation. So that's going to be add property, sword attack, polygon collider, enabled. So what we can do is when we want this region to cause damage to a player or any other target, we enable it, and at other times we would disable it. So go to frame 0 on the attack where the sword swing hasn't been made yet, and uncheck enabled on the sword attack polygon collider. Then we'll go here to 2 frames in where we have this part of the animation, and I'm going to enable it since this should be a collidable part of the animation. So if the player's inside of here at this point in time, it's going to get hit. And we'll keep that going, let's say, until right here on this frame, unchecking that. And then on the final frame, we'll also uncheck it. So frame 1, 2, it's not enabled. Then 3, 4, 5, it's enabled where it can deal damage. 6 and 7, it's unable to deal damage. And I'm talking about the sample frames, not the moment in time when we actually change the animation sprite. So now we need to create a new component where when the polygon collider picks up a target and that target is damageable, we'll hit the target and deal damage to it, and possibly a knockback later as well. So let's add a new component, and I am going to call this attack. So this will be a new script. I'll create an add, and then let's edit it. So of course, the thing we definitely need to get reference to is the collider 2D. So the collider in our attack script, of course, we're going to want to reference this polygon collider. Because this sword attack is its own separate game object, it's only going to have one collider here. We could just get away with grabbing the component that is attached to the game object. So I will do void awake and then do attack collider equals get collider. So because this is a parent class for different types of colliders, it will work for finding the polygon collider as long as the collider attached to this is a type of collider 2D. It'll qualify. So a polygon collider 2D or a box collider 2D will work just fine. So inside of our attack script, we're going to need to do a void on trigger enter 2D. And then when an object enters the collider, that means that the collider is enabled and ready to hit a target. So we're going to want to see if the target is valid to be hit. So in our game, we're going to check if the collider 2D of the collision has the component damageable on it. Since anything that is damageable in our game, whether that's a character, an enemy, an NPC, or whatever, is going to need that damageable component. So I'm going to type in damageable equals collision.getComponent damageable. Now, just as a FYI here, you wouldn't have to necessarily use one specific class or component here. You could use an interface here, and then anything that implements an interface would be able to qualify if you did iDamageable instead of damageable. So that would just be if you wanted to have different implementations of what a damageable component would look like, but it's unnecessary for our game. So we're just using this one specific damageable component, which refers to the damageable.cs. So for a target to be hit, it has to be damageable. So we'll check if damageable does not equal null, then we're going to hit the target. So that means we're going to call damageable.hit, and we're going to pass in a damage amount. So I'll call this attack damage. And then let's implement this field at the top of our script. So generate field, attack damage. I'll default this to 10. And I would say we could make this public so that other scripts can reference how much damage it's supposed to deal. And also we'll be able to set it in the inspector when it's public by default. So we don't need a start or an update method. And as for the invincibility part of the damageable component, let's go take a look at the definition for hit. And we can see that when we pass the hit into this function, it's already checking if it's alive or invincible. So we don't need to check on the attack if the state is ready for the character to actually take damage. We're just going to try to damage it and let the logic be determined over on the damageable script side of things. Okay, so let's go back out to the game. Another thing we need to be aware of is that it needs to have the layer enemy hitbox, because we're using the sword attack to damage a player. So we want to check for physics layers that the enemy hitbox would be considered acceptable to hit. And in the case of our game, that's going to be exclusively player objects or colliders that have the player layer attached to it. So let's go to Edit Project Settings, check our Physics 2D, and make sure that on enemy hitbox, and we can see that the enemy hitbox, we've already set it up so that it can only hit players. So let's actually do the same thing in advance for player hitbox. So I'm going to uncheck everything except enemy. So a player can only hit things that are on the enemy layer. So now we have the filter that if something does fall into the trigger zone for the polygon collider of this attack, that A, it's at the frames where the polygon collider is enabled, and B, it's already going to be on the player layer. So basically, we're already certain that whatever the damageable component is attached to a player game object. Now we do want to make sure that our polygon collider is turned off by default, so I'm going to uncheck polygon collider. We only want to enable this when the game is running and the animation of the attack plays, which, if we recall, on Night Attack is already going to set the collider to active when it's on this frame and persist until this frame. After that, it turns off. So the last thing in the attack script for right now, I'm going to debug log and say collision.name hit for, let's see, attack damage. Attack damage the field. So that'll just give us a little indication that the character took some damage. So let's go ahead and hit play, walk into the attack and see, hey look, we're taking damage. And we can also go click on the player. Let's take a look at its health on the damageable. Okay, so down here we can see health is set to 30. The attack of the knight is kind of missing right there. So maybe we want to expand how far the knight can hit you. But yeah, we definitely got hit 9 times. One more hit and we shouldn't be alive. But unfortunately, our knight kind of went off the screen. Oh no, he actually ended up down there. Interesting. So let's open up the knight enemy, the sword attack polygon collider. Go to the animation, knight attack, and I'm just going to expand it a little bit for the polygon collider, just making it so that the knight can hit a little bit more areas. So maybe we don't need to make it quite that big, but just work with the shape and kind of adjust it until it makes sense for the actual game. Okay, and just remember to turn off polygon collider there. Let's hit play, and we can see we're getting hit. If we're about right here, character still gets hit, taking damage. We can click on the player, scroll down to the bottom, and we can see, yeah, we're taking damage still. So let's get hit that last time, and you can see we transition into the death state. So before we run our game again, we're going to want to make sure that we turn off the polygon collider 2D. So this should be disabled by default, and we should also do that on the prefab, making sure that the sword attack is disabled here. So when we hit play, we should still see that the polygon collider is disabled. And then that will stop us from accidentally dealing damage when the sword attack technically hasn't even been made yet. So I'm going to re-enable the player here, and let's hit play, go to the console, and you can see that the hit doesn't actually occur until we take damage there. So if we watch the pattern of the knight, we can see it goes to the run state on every attack just for a second before it transitions back to doing the sword swing. So if you like it, taking this little jump where the velocity is there for a second and it actually moves forward on every attack. You can leave it alone. So if you preferred for the knight not to jump back to the move automatically, what we can do is go to the attack state. And then here for the exit, we're only going to leave on the condition that has target is false. So if we wanted to do it this way where it can just keep attacking and stay in this state, then we would want to re-enable looping on knight attack. So let's go find the enemy, knight attack, enable looping, hit play. And now we can see that we're just going to stay in this state. So it'll still be able to swing multiple times, but it's not going to go back out to a running state until our character leaves that area. So obviously this kind of just depends on what you prefer. Obviously, having a sliding motion on every attack can be kind of a cool feature. But maybe it just makes sense to keep them in the same place every time. So up to you. Now, I do see that the player is still able to be hit after it's already in the death state. So I'm going to make sure that on the damageable script that we actually set is alive to false when the health drops below 0. So let's take a look at the damageable script. We can see if health is less than 0, then we're going to set is alive to false. Let's set a debug point here, attach it to Unity, and we'll see if we can actually get that point to hit. So I'll hit play. Oh, actually, let's make it quicker. I'm going to change the character's health to 10 so that we'll drop to 0 on the first hit. Now let's hit play and see if we hit that debug point. Okay, we do. So let's jump into this a little bit. I'll hit step into. And then, of course, we get to the property here. Is alive equals value. So the value is false. So after this line, is alive should be false as well. So let's check this dot is alive is set to false. And then we set the value on the animator as well. So it seems like the issue is that the health can hit -10. And I'm going to go up here to where is health is less than 0. So technically, that's working as written. It should be less than or equal to 0. So 0 still counts as a death state. So when the health drops to 0, we want to set is alive to false. Also, the reason it keeps putting the debug message after the character's stat is because this message runs whether the hit was successful or not. So what we could actually do is go into the hit function, and let's have a return type. So bool, hit, and if we get to this part, we're going to return true, as in the damageable was able to be hit. Otherwise, we return false because it was unable to be hit. So we're returning whether the damageable took damage or not. And that could mean over here, we could put bool got hit, and we'll only actually debug if the hit was successful. So if got hit, then we debug log for the attack damage. Okay, so now it should be a little bit more clearer when our game's running, what happens. So I'll hit play, and we get hit once, and after that, we don't get hit anymore. So you can see is alive was set to false. If we click on our player, the health that we get stuck at is 0. Once the character is in that state, it's unable to be hit any more times. So that just cleans that up for us. We can now go ahead and reset the health back to the default of 100. So another thing that would make our attack more interesting is if there was some kind of knockback effect on the attack. So let's edit the attack script again, and I'll go up here to the top, and let's add in a public vector2 knockback, and this would default to vector2.0. So not every attack would have a knockback. And what we want to do is when a character gets hit, we also want to pass in the knockback vector. So this is going to mean that we need to add the parameter to damageable.hit. So let's go to the definition. I'll do vector2 here. Knockback. Now, the way that a knockback is going to affect our characters may depend on the exact way we script the character's movement. Because it's more of a physics function, I don't want to have it change the rigid body values on the damageable component itself. So what I'm going to do here is I'm actually going to pass the knockback vector and the damage to other components that exist on our enemy or player game objects by using a Unity event. So at the top of our damageable script, I'm going to put a public Unity event, and I'm going to control period using Unity engine.events. And we want to give it the types of the parameters that we're going to pass in to any method that is called when the Unity event is invoked. So it's going to be an int for damage and a vector2 for the knockback. And I'll call the event damageable hit. So down here on the hit function, I want to call damageable hit. So let's see, damageable hit. I spelled that right. Let me copy that up to the top. Yeah, okay, I forgot the E. So damageable hit is the Unity event name. And then I want to do .invoke. And we're going to invoke with the damage and the knockback. So any functions that are subscribed to the Unity event are going to invoke the methods using these as the parameters when our character gets hit. So when the character gets hit, basically, other components like the player script can respond to it and apply the knockback to the rigid body. But I do want to make sure that the subscriber list is not null. If you try to invoke a event that has no subscribers, I think you get an error message. Because if nothing is responding to it, then it's unneeded anyway. So to make sure that the list is not null, we add a question mark there. So we check if it's null or not null. And if there is something in the list for the events to invoke, then we invoke. We pass in the damage, we pass in the knockback, and then those functions are going to get called on other scripts. So in order for this to work, we need another component that is going to have a function to respond to this. So I'll create an onHit function on the player controller. So let's go to the player controller down to the bottom, I suppose. So let's add in public void onHit. This is going to take int damage and vector2 knockback. And we'll do something with this information in a minute. So to set up the Unity event, let's go back out to the game. I'm going to expand the player prefab. And let's scroll down to our damageable component. And we can minimize the ones that are necessary. So you can see here, damageable now has this box here where it says damageable hit, list is empty. This should look familiar because it's just like the player import where you have events. So you can see the player input events move with a callback context. It's the same idea. Those are Unity events here. So we just created a Unity event in our custom script. So now I need a function to call when the damageable hit is invoked. So let's hit play. I'm going to drag the player game object from the prefab over here. Let's click on the drop-down list. So we want player controller, onHit, dynamic int vector2. So when this component is hit, this player controller is going to respond to it by calling the onHit function with the data that just got passed in. So when we reach onHit with the damage and the knockback, what I'm going to want to do is take the velocity of the character, and I'm going to set the x velocity to whatever the knockback is. So this is going to be equal to a new vector2, and let's do knockback.x. But for the y movement, at least for now, I want to maintain whatever velocity already existed and then add the knockback to it. So that's going to be rb.velocity.y plus knockback.y. So the other thing we're going to want to do when the character gets hit is make sure that we transition into the hit state. So we could set that up on the player controller, but I think I actually want to do it on the damageable component this time around, since different characters that are damageable are going to probably have hit animations as well. So for damageable, when we get hit, I'm going to do is hit equals true. So this is going to be a property we're going to generate up at the top. I'm going to right click, go to the definition. And for right now, I'm just going to focus on getting the value from the animator and setting it on the animator. So get is going to be animator dot get bool, and we'll do animation strings dot is hit, which we haven't created, of course, and we're going to return that. So let's generate the field and go to the definition. I will make it equals is hit, and then for the setter, it's very similar, of course. We're just going to do animator dot set bool, animation strings is hit equals the value we passed into the setter. And then on the flip side, when we exit the animation state, we'll just use the set bool behavior for the state machine to turn is hit off. And then that will let the damageable component know that it's no longer hit. So on the player controller, we need to limit the movement for fixed update. So right now, the fixed update X movement is being overwritten by whatever the movement speed would be based on the player's input. But when we specifically get hit with a knockback, we want that knockback stun, where the character is just going to progress in a certain direction and it doesn't matter what input we have. So we want to check if the damageable component is hit currently, and then if that's the case, we disable our movement updates. So the direct way to do this is going to be to add the damageable component to our player controller. So I'll do damageable, and then on awake, I'll get the damageable component, So damageable equals get component damageable. And then on fixed update, we'll see if the damageable component recognizes that the character is hit. So if, and we're going to have an exclamation mark to reverse this, but damageable.isHit. So we want to check that this is false. And only when this is false can we set the RB velocity. So whenever the character is hit, we can't update the velocity based on our input. And right now our player controller is dependent on the damageable script. So I am going to add it to the required components up here at the top. So type of damageable. And make sure you have the ending parenthesis there. Okay, so now we need to add this parameter to the animator. So let's go back out with the player animator. Let's add the Boolean here, is hit. While we're at it, we can also add it to the night enemy. So I'm going to click on night, add the Boolean. So having the night enemy set up with is hit will eventually allow us to transition into the hit animation as well. So now let's update the player animations. So now we need to add the hit animation for the player. So let's go to the animation window with the player selected, and let's create the player hit animation. Set the samples to 10. Let's go to project, RV Ross individual sprites, and let's find adventurer.hit. And let's find adventurer hurt 0 through 2, import those in the window here, hit play. So we're only going to have this animation play once. So let's turn off looping for it in the characters player folder. So we need to find it in our project. I can't find it. I must have put it in the wrong folder. So I'm going to search player hit, and let's drag this animation into the player folder. So now if we get rid of the search term, and we can make sure it's in there. Let's click on player hit, go to the inspector, turn off loop. So now if we click on player, we hit, let's see, player hit, play. Okay, so now that we have this animation, let's go to the animator. So with our player hit animation on the animator, we're going to want to be able to transition to it from any state. So I'm going to make a transition to player hit. The requirement for this is going to be is hit is true, but I'll also add in is alive is true as well, because if it's not alive, then we want to go specifically to player death. So for this transition duration 0, so it should happen instantly. And when we're in this state, we want 2 copies of the set bool behavior. So one is going to set can move, update on state, and the value on enter is going to be false. Value on exit is true. But in addition to that, I want to click add behavior, set bool, and we're going to set is hit to false when we're leaving the state. So is hit, update on state, value on exit is false, value on enter is true. So when we're done being hit, we want to return to either the air states or the ground states, depending on whether is grounded is true or false. So I'll right click on player hit, make a transition to the state machine air states. The condition for this will be that is grounded is false, has exit time true, the exit time is 1, and the transition duration is 0. So that means at the end of player hit, we just return to the air states. Now on the flip side, if grounded is true, then we'll do the same thing with ground states. So click on the transition here, add the condition, is grounded is true, exit time 1, transition duration 0. And so that sets our return for after we're done being hit. We can move into the air states or the ground states immediately. So let's hit play and try to get hit and see what happens. So we can see that our animation plays, and after that, it kind of gets stuck there. So let's go back to the main scene, make sure the player selected hit play, and then we'll be able to watch the animations. So we get to player hit, but nothing actually really occurs here. It just kind of gets stuck there. So the reason for that is that when we click on the line for the transition, we have to turn off can transition to self. So just like with player death, whenever you make a transition from any state, you got to make sure that you don't check can transition to self. Maybe it would be okay if you were using triggers, but for Booleans like this, no. So now we should not get stuck in player hit. We have the animation play, and then it's not actually exiting. At least it's playing now, though. So I think that this Boolean might be actually causing us some problems. So I'm going to actually change the transition condition here to a trigger. So let's add the trigger, and I'll call the trigger hit. So instead of is hit, we'll use hit. This trigger will set whenever we get hit in the script. So we'll still have a Boolean value, but I'm going to change this to lock velocity, and we'll rename this parameter to lock velocity. So this is going to mean that we can't change the velocity. So let's go update our scripts to use this. So at the bottom of the damageable and the hit function, let's do, instead of isHit equals true, animator.setTrigger animation strings dot hit. And then we'll create that as a trigger name. So let's go to the definition. We can actually make this a hit trigger. So I want to be kind of more clear about that. So I'm going to rename this to hit trigger, right click and rename so that it updates in all the files. And we'll call the string for it hit though. Okay, so we're setting the hit trigger, which will allow the transition to happen. So we're not actually going to need this is hit. And as a result, on the player controller, let's just remove the reference to the damageable component. Let's remove the require type of damageable. We'll remove the get component damageable. And then let's create a new property. So lock velocity is not set to true. Let's generate that property. Go to definition. And this will only have a get function for right now. So the get function is going to be animator.getBool animation strings.lock velocity. So we need to generate that, and we'll give it the string name in here, lock velocity. And we need to have a return for this. Okay, so this is kind of nice because now our player controller is not directly dependent on the damageable component, but rather this parameter is just being set in the animation states. Okay, so let's go ahead and see if it works now. I'll hit play. We'll get hit, and you can see that we're not moving here. Lock velocity is not being set to false on exit though. So I actually see that the set bool behavior, the value on exit, is not setting properly. So let's go edit the script. And here's our problem on state exit. I actually mean to have value on exit here. So that's really the root of the problem there. If we hit play, then we can get hit. Okay, and now you can see that after the hit's done, our settings are returning back to where they should be. So changing to this lock velocity option, probably not entirely necessary. Otherwise it would have worked, but I think that this implementation is actually better. So that's going to be what I'm going to keep as we go forward in this tutorial. So now after all of that, we want to make the attack actually have a knockback. So let's go to the knight enemy, the sword attack. Let's jump into the prefab. And you can see we have the field for knockback. So we need an X value and a Y value. So this is going to be in velocity per second. So if we put 5, that means 5 units per second. And we can add a Y velocity as well. So let's try 5 on the X and 2 on the Y. Let's hit play. Let's go get hit. And you can see that our character is getting hit. Now we're actually getting hit multiple times. Now we're actually able to get hit multiple times here. So a quick fix for that would be to go back out to the player and increase the invincibility time. So let's go to the player invincibility time and let's set that to 0.5 seconds on the prefab. Hit play. Okay, now we should only get hit once for each time. So another way we might want to make sure that the player doesn't get hit multiple times. So we could just keep increasing the invincibility time of the player. So we might even want the invincibility time to be something like 1. So let's get hit. And okay, yeah, that's better. We're definitely only getting hit 1 time by the sword. You could also make it so that the sword only hits on a single frame and then it will never hit more than once per attack. But it's something you just got to kind of play around with. So let's apply that to the prefab player. But we can see that even though there is a knockback, that our speed is not being completely controlled by the knockback. We can still kind of manipulate it, which probably isn't what we want either. So maybe to make absolutely sure that this velocity doesn't get changed until the hit is done, we'll also do a lock velocity equals true inside of the player controller itself. So that's going to mean setter function animator.setBool animation strings.lock velocity equals the value. And so that should mean even before we get to the hit state that this should already be set to true, which means that the RB velocity shouldn't run. So let's see if that actually fixes our problem there. So we hit play. Let's get hit. I'm going to try moving. Okay. And now it's actually working correctly. So I guess there was just a split frame before the hit animation starts that value was not set to true. Okay, so now we're definitely not able to move whenever we get hit. So to kind of wrap up this video, we should add an attack to the player as well. So let's click on player. I'm going to jump in here. Let's create a new game object. So this is going to be the sword attack. I'm going to add a collider in here. So let's do a polygon collider, just like the knight, and I'll add in the attack script. So the knockback here, we could say 3 and then 1 to give it a little bit of a bump into the Y direction. The attack damage, let's say 15 by default. So we need to add this collider to the animation. So animation, let's do player attack 1, add property, sword attack. Let's do polygon collider enabled. So at the start of the animation here, it's not enabled, of course. And right here is where we want to enable the collider. We'll just have it at that single frame, so the next frame after we disable it again. And then the last frame, it's disabled. So it's just a 1 frame hit here for this sword swing. And let's edit the collider. So inspector, edit collider. Okay, and let's make sure we're on the hit frame so that we know where to put the shape. And then take the polygon points and move them to wherever you think would be good for the hitbox of the sword swing. So I'll just kind of click and add a few points here. I think that looks pretty reasonable for this sword arc. And then make sure that the sword attack is off by default for the polygon collider. And I'll check the main object in the main scene. The sword collider, this should be off here as well. So now we're going to need to edit the knight script and create an on hit to apply the knockback there for the knight as well. So I'm going to add a component here for the knight. So let's open up the knight script for editing. I'll go down here to the bottom and let's create a public void on hit, which is going to take the damage and the vector2 knockback. For this character, we'll basically take the same code from player controller. So I'm going to have the lock velocity property and the RB velocity set, and I'm just going to paste those over here. Now that I think about it, though, we're just really duplicating code here. So I think we're going to take the lock velocity and put it into the damageable script. So let's go grab the property from the player controller, and we'll kind of go back to a few minutes ago again. So cutting and pasting the lock velocity. Going to go in here to the damageable, paste that in. So down here when we get hit on damageable, I want to set lock velocity to true. And so that means we do need the reference to the damageable component in the player controller. So damageable, damageable. And we are going to require type of damageable at the top here. So let's go down to onAwake and get the component, just like we always do, get component damageable. And so we're not checking lock velocity, but rather damageable.lock velocity in order to determine if we can move here or not. Okay, so this means that on the knight, we can also reference the damageable component in the same way. So damageable, damageable, require type of damageable. And then we can go down to where we're setting the movement for this character, which should be in fixed update. And we'll add a new if condition. So if damageable.lock velocity is not true, so let's add the exclamation mark for that, then we will allow our normal movement logic here. So just paste all of that inside. Otherwise, we're not going to mess with the velocity. So having the lock velocity and the damageable means we don't need to rewrite the same code for every other component, but we are going to need to manually respect that lock on the player controller, the knight scripts, to actually make sure that we don't update the rigid body velocity. So when we have this lock velocity on the damageable, it's convenient to have here, but because our physics are in other components like the player controller, we need to make sure that we respect that on those individual components. So at the bottom for the on hit of the knight, we can remove the lock velocity is true. Going to click to jump to the same thing in the player controller. We remove that here as well. And let's make sure that that error is cleaned up as well. So the type of damageable is required. And so something we could even think about doing is, if we wanted to, we could just have the RB velocity set on the damageable component directly. For right now, I'm not going to do that because I don't necessarily want the damageable to have to mess with the physics itself. So for now, we're just going to keep using the Unity event to pass that knockback information to a different script. So I'll admit it's an imperfect implementation, but it should work at least for now. So let's add the method to damageable hit on the knight. So I'm going to take the knight script, drag that down there, and let's go to knight on hit, so we can apply the velocity to the knight when we get hit. So let's make sure that the parameter lock velocity is also set on the animator component. So parameters, add bool, lock velocity. So that should be on player and the knight as well here. We can delete is hit because we're not using that anymore. And then add the trigger. So it'll be very similar to the player. From any state, we can make the transition to hit. The conditions for that are going to be that the hit trigger is made, and also that isAlive is true. We're going to turn off can transition to self, transition duration 0. And then from night hit, at the end of that, we're going to make the transition to move, state machine, move. And this should happen automatically at exit time 1 with a transition duration of 0. Also on night hit, I'm going to add the set bool behavior. Value on exit is going to be false, but on enter is true. And the bool name is lock velocity. So update on state. We also need to make sure that we actually get the reference to the damageable component in the night script. Otherwise, it's not going to work, of course. So on awake, do damageable equals get component damageable. Okay, now with all of that, make sure you're in the main scene. Let's open up the animator for the night. Let's hit play and make sure everything works still. So the knight is able to move. Let's see if we can hit the knight if we get close. So right now it's kind of hard to do that. So right now it's pretty hard to do that, but let's get closer and see if we can hit him. Okay, so what's going on here is that we haven't set up the sword attack properly. So the sword attack is still in layer player, but we want this to be player hitbox. And we also need to take the polygon collider and turn it to is trigger mode. Now let's try hitting play and see if we can hit again. So we're swinging at the knight. Oh, I do see the knight getting hit. Okay, and we're actually able to kill him. Now the animation for the hit seems to happen almost instantly, and I believe that is because the animation on the knight is a single frame. So we got to go back to knight enemy, open up the animation, and we can see the knight frame here. It's only lasting a single frame. So if we control and middle mouse scroll outwards, we can just copy this frame out to however long we need it to last for. So I'll put it at 0.4, paste it in, and now this animation should last for 0.5 seconds by default. So let's try going into play mode again, hit play, and we should have a 0.5 second knockback for the knight. So let's see if we can hit him. Okay, yep. So definitely hitting him. The knockback may be a little bit wonky there, so we can change the settings on it. So let's go into the sword attacks values for the knockback, and I'll set the Y to 2, and the knockback X, let's actually set that to 2 as well. So one reason for making the velocity set on the knockback custom for each of the characters might be that you can allow each character component, whether that's a knight or a player controller, to be able to take that knockback vector and apply it individually. So if you wanted the knight to be, let's say, more resistant to the knockback, you could just take the X value and cut that in half before you apply it to the velocity. For right now, though, of course, they act the same. So let's try hitting the knight. Okay, and we can see he gets a little pop off the ground there. Maybe that's not what we want. Maybe we want the sword hit to be a little bit softer. So I'll just take the Y and I'll set that to 0. Leave the X as 2. Yeah, now the knight gets knocked back a little bit, but not too crazy. So it's mostly working, but we can see that sometimes the sword doesn't actually hit the knight. So that was just a mistake in setting up the sword attack. So if we go to the sword attack, you can see that we set no offset for the transform. So when we're flipping the transform over from over here to the left, we're not actually reversing this polygon collider shape in any way. So we need to make sure that the center for our transform on the sword attack is actually over to the right as well. So it should look something like this. The transform X is, let's say, 1. And then let's jump into animation, attack. Go to the frame where we have the attack. And then we need to pull all these points over again, like so. So if we click on player now, and then I do -1 on the scale, then we'll be able to click on the sword attack. And now you'll see that it's properly over here on the left. Got to make sure that your transform is still the center point for your animation over here. So we reverse the direction based on the transform. And that's why we need to set the offset for the sword attack. So we should also make sure that for the knight enemy, we do the same thing. So knight enemy, let's double click on it. Let's look at the attack animation. Go to the frame where we have the attack. I'm going to click on sword attack in the inspector. And we can actually see I made the same mistake over here. So we need to take the offset and move that to the center point of our attack, right about there. And then we need to position the polygon collider based on that. So polygon collider over to here, like so, and keep moving the points. to fit the sword's attack. And then we'll test it by clicking on Knight Enemy and doing a -1 on the scale. -1. Now if we click on the sword attack, we'll be able to see that it's over here on the left. So that's what we're looking for. And that should help make sure that the animations actually match the collision shapes for our attacks. So now we can hit play, and I'm going to go swing the sword at him, and you can see it's actually hitting correctly now. So that's what we would expect. And we can also test to make sure that when we get hit by the sword over here, that is being applied as well. One more thing I notice is that the sword is knocking us back to the right no matter what. So what we really should be doing is changing the knockback vector depending on which direction our enemy is facing when they make the attack. So since our characters are based on the local scale changing, let's go into attack. And when we apply the knockback, we want to reverse it if we're facing the left. So let's come up with a final value for a delivered knockback. The final value we're actually passing to the hit target. And that's going to be equal to the transform.parentTransform.localScale.x is greater than 0. And then if that's the case, then we're going to do knockback. Otherwise, we're going to do a new vector2, which is going to be knockback.x, knockback.y. But on the x, we're going to make it negative. So our attacks are a child component of the main character game object. And on the character game object, we're flipping the scale. So as a result of that, if we flip to face the left, then we also flip our knockback to face the left. So I'm going to create a knight enemy down here as well, moving the player down to this little area where we have 2 walls so that we can easily test directions. Let's hit play, and we'll see that from this direction, our knockback does go towards that wall. And on the flip side, our knockbacks are still going towards that wall. And the reason for that is that we haven't used the delivered knockback in the hit. So this is our final knockback value, depending on what direction they're facing. Okay, so let's go ahead and hit play. We get hit from that direction. Okay, that's fine. And then we come over here. And okay, now our knockbacks are actually hitting the right direction. So that should apply both for the enemies, but also for us. So let's see if we can get a knockback from the left as well. Okay, yeah. So the knockback is directional based now. So that's what we're looking for. And that's going to wrap it up for this part on getting hit colliders, attacks, and knockbacks to work for both our player and knight characters. So now that our attacks have been working, we might notice that the knight being able to keep attacking over and over again can become a little bit oppressive. So what we might want to do in order to adjust that is to add a cooldown for the knight's attack. So we can make a new float for a timer on our animator controller. So I can call this attack cooldown. And we can say that when this reaches 0, then our knight is able to attack again. So let's add a attack cooldown as a parameter value. And I'll say less than 0.0001 as the attack cooldown. So basically, if it is 0, or for some reason less than 0, then we'll allow ourselves to go into the attack state. So then when we jump into the attack state machine and we make our attack, when this attack is done, I want to set the attack cooldown to a value. And let's do a set float behavior, which I think I made behind the scenes. So let me just go ahead and open that up and show. It's pretty simple. So it's almost like a copy out of the set bool behavior, but we have public string float name up here at the top, Boolean conditions, which are for checking at what time we should set the value, and then float value on enter, value on exit. So if update on state enter, then we're going to set the animator's float, the float name, the value on enter, and on state exit, if we are checking for update on state exit, we do the same thing, just using the value on exit. And then for state machine enter and state machine exit, it's the same thing. Update on state machine enter, set float, float name, value on enter, and on state machine exit, if update on state machine exit, then we do animator.set float, float name, value on exit. So this just allows us to change an animator parameter when we enter or leave a state or a state machine. So the float we are going to set here is the attack cooldown. The value is going to be set on state exit, and the value we want on exit is going to be however long you want to wait between attacks. So I could say maybe 0.5 seconds to start. Now you could also create a behavior component where you would decrease this value down towards 0, But the thing is, if you try to add a behavior at a global state, but then for some reason your movement ends up in a substate machine, then that timer will stop working. So rather than setting the values at some layer level in the animator, I will just update this attack cooldown inside of the knight itself. So let's click on the knight enemy, and I'll open up the script for editing. So let's create a new property here, which will be attack cooldown minus equals times dot delta time. So let's generate the property for the attack cooldown. And we're going to need a get to get the current value off the animator and the setter to set the new value. So the get function, we will return animator.getFloat animation strings dot attack cooldown. And for the setter, we're going to do animator.setFloat animation strings dot attack cooldown equals the new value. So when we're doing a minus equals here, it has to get the old value before we can subtract it and apply the new value. So we'll get the old value, we subtract the delta time, and we set that as the new value up here. So let's generate the string for this. I'm going to make it lowercase, and then we'll generate the field. We're not making a property on the strings list. So let's go to the location. I'm going to remove this accidental attack cooldown property, and let's set the string value for attack cooldown. So let's clean up the attack cooldown property a little bit. So to make sure that the value never gets set to something less than 0, we're going to call mathf.max, and we have two values. It's going to pick the largest between them. So the first one is value, and then we have 0 as the other value. So the 0 will now become the new minimum because we're taking the value maximum of either the value or the 0, and anything less than 0 means the higher number is 0, of course. So that's not really required, but that's more of a visual thing. We could also put down here a if attack cooldown is greater than 0, then we'll change it on the delta time, but otherwise we won't mess with it. That will just mean that there'll be less calls to this animator.setFloat, only decreasing the timer when it's actually active. So since that behavior is added to the knight script, it should always be running no matter what state the animator controller is in. So let's hit play. I'm going to run up to the enemy, and let's see if that timer actually gets set. So I hit play again. Let's see, the attack cooldown, it's not really triggering, it keeps running. So let's see what's going on. I'll click on the inspector. So we can see attack cooldown on state exit. We set the value to 0.5. Let's make sure that that's happening on the set float behavior. So if update on state exit, we set the value on exit. But you know what? I think the reason is because we still have those has target conditions. So I added this before so that the attack could keep looping, but I actually want to remove this. We want to allow the knight to return to its default movement states, since it's not going to be attacking consistently. So remove the condition and make sure that the has exit time is still 1. Go to the base layer, and on the transition from attack to move, also remove the condition here. So let's hit play, and now we'll look at the enemy. So yeah, we can see the attack cooldown is actually having to take a second here before it could just keep attacking. So we have the attack, but then the character can't attack again. To make that more obvious, let's click on the attack state again, and let's take the value on exit and set that to 1. So now there's a big cooldown between attacks, and you can see that the knight keeps running for that second when it can't attack. Now one thing that's a little wonky is that when it has the target, but it's not in the attack, that it's still locking the movement of the player. So we want to change the condition for when we're locking the animation from has target to something else. So let's go back to the base layer, and let's look at the condition from move to attack. So you can see here that we also require the attack cooldown to be less than 0.0001. So we also want to make sure that that is also the case with move. So on the transition inside of here, add the condition for the has target to also be attack cooldown is less than, and let's add in 0 with 4 5 zeros, 0.00001. Okay, or 1e to the negative 0.5, whatever. Okay, so now if we hit play, the attack is made, but the character is still able to run while it's not able to attack. Okay, so that's kind of what we're looking more for. We just want to make sure we're not locking up any of the animations when we shouldn't be. And since there's a cooldown between the attacks now, then that should mean that the knight's going to keep running, and then it'll attack us when it's able to, but only when the attack cooldown reaches 0. So possibly the last thing we need to add for the knight's AI is that I want to make sure that the knight doesn't walk off a cliff when it reaches the edge. So we're reversing based on hitting a wall, but what if there's a area in front of us where there's a gap? So if we cast to the right, cast down, cast up, or cast to the left, we actually aren't able to see the ground with that. We could cast down and to the right, but then we would hit this ground and then that would show up. So what we actually want to use is a detection zone that will be in front of our knight, and we'll use that to see if there's no ground kind of in front of us, but to the right. So I'm going to jump into the prefab for our knight, and let's add in another detection zone. And I'll call this cliff detection zone, I suppose. For the first hitbox, I'll call this something like hitbox detection. So this detection zone down here is still going to have a detection zone script, and we're still going to add a collider to it. In this case, we're going to use a box collider 2D. So let's offset this collider to the right, probably right around there and downwards, like so. And I think just having a 1 unit square is probably fine here. But what we're going to look for is going to be different. So the layer isn't going to be the enemy layer, or the hitbox layer. We could actually click on layer and just create a whole new layer. So I'll call this the ground detection. So the ground detection layer will go up to edit project settings, go to physics 2D, and we'll turn off everything except for ground as what it can detect or collide with. So ground detection and ground, that's the only thing you need to have at this cross points. Let's hit X here. And now we're sure that if this picks up anything, that it is on the ground layer. So make sure that the cliff detection zone is changed to the ground detection layer. Also make sure that the box collider is in is trigger mode. Now we can go back out, click on one of the detection zones, hit play, and we should see that the ground composite collider shows up here in the cliff detection zone. But when we get to the edge, it's no longer there. So what we need to do is on our knight script, we reference this cliff detection zone. So let's click on knight, open up the script, so edit. Let's go to the top and declare another detection zone. So public detection zone, ground detection, and I'll call this cliff detection zone. And what we want to do is see if this is empty in terms of the colliders that show up. So if it's empty, then that means that we're about to walk off a cliff and we want to reverse our character's direction. So let's go down to where we flip the direction around, and let's add in a or condition for where it says touching directions is on wall. So the or is going to be the cliff detection zone dot detected colliders dot count is equal to 0. So now if we're on the wall, or if we're about to walk off a cliff, then we'll flip directions, but also only if we're on the ground. Because obviously if we're already in the air and there's nothing detected, well, that makes sense because we're already falling, and we don't want to keep flipping the directions in that case. So this is the if statement that currently makes the most sense for our knight. So back in the Unity editor, we need to go to the knight enemy and make sure that you set the cliff detection zone in the spot for cliff detection zone. So I'm going to drag this in here. Now, when you start having multiple components of the same type, you do have to make the variable for those detection zones public so that you can manually set it. It wouldn't be appropriate to do get component in this case because the attack zone is for very specific checks and the cliff detection zone is a different set of checks. So you have to make sure that the right zone is attached to the right field slot here. So at the start of our script, we might hit play and see our knight kind of freak out since it's not picking up on the colliders. If that's the case, I'm going to take the detection zone and I'm going to increase this a little bit to make sure that the detection zone is actually able to have the on trigger enter 2D called so that the ground gets hit into the collider. But then we can still see that for some reason we're reversing the direction at the start of our script. So what we want to do is to have sort of a delay for when we actually flip the direction based on the cliff detection zone having or not having a collider. And I thought about this for a minute, but I think a good solution is going to be to use a Unity event, and we'll check not at the start of the script if there is no colliders. But what we'll do is that when the count drops to 0, after there's already been a collider in it, then we'll send a Unity event back to the knight to let it know that the ground has left the list and that it can flip at that point in time. But that shouldn't occur until there's been at least one ground item in the detection list to start with. So let's go into detection zone and let's create a new Unity event. So I'm going to call it public Unity event. Control period to bring in using Unity engine.events. And then I'll call the Unity event no colliders remain. So down here, when we remove a collision from the list of colliders, if detected colliders.count is less than or equal to 0, then we're going to call no collisions remain dot invoke. And I'm also going to make the n for no collisions remain lowercase there. It's not a property. So now let's create a method in our night where we can respond to that. So just like with onHit, we'll do public void on no ground detected is what I'll call it. And that's where we'll check if we're grounded already. Then in the night script down here below onHit, I'm going to do public void, let's say on cliff detected. Then if grounded, so that's going to be if touching directions dot is grounded. Then we're going to flip direction. So using this as an event means that we can go up to where we have cliff detection zone dot detected colliders dot count equals 0, and we'll remove that. So this will handle our normal flip direction, but we don't want that to happen at the start of the script. So instead, we rely on cliff detected, the event to be triggered for us to flip the direction if the character is still grounded. So now that we have the function, we can attach that to the Unity event. So detection zone on cliff detection zone, add a function. So no colliders remain. We'll bring in the night enemy and then go down to night and do on cliff detected. So let's hit play and test if this works. So you can see that the night does not flip at the start, but it does flip when it gets to the end. So basically we're not doing a no colliders check at the end. We're just waiting for that event to trigger. And as you can see, the night no longer walks off the cliff. So just one more time. Let's show this when the night is on screen. And you can see that this is actually working quite nicely. So that's basically it for setting up the AI for our knight, being able to walk back and forth, make sword swings at the player, having an attack cooldown, and detecting if we are on the edge of a cliff so that we can reverse direction. So in this video, we're going to create a health text to appear above players or enemies whenever they take damage. So that means we're going to need to set up a game object for the basic text. We'll be using the built-in Text Mesh Pro package in order to create our text prefab. The text is going to float upwards above the player, disappear after a certain period of time, and then remove itself from the game when the fade to completely transparent is done. And we'll be using the M5X7 font that we installed at the beginning of the course. But the interesting bit in this video is going to be that we want to create the text as an instance whenever a character takes damage. So we'll be creating a new Unity event that will happen when any damageable component takes damage, and we'll be responding to that with a custom UI manager. So let's start by creating our text prefab. So I'm going to right click in our scene hierarchy and go down to UI and then Text Mesh Pro. When we do this, we're using Text Mesh Pro for the first time, so we need to import the Text Mesh Pro into the project. So you'll have to go ahead and click on the button here, Import TMP Essentials, and then we'll add a folder Text Mesh Pro to the root of the assets. So exit out of that and then double click on Text TMP, and we'll be able to see our text on the canvas. So keep zooming out and you'll see the frame of the game canvas. I'm going to take the position X and position Y and set those to 0 for now. When we actually spawn the text, we'll be creating a custom location for it. Where we have the text field, I'm going to put in a placeholder text like damage. So this should never actually be visible. Instead, we're going to replace this with the exact number of damage that a player or enemy is taking whenever we create an instance of the text. Next, we need to create our new custom font asset. So in the root of our project, go to UI, Fonts. So right click on M5X7 and then go to Create. Look for Text Mesh Pro and then choose Font Asset. So that will create the M5X7 SDF. And we want to take that and apply it into our Text TMP object. So click on Text TMP, and where we have Font Asset, drag in the SDF into this Font Asset slot. And you should see the displaying font go ahead and change. So now we have a cool pixel art font to go with our game. For the font size, we'll leave that alone for right now, but let's change the alignment to the center. So when we create the text above our player, the text should center on the player, half to the left and half to the right. If you'd like, you can also put it to center vertically. So if we go ahead and hit play now, then you'll see that this text just shows on the screen in the center. So one of the differences between a canvas UI element and the actual game objects in the scene is that the position of a canvas element is static. It's not going to change and move around on the screen. So the next thing we can do with this text game object is create a health text component. Before we do that, let's create a new folder in UI for text items. So I'm going to create a folder, text, go into here. So before we create this as a prefab, let's rename this to be damage text. And in the text folder, I'm just going to drag and drop it into there so we can recreate a copy of this. Also, one last thing I want to do, jump into the prefab for it, and let's take the color of the damage text and make it red. So that will make it really obvious that when this number shows up on the screen in this color, that our character is taking damage. Then if we double click on the prefab, we can just make sure it's still there. So let's add the new component. I'll call this health text because we'll use it both for damaging text and healing text as well. The difference would be that we change the color here for healing, but we don't need to change that on the script itself. The script is going to do different things. So let's create the health text script. So in the root of the project, I'm going to take the health text script and move it into the scripts folder as well. So now let's open up the health text script for editing. So inside of the health text, we're going to create a move speed vector. I'm just going to make it a vector 3, and let's call it move speed. And we'll make this equal to vector3.up by default. So this should be 1 on the y-axis, 0 on x, and 0 on the z-axis, which means it's just going to be moving up on the screen. So then we need our update function. So with this move speed vector, we're actually going to apply it to a rect transform, not a normal transform, because this is a UI element. So if we take a look at the damage text, you'll see it has a rect transform. So we need to move its position upwards based on our speed. So to do that, we'll need a rect transform. I'll call it text transform. Let's do a void awake to get text transform equals get component rect transform. And now on update, we want to take that transform dot position, and then we want to add move speed times time dot delta time to it. So we're just applying a percentage of our move speed to the position on every second. So the time dot delta time makes it so that we can move at a consistent amount. So let's go back out to the game, hit play, and see if we get any movement on the text. So I don't really see any, but you can see that the number is going up over here on the position Y. So it is moving technically, it's just very slow. So let's try taking the move speed, and I'll set it to 50 by default. Let's hit play now. And you can see that that is a much, much faster float upwards. So I think the number we kind of want is probably going for about 75. I'll hit play. And yeah, I think after about 1 second, having that fade out would be good. So back in the health text, I'm going to actually change vector3.up to a new vector 3. And let's just use 0, 75, 0 as the default amounts. So I think this comes out to be a pixels per second, since when you move the position X and position Y on a rect transform, that's dealing in pixel amounts. So now we have two options for what we could do with this text component. One would be to reuse in our state machine scripts the fade remove behavior, or another option would be to recreate basically the same information on the health text. In order to use the state behaviors though, we would have to create an animator controller, and that might just be a little bit too much extra stuff. So I suppose I'll just create a really quick timer on the health text script as well. So let's edit the script. And we can put in a public float time to fade, and I'll default this to 1 second. So then we need a private float time elapsed, and we're going to be fading out the color on the text mesh pro UGUI component. So let's get that text mesh pro UGUI. I guess we can call it text mesh pro. For the variable name, because TMP would just kind of mean more like temporary file, and that doesn't exactly make a lot of sense. So let's get that component as well. I'll just hit tab and have that autofill. So on update, we'll do time elapsed plus equals time dot delta time. Let's make sure up here that we default time elapsed to 0f. And then if time elapsed is less than time to fade, then we're going to adjust the color on the text mesh pro. So text mesh pro dot color equals a new color. And let's base this on the starting values so that we don't have to get this every time. So we'll have a private color, start color, kind of like in our fade remove behavior. So start color equals text mesh pro dot color. So this is the starting value, and then this will be the updated value. So for the RGB, I want to keep that the same. So start color dot, let's see, R, start color dot G, start color dot B for blue, and then a new value, fade alpha. So the alpha is going to be a float value, and we're going to calculate that. I'll just go over to the fade remove behavior, double click into it, and let's just grab this same formula here. The new alpha is equal to the start color dot A, the original alpha, multiplied by 1 minus basically a percentage calculation between the time elapsed and fade time. So if we just copy that bit over here, paste it in there, then we have our new fade alpha. So the only thing we need to change it over here is using time to fade as the variable name. And that should be it for the fading. But after the fade is complete, we want to remove our object from the game scene. So else, implying that the time elapsed is already greater than the fade, we're going to destroy the game object. So let's go back to Unity, hit play, and watch our fade. So you can see it fades completely and deletes itself from the scene. Watch the damage text in the hierarchy, and you'll see it removes itself when the fade is complete as well. So now all we need to do is have a Unity event where we create the health text and then assign a text number to it, and the fade out and the removal of the game object will already occur in the health text script. Another quick thing to note, this event system game object that gets created when you add a canvas to your scene, because we're using the new import system, we want to click replace with import system UI module here so that we're using the new updated version of the import system. Okay, so let's create a new game object in the scene, and this will be our first kind of manager script. So I'm going to right click, create a new empty game object, and I'm going to call this UI manager. I'll reset all the positions to 0 for XYZ, though it's not going to matter. And then I'm going to create a new folder in assets. So let's right click in the assets folder, create folder, and I'll call this managers. Double click into here and drag UI manager into the slot. So the UI manager, I'm going to jump into the prefab for it. We're going to create a new script, and I will call this UI manager, create and add. And once again, I'm going to move the script into the scripts folder inside of Unity, so that it keeps track of where the scripts are located for the game objects that already have components like UI Manager attached. Okay, so when we move it like this, it doesn't lose the reference up here. Okay, then we want to add it into this script. And let's create a game object public field. So public game object. And I'll call this damage text. We'll also have a slot for a health text. So public game object health text. I'll also say prefab at the end, because what we're implying here is that we're going to create instances of these. So let's delete, start, and update. So I'm going to create two functions here that we're eventually going to use in a Unity event. So let's do public void, and I'll call this character took damage. So for the parameters, we'll do game object character, and then int damage received. Then I'll also have a function character healed. Let's do game object character, int health restored. So this will be a to-do. We'll come back to that a little bit later. So when the character takes damage, we want to create the text at the location where the character gets hit. So to do that, we need to find the spawn position. And that's going to be using a function on the camera. So camera.main, which is your active camera. And we're going to do world to screen point, which means we take the world position of the character and we turn that into a point on the canvas, something that the rect transform can understand. So when you want to turn something from a world position into a canvas position, you use world to screen point. And then you need the position we're taking from the world to turn into a screen position. So that's going to be character.transform.position. Then we're going to want to instantiate a copy of our prefab, and we're going to set the text on it. So to set the text on a text mesh pro, we can get tmp underscore text, and I'll just call this tmp text, I guess, equals And we're going to instantiate a copy of our damage text. So damage text, the location where we're spawning it is this spawn position, which we just calculated. The rotation is going to be Quaternion.identity. And then the parent is going to be the canvas, which we have not gotten. So, and then the parent, which we're attaching it to, is going to be the canvas game object. So we'll need a reference up here to the game canvas. So public canvas game canvas. And for the instantiate, we'll do game canvas.transform. So the last thing we want to do, this gives us a copy of our game object. So when we have the game object, we want to get the TMP text component. So get component TMP text. I can make this 2 lines if that helps. And then we want to set the text on the TMP text to the damage we received. So TMP text.text equals damage received .toString, because we need to turn an integer into a string so that we can assign the string to the text. Okay, so honestly, we can just copy paste this down here for the character healed function, except that we're going to use the health text prefab. So copy paste that down there. And instead of damage received, it's health restored. So copy paste. And there's our healed function, which will respond to one event. And the character took damage, which will respond to another event. So to get the game canvas, when our script starts, we can do void awake, and we'll do game canvas equals find object of type canvas. So that will look in the root of our scene, the game level, and find the first object that is of type canvas. As long as you only have one canvas to find and that's in the root, it should go ahead and find it, and then we'll use that for creating the text into for the parent transform. So when you have a UI element, you should create it and assign it onto the canvas because it's a UI element. So we have the methods to invoke on our UI manager when a character takes damage or when it's healed, but we don't have those Unity events. Now before, what we were doing with the damageable component is we created a Unity event straight on the damageable component, and then other scripts inside of the same game object, we drag and dropped onto the inspector which function we wanted to call. But in this case, the UI manager and the damageable characters exist as 2 completely separate entities. And we might even have damageable characters that spawn after the game loads. So we can't actually set those Unity events up in the inspector. Instead, what we're going to do is create more like a global Unity event, a static Unity event, one component, the damageable, call that event with the .invoke, but we'll subscribe to it inside of the UI manager when the UI manager is awoken in the scene, or either awake or on start. So let's create a new folder in our scripts. I'm going to right click over here, add new folder, and let's call this events. Right click inside of here, add a new item, and this is going to be a C# class. So I'll just call this character events.cs. I'm going to get rid of the namespace. I'll change from internal class to public class. Let's give it a that, and just align everything like you would normally. And inside of here, we're going to create a public static Unity event, and this will be character took damage. And then the name of this event will be character damaged. For the parameters over here, I'm going to add in game object and int. So the object that took damage and the amount of damage it took. And let's also create the character healed event. So character healed, which is going to take basically the same parameters. Character healed and amount healed. Okay, so now that we have these events, we can invoke them inside of our damageable script. So let's go to damageable. Scroll down to where we get hit, which is on this hit function. So after we've already checked that it's not invincible, we're taking the damage, right? And that is where we should call the Unity event. So I'm going to do it right after we call the local damageable event, which was more to let other components know for physics reasons. And let's do character events. So we've got the class name here, and we're accessing a static field, which is character damaged. And we need to pass in the game object. So that's the game object of the damageable component. And then we need the amount of damage, which is just damage. Okay, and actually I forgot the .invoke with these parameters. So character events .character damaged, the name of the event, .invoke to call the event, trigger it, and then the parameters we're passing in. So anything that now subscribes to this event can be notified with this information. And we don't actually need to know anything about the damageable component. We just need to be notified that this event happened. So now we go back to character manager, And let's add in the trigger so that we can run this character took damage function. So let's do character events up here, dot character damaged, and we'll add a delegate method to it, character took damage. So character events dot character damaged, and we'll do add listener, and we need the name of the method we're going to call, which is character took damage. Okay, just make sure we spell that correctly. So it just needs to be the name of the method, and the parameters will just come in automatically. So let's do this again with character healed, just in advance. So character events dot character healed dot add listener character healed, the local method. And now these functions will run when these events are invoked. Now there's a chance that the UI manager would be disabled in the scene or removed from the scene. So I'm actually going to bring in a couple more lifecycle methods. So we're going to have void on enable, which is going to mean whenever this UI manager is made active in the scene. And then down here, we're also going to have private void on disable. So the reverse of it. So let's take these add listeners and bring those down to on enable. So awake only happens once. On enable can happen multiple times. And we want to make sure that we're only listening for these methods to call when our UI manager is actually active. So in reverse, we also want to remove the listeners when our script is disabled. And all we need to do is change add listener to remove listener. So I'll copy paste that down there. And now our UI manager should be properly subscribed to these events and can respond to them in our game whenever they need to. Okay, so back in the Unity game, let's remove this example damage text from the scene. I'm going to just delete it. And we already know that our characters can take damage. So I'm going to go into play mode, and we'll try taking damage from the knight and hitting the knight to deal damage to it. So let's hit play. And currently, we can see that it's not triggering yet. So let's see what the error is. Object reference not set. Of course. So let's go to the prefab for the UI manager. We have to set the damage prefab and the health prefab. So let's open UI, text, drag the damage text into here. I'm also going to create a copy of this prefab, Control V, to copy our damage text. And then we can rename this new prefab to be health text. Going to double click into it, and we'll just change the color to green. And that's all we need to do for some health text. So now the UI manager, we want to bring in the health text over here. Let's click the 3 dots for the UI manager script and apply this to the prefab. Now when we hit play, let's see if it works now. Okay, so still not. It is finding the canvas, so that's not the problem. Let's double click into the script and see what the issue is. Okay, so my bad. The reason here is actually that Unity events have to have some kind of component mono behavior game object attached to them. So what we really want to use for character events is Unity action. So this is almost the same thing, but you can't set these in the inspector. You have to set these inside of code directly. So if we go to UI manager, you'll see that add listener errors out. Instead of add listener, you want plus equals the name of the method. And we'll do that down here as well. But just FYI, if you do have a Unity event on a mono behavior, not a class that just contains static fields like this, then add listener and remove listener will work the same way that doing plus equals or minus equals on a Unity action will. The main difference between the Unity action and the Unity event is that the Unity action, you have to subscribe and code directly like this. You can't drag and drop in the inspector, and a Unity action would not show up in the inspector for that matter. Okay, so aside from this change, everything else should be the same. So let's go back to the game, hit play, and see if our text actually works here. Okay, so yeah, I can see the player's getting hit for 10 damage. The text is a little small, but it's definitely working. Let's swing at the knight, and there we have damage text for the knight. The only problem is the text is kind of small, so we can fix that quite easily. We'll just click on the prefab in the project, change the font size. Let's just make it something like 72, and I'll make that 72 for the damage text and the health text. Now let's hit play, get hit, and we can see that's much bigger now. So now we have damage text that's going to float away and remove itself from the game after it has been there for a second. And what's really interesting about all of this is that our UI manager doesn't need to know anything about the damageable components. We're just responding to the Unity action. And the damageable component doesn't need to know anything about the UI manager. It just needs to know to invoke the event so that other things like the UI manager can respond to it. So in our game, the player can already take damage, but we have no way to heal the player. So a good way of doing that for a platformer would be to create a pickup item which will instantly heal our player. So I'm going to jump into the art folder of our project, and we downloaded some icon packs in advance. So the Free Pixel Food Pack by Henry Software is going to contain a lot of good food items we could use for setting up our healing pickup. So let's jump into the food folder, and you'll see that we have a lot of these little 16 pixel icons we can use for a healing item. So in the project reference, I was using a dragon fruit to heal the player, but feel free to choose any food item you'd like for your game. So I'm going to drag this dragon fruit into the scene, which is going to immediately create a game object with a SpriteRenderer attached to it. If we want, we can leave the name defaulted, or we could call it something like health pickup to be a little bit more clear about what its purpose is. So now in the assets folder, let's create a new folder. I'm going to call it objects, and then we'll drag the health pickup inside of here to be a prefab that we can copy over and over again. On the prefab, I'll reset the position. Let's also double click into the prefab so that we can edit it. So if we want an item on the screen to be a health pickup, we're going to need to create a custom script for that. So let's create a new component, and I'll just call it health pickup. New script, create an add. In the assets folder, I'm going to move health pickup into the scripts. So like always, I'm going to bring the script from the assets root into the scripts folder with a drag and drop inside of the Unity project window. Now we want to open the script up for editing, so health pickup. So the first thing we're going to need in our health pickup script is going to be the amount we're going to heal. So I'm going to create a public int, and I'll call it something like health restore. I'll default that to 10. Well, let's actually make it 20, be a little bit more generous. And we can always, of course, customize this for each individual health pickup. We're not going to need an update method, but how we're going to heal the player is that we check when it walks onto a collider trigger zone. So we'll have to go back and add the collider in a minute, but for right now, we can do a void on trigger enter 2D. So first, let's check the damageable component on the collision. So damageable equals collision.getComponent damageable. And we'll check that that is actually valid to make sure that the character that walked in is on that layer. Now, as for filtering out whether enemies or players or any other type of character should be able to pick up the health pickup, we'll use the physics layers for determining that. So we just, in the script, want to make sure that the character has the damageable component. So on the damageable component, we need to call a healing method. So I don't think we've created it yet. Let's go into damageable. And similar to where we have public bool hit, let's create one that's, let's say, public void for now, and I'll call it heal, passing int health as the parameter. So we do want to check if the character is alive. So a normal healing item wouldn't be able to affect a dead character. And if that's the case, then we'll do health plus equals the health value. To be a little bit more clear, I should actually rename this to be health restore. So we add the health restore to the health of the character. We don't need to change the animators or lock the velocity or anything, but we do want to call the heal event that we created in the other video. So under character events, we have character healed. So this is when we're going to call that. So game object and int for what parameters we pass through. So let's come out here and we're going to do character events dot character healed, passing the game object and the health restored. So that's how we'll get the UI manager to create the healing text, which we already actually set up as well in the previous video. So that might actually be all we need here for right now. So on the health pickup script, let's call the heal function, and we're going to get the health restore variable passed through. And then we want to destroy the game object. So a health pickup is only going to be able to be used once, and then it just disappears. So to give a little overcap of what's happening, the health pickup detects that a damageable character walked into its box collider zone, and then we're going to call the heal function on the damageable component. When the damageable component gets healed, we invoke the event character healed, which means that any other components that have a function subscribed to the character healed event are going to run that function with game object and health restore as their parameters. So in the UI manager, we have character healed, which is going to spawn the health text. The difference between the health text, damage text, mostly just that the health text shows in green to show a positive number, and then the damage text shows red to imply that the character took damage. And then to make sure that that function gets ran, we add our subscribing method, character healed, when the UI manager is enabled to the character healed event. And we remove it on disable so that only a UI manager that's currently active can call those methods. So now in Unity, we still need a collider in trigger mode. So I'm going to add actually, let's do a circle collider this time, since the shape of this is kind of round. And we can actually just use the default values here. You can see the circle goes pretty well around the shape of the dragon fruit. So let's just set this to is trigger mode. And then we need to pick a layer for the health pickup to be on. So I suppose we could create a new layer here. I'll add a layer. Let's call this the pickup layer. So under edit project settings, physics 2D, the pickup is only going to be able to interact with the player layer. So let's disable everything else and then hit X, hit play to go into play mode. And let's jump into the fruit. So we get a 20 heal on the player. Now, one thing about that though is that our character, if we take a look at it, at the start of our script, it's already at max health. So we shouldn't be able to go above 100 for the health. And I'm going to argue that if we're not healing any damage, we shouldn't show that we healed damage. So I'm going to hit play, jump into this, and you can see that the health actually went above the max health. So we got to make a quick change to the damageable script. So let's go to the damageable script for our heal function. And instead of just adding directly to the health, let's change this up a bit. So the new health value is going to have a limit. So I want to have a, let's see, mathf.min function. So we take the lower of two values, and the first value is health plus health restore. And then the cap value there is going to be max health. So what we're going to want to do here for the heal is to figure out the maximum amount we can actually heal the character. So let's create an int max heal, and that's going to be equal to max health minus the health. And I want to wrap this in a mathf.max function. So we'll get the higher of the two values. So the two values are max health minus health and 0. So if the health is equal to or greater than the max health, then this is going to return a negative value. And in that case, we want to default the max heal to 0 because we can't heal the player above the max health, of course. And then when we add the health restore to the health, we want to take the lower of these two values. So the max heal will be our heal cap, and the health restore will be the expected amount to heal. So let's do a mathf.min here, taking the lower of the two values. So that's max health and health restore. And I also want to use this actual value for the character events. So we showed the exact amount that we healed. So I will replace this with a variable one line up, and I'll call this actual heal equals this. So the health is going to plus equal the actual heal. And then we're going to call the character healed with the actual heal value rather than the health restore. Okay, so I made a little mistake here. Max heal is supposed to be the min value here. So the minimum value of max heal and health restore. Let's go back into the game, hit play, jump at this, and we can see we healed for 0. So now let's hit play. I'll get hit once, jump into it, and you can see we heal for the 10 damage we were missing. I'll hit play now. Let's get hit at least twice. Okay, and now I jump into it and we heal for 20. So now the text responding to the health pickup properly shows the actual value that we healed for, not the min value. So now we can duplicate our health pickup all around our map as we choose. So if we select it and hit Control D in the hierarchy, and then hit W to go into the move tool, we can just drag our fruit all over the map. So let's duplicate it again, and I'll move one down here. And we can duplicate, and I'll put a couple more down here. Now, we go into play mode, we can jump into all of them, and technically they're all going to work exactly the same way. But right now they're kind of static. It's a little boring when they don't do anything. So we can actually take these icons and animate them. So I'm going to do that in the health pickup script. We'll create a rotation variable, and then with the rotation amount, we'll apply that to the transform of the object so that it keeps rotating. So let's create a public vector 3, and I'll call this spin rotation speed. And I'll set this to a new vector 3. I want to rotate on the y-axis, so I'm going to do a 0, 180, 0. Then we're going to need a update function, so void update. And we just want to apply the spin rotation speed times the time.delta time and apply that to the rotation on our transform. So the way you add a rotation value to the current rotation value is that you use transform.Euler angles, and you're going to want to plus equal the spin rotation speed times time.delta time. And I think that's all we need to make it spin. So let's go back out to the game. I'll click on our health pickups, and you can see the spin rotation speed measured in degrees per second. Let's go ahead and hit play, and we'll see that our icons are rotating. The health pickups are rotating. They still work exactly the same, being able to heal our player, or to be completely wasted if we happen to have not taken any damage. So one change we could make as a quality of life improvement for the player that's different from the reference project is that we can limit it so that we only pick up the health pickup when there's damage that actually needs to be restored. So to do that, we can add a Boolean to the damageable heal function. Let's go to definition. I'll call it public bool heal here now, and we'll return whether the character was healed or not. So the condition here is going to be and health is lower than max health. So if that's not the case, we're not even going to try to heal the character. We're just going to come down here to the bottom and return false. But if we do heal the character, let's return true. And then on the health pickup, we can now use that Boolean. So Boolean was healed equals the results from the heal function. And then before we destroy the game object, we're going to check if was healed. Then we destroy the game object. So this means that a heal pickup, even when we collide into it, if it would be wasted, it won't be used. It'll just remain on the screen for us to use later. So let's go ahead and hit play. I'm going to jump into it, and you see nothing actually happens. But let's get hit a couple times. So we've taken some damage. Now I'll jump into it. We get healed. I'll come back up here to the top one, and we jump into it. No damage to heal, so it doesn't get wasted. So that part is a complete personal preference option, just if you want to be nice to the player and not have them waste their resources like that. But to show that it is working, I'll temporarily set the max health to 200. Let's just jump into a couple of these. So we got that first heal, and then down here we have a couple more. You can watch the health value on the inspector going up. So we're at 160 out of 200 max now. So it appears to be working correctly. And just to wrap things up, I'm going to reset the max health to 100. So in our next part, let's start adding extra attacks to the player characters. So we have a second sword swing attack and a third swing sword attack. And we'll be making it so that we can transition to those new attacks at a specific exit time. We'll talk about more of that. So we'll need to create a way that we can transition from attack 1 into attack 2, and then attack 2 into attack 3. And we'll be setting up a exit time, a transition time, and a trigger in order to set that up. And then we'll also make it so that if you do decide to attack a second or third time in a sequence, that will have scaling damage. So the second attack will deal more than the first, and the third attack will deal more than the second. So let's start by jumping into the player prefab, and I'm going to go over to the animator, and in the top right where I have the animation window, I'm going to open this up, and we're going to create player attack 2 and player attack 3. So let's create a new clip, player attack 2. I'm going to save this in characters. Player, just save it in here as a .anim file. Change the samples to 10, and then let's go into the art of the project and find the animation frames. So under RVBoss Adventurer, individual sprites, let's grab everything for Adventurer Attack 2, and I'm going to drag those into the keyframe window. So let's hit play to test it, and there's our second sword attack. Now, if we look at Sword Attack 1, you also see that the Polygon Collider needs to be enabled or disabled here. So if we look at Sword Attack 1, you'll remember that we have that Polygon Collider with a specific shape that we're enabling or disabling. So we need something similar on Player Attack 2. But if I click on the Sword Attack child game object to see the outline of our collider, let's go to where the sword swing is. And you might decide that this shape doesn't exactly match what the sword swing is doing here. So we might want to create a secondary sword attack shape for our second attack and later our third attack too. So the different attacks will hit in different locations. For the time being, let's also create player attack 3. So player attack 3, change the samples to 10. And let's drag the frames for attack 3 into the keyframe window. So now we can hit play and see our third final attack. Obviously we can tell that the hit collider on this is going to look quite a bit different than this sword attack, much lower to the ground. So a quick way of solving this will be to duplicate the sword attack and then enable or disable it depending on which attack animation we're in. So I'm going to duplicate and we'll have sword attack 1 up there. Duplicate again, sword attack 2. I'm going to rename these to be sword attack 2 for the one that had the 1 in parentheses, and sword attack 3 for the one that has 3 in the parentheses. I can also take sword attack 1 and just add a 1 to it to make sure that we know that there's a sequence of numbers here. So as you could see in the sticky notes, at one point I decided to put the scaling damage into an animator parameter, and then we would grab that in the attack script. But I think that if we're going to be doing things this way, where we have 3 different colliders, each with their own attack script, it's much easier to just have a different number here for Sword Attack 2 and Sword Attack 3. Also, that allows us to set custom knockbacks for each one just by reusing the attack script. So Sword Attack 2 can be a 15 damage, let's say. Sword Attack 3, let's give it 25 damage and a 5 for the knockback. And I'll also change the knockback to 5 to make it a lot stronger. So the third hit will definitely knock back the enemy. So this method is just a lot more straightforward than using the animator parameters for controlling the attack. So this method is just a lot more straightforward than using the animator parameters for controlling the attack damage and knockback. Now we just need to customize the polygon shape collider for each animation. So let's switch to Attack 2 so we can see what it's going to look like visually. Go to the frame where we're going to have the player be hit. And let's temporarily turn off Polygon Collider on Sword Attack 1 and Sword Attack 3. Click on Sword Attack 2 so we know which one we're working with. Hit Edit Collider. And let's just reshape this to whatever we think would be good for this collider to have. And there'll be a limit to how far we want the sword swing to actually deal damage. I'm thinking somewhere around here is good. So we'll only damage on the swing down, but not the draw back here for our Sword Attack 2 hit. So now in the animation, Player Attack 2, let's go to frame 1. I'm going to add a property, Sword Attack 2. Make sure you're selecting the right attack object. Take the Polygon Collider, set it to enabled off at frame 0, and then find the frame where we are swinging, enable it. After that, on this 0,4 frame, I'm going to disable it. And let's make sure it's disabled at the end as well. Then we just need to make sure it's also disabled by default, which we can see clicking on it that it is. Let's also go to Sword Attack 1. So that's still disabled by default. And now let's set up Sword Attack 3. So I'm going to enable it temporarily. Let's go to Animation, Player Attack 3. I'm going to add the property, Sword Attack 3, Polygon Collider, enabled. Let's disable it on frame 00. Go to where we hit the target, enable it. The frame after, I'm going to disable it. And at the final frame, we're also disabling it. So now we just need to go to our hit frame, which is right here, 02. Let's go to the inspector, edit the Polygon Collider, and reshape it so that it matches the arc of our sword swing. Okay, I'm going to need a few more points. So something like this matches the shape pretty good. Maybe we want to go a little higher with this as well. So we could be a little more generous. Say something like that as the hit collider for the sword swing. So now we have Sword Attack 1 with that shape, Sword Attack 2 with this shape, and Sword Attack 3 with that shape. If you prefer a simpler, just more straightforward box collider, feel free to use that. And then just if the target's within the box, they'll get hit. That'll probably work just fine in 90% of circumstances as well. I just kind of feel like playing around with a more custom shape here for our character. So now just make sure all the polygon colliders are off by default. Go to the main frame. I'll check the colliders here as well. Sword Attack 1, 2, 3. Got to make sure that's disabled. Okay, and now we can jump into the animator where we'll add the sword attacks to the attack state. So in animator, let's go out to the base state. You'll see the new animations, Player Attack 2, Player Attack 3. Gonna select these, Control C, jump into ground attack, Control V to paste them in. Back to the base layer. I'm gonna delete Player Attack 2 and 3 from here. Let's go to ground attack. And now we need to set up some more transitions. Okay, so from any of these attacks, if nothing is a follow-up attack after the attack animation is completely played, then I simply want to exit the attack substate machine the same way that we did with Player Attack 1. So I'm going to right-click, make a transition from Player Attack 2 to exit, Player Attack 3 to exit, and then I want to take each of them, exit time 1, duration 0, and then the other one, exit time 1, duration 0. So the idea is that if you want to progress into attack 2, you need to press the attack key again before the animation already transitions out towards the exit. So let's right-click on Player Attack 1, make a transition to 2, right-click on 2, make a transition to 3. And the requirement here is that we use the attack trigger. So I'm going to hit plus to the conditions, and let's add in attack. For the exit time, 0.75. So this means if the trigger is set by this point, 0.75, or somewhere after here, I believe, then it will try to make the transition into Player Attack 2. But if we haven't pressed the attack key, by the time it reaches the end of the animation, then we simply exit and return to our normal idle walk cycles. So exit duration 0.75 and transition duration 0.25. I believe those are the settings I had, which seems to work pretty well. So we'll do the same thing on player attack 3. So plus, let's go into attack. Exit time 0.75, transition duration 0.25, and that should pretty much be it. So let's hit play, and I'll see if our character can swing 3 times. So 1, 2, 3. Yep. Okay, cool. And let's go and hit the guy. 1, 2, 3. So our second and third attack hit. You saw that one did 15 and the other did 25 damage. For some reason, the first hit isn't working right now. So let's go ahead and troubleshoot that. Into player attack, let's click on sword attack 1. Let's go to the animation. So player attack 1. Okay. Yeah, right. So here's something we got to be a little bit careful about. When we rename our objects, it also messes with the animations in this window. So in order to fix this, I actually need to re-add the name of the object back into this animation. So I'm going to have to add a property, sword attack 1, polygon, collider enabled, and we just copy the settings from up here to down here. So let's see if I can just Control V paste that in. Okay, looks like it. And now I can delete the yellowed out sword attack and remove that property. And this is going to work just like it did before by the looks of it. So at least you can copy paste it. That's pretty cool. Let's hit play and test it out. So 1, 2, 3. Yep, we got 3 hits going on. 1, 2, 3. Now one thing that we might not like is that our sword attack, the first 2 actually knock the character back a little too far for the third hit to actually hit. So just as a design kind of thing, I might go into sword attack 1. I might change the knockback to 1. Sword attack 2, change it to 1, and then only on the third one do we get that strong 5 knockback. So let's hit play. Let's get hit, and then 1, 2, 3. And then 1, 2, 3. Okay, so when we hit play, and we have our little knockbacks on the knight, we can see that it's kind of working, but it's also a little bit glitchy in a sense. So I think what might be going on is that when the knight returns to its hit state, it immediately reverses the direction on the velocity, since it's just instantly setting that new velocity. So what we might want to do with the knight enemy is make it so that it has to accelerate towards its max speed rather than just instantly setting it, because I can see that right now it is a little bit wonky. So let's go to the knight enemy, and I'm going to open up its script, and let's add a new variable to the top, which is going to be public float max speed, and I'll make that 3f. And then I'm going to take the walk speed and I'm going to make it walk acceleration. Right now I'll leave it to the default value 3f as well. So what we're going to want to do is add the acceleration to the velocity when it's trying to walk until we reach the max speed, and then it won't be able to increase its speed more than that. So in the fixed update method for the knight, we're going to do a calculation function to get our x velocity. And this is going to require us to clamp between 2 values, so mathf.clamp. And so we need to start with the current velocity, rb.velocity.x. And then we're going to take the walk acceleration times the current walking direction. So walk acceleration times walk direction. Let's see, walk direction vector.x. And then we're also going to multiply this by time.fixed delta time, which will make it so that our increase in speed scales with the amount of time between frames. Okay, so this is getting a little long, so I'm going to move that to a second line. So we have the RB velocity plus the walk acceleration times the direction times time.delta time. Okay, and then we need the other 2 parameters. So that's going to be, as the min value, negative max speed, and then the positive value, max speed. Okay, so let's see. Why is that giving an error still? Embedded statement cannot be a declaration or a labeled statement. But I guess we can just take this and set it directly down here. So I'm going to replace the walk speed times the walk direction vector by our math calculation here. So let me organize it and put everything on one line. So to walk you through what's happening here. So we start with the current x velocity, and then we increase it in a certain direction based on if we're facing left or right. And as we increase the value, we limit it with the clamp value to the negative max speed or the max speed. So the negative max speed is just the max speed, but in the left direction. And then the max speed is the actual max speed, but also in the right direction. So we have a limit on how fast we can move to the left and a limit on how fast we can move to the right. And with the RB velocity y, we leave that alone. That's just based on gravity. So we're only changing the X value here. Go back to the game view, hit play, and see if we get that acceleration towards our max speed. So the knight won't. So if we go out and we hit play, we'll see that with the acceleration of 3, it barely moves at all. But if we change this to 30, it actually accelerates to the max value pretty fast. So I think that's what I'm going to test with. Let's do a max acceleration of 30. So the reason why with the 30 it takes so long to get to the max speed is because the time.fixedDelta scales this down a lot as the amount of increase between frames. So let's hit play and we'll get hit. Let's see how our knockback works. So we have 1 hit, 2 hit, 3 hit. And now when the knight regains its control after the hit animation, you can see that the knockback doesn't just completely go away and then it has some weird direction reversal. And just FYI, if you wanted the player character to work with the walk acceleration as well, you could do that. So if we hit play, let's hit the knight a few times. We can see it's kind of glitchy still. So for the hit to move, let's change the settings here a little bit. I'm going to turn off fixed duration, and let's say the transition duration is 25%. Oh, I guess we need that as a float. So 0.25, exit time 0.75. So let's hit play and see how the transition exits. Okay, I'm liking that a lot better. It doesn't seem to be doing any glitches or randomly switching direction or anything like that. So that's much, much better. So on the knight enemy, we might also say that we can just increase the walk acceleration, since we already have it there, to a higher number. That way the knight can reach its max velocity much faster. So let's hit play. Okay, I'll hit him a few times, and our knight's accelerating pretty fine. Yep. So the main issue there is probably just having no transition duration on hit to move. I'm going to jump into the move, and let's actually take the transition duration off of the run to attack. And then let's hit play, and let's see if it can work well without that. Yeah. Okay, so the problem really wasn't the run to attack. It was definitely the hit to the move state. So we test our animations, and yep, it's just working a lot cleaner now. So the walk acceleration wasn't really the problem there. I was sort of doing it live. It's definitely the hit to the run transition, but now you know how to script it where you accelerate towards a max speed rather than just ending up there instantly. So I think I like this movement a little better for the knight, so I'm just going to keep it. But the main thing is just to test your animations and make sure they flow into each other smoothly. So transition duration definitely makes it a lot better there for the knight. So after this video, ended up being making a few extra improvements to the knight, but in the process we did make the attacks on the player work nicely. They all have their own custom attack values, hit knockback values, and we transition into each attack by clicking the attack key an extra time. So I think it didn't really show it, but you can actually stop the attack by just pressing twice, and you see that it goes to the exit. So we can do a 1-hit attack, a 2-hit attack, or do the full combo for 3 hits. So that's pretty cool. So in this next part, we're going to work on projectile attacks for our character. We'll set up the bow animation. Then we'll create a new trigger, a ranged attack trigger. So we'll be pressing down a different button when we want to cause a ranged attack like a bow shot to happen. And that means we're going to be setting that up on the player input action. And that means we're going to be setting that up on the player input component. And on the release frame of the animation, we want to create an animation event where at that moment in time, we fire the projectile. And we'll be creating the projectile as a kinematic body instead of a dynamic mode rigid body, so that the arrow will ignore all physics except for the movement we set in the script. So first off, inside of the player prefab, we're going to create a new animation. So I'm going to click on the drop down of the animations. Let's go into the assets folder, characters, player, and let's create the player. I guess we could call it player bow or player fire. I'll go with player bow, since maybe you'd have multiple ranged projectiles. So player bow, I'll save that animation, change the samples to 10, and now inside of project, RV Boss Adventurer, we're going to find the bow animation. So frame 0 to frame 8, drag those in, and let's hit play to see it. Okay, so there's our shot animations. So I need to have an arrow appear right at this moment where the wind appears on the bow firing. Now just in advance, I'm going to take this animation and I'm going to turn off looping, because each time you press the bow fire button, we should fire 1 arrow. So there's no need for that animation to loop. Okay, so on player, animator, let's go ahead and create a new trigger. I'm going to click add trigger. and this will be ranged attack for now. I can move it up the list next to attack just for organizing. And then we have this bow fire. So the bow is something we're going to be firing from ground state. So I can create a transition, make transition to player bow, and player bow back to ground states, state machine, ground states. This exit transition, of course, would just be at exit time 1 and transition duration 0. But the trigger to come into the state is going to be ranged attack. And then in ground states, we can set another exit transition, same as before, where all of our ground states go to the exit. And the reason for that occurring this time is going to be the ranged attack trigger is set to true. And then for has exit time off, transition duration 0. So just make sure you have those same settings for all of them. Transition duration 0, trigger, ranged attack 0, no exit time, transition duration 0, and ranged attack. And that should set up the animator for the player bow. So now we need to set up the import action on the player so that we have a way to set the ranged attack trigger on our animator. So click on player, and let's go down to our player import. I'm going to double click import action asset, and let's add a new action. And I'll call the action, let's say, fire bow. Or actually, I'll rename that, and let's make it ranged attack. If we're only going to have one button to press for all ranged attacks, then this might make more sense for an action name. And then maybe with more developed platformer character, you could have a way to cycle through which ranged weapon is selected, and then it just fires the selected one with this button. Not something we're going to personally set up in this course, but a direction to head in the future if you want to keep building on top of it. So with ranged attack, let's add in a binding. So I'm going to click on no binding here, and let's do path. Listen to whatever key you want to press. In the reference project, I used F for firing the bow, so that's what I'll use here. I press F and then choose it from the list. Okay, and now we have our keyboard and mouse set up, so I'm going to check that for keyboard and mouse. We use the F key to fire the bow. And let's save that. Now let's go into the player controller script. And we'll need to create a on ranged attack method, which is basically going to be just like this on attack. In fact, we could just copy this if we want. So I'll copy this down there, and let's change the name on ranged attack. So it's still going to be when the button is first pressed down, context started. Then we're going to set the trigger, and it's going to be ranged attack trigger instead of attack trigger. So let's hit control period to generate the ranged attack trigger in the animation strings. Going to right click on it, go to definition, and we'll set the name here. So ranged attack trigger is equal to ranged attack. And just double check and make sure that that matches the animation parameter here. So after verifying that, we need to go look for the Unity events and player import. I'm going to drop down events, player, and we have our new one down here, ranged attack. So let's click plus. I'll drag in the player object from the hierarchy to here. And let's choose a script from the dropdown, and we want player controller on ranged attack. So let's hit play, and now we press the F key, and you can see our ranged attack animation plays out. And after the animation is done, we return to the idle states. So that is pretty much working as intended. The only thing is that the character can also move while it is in that state. So we probably want to set something up like we added with ground attack. So we can see that when ground attack is active, can move is set to false. So we want to set up the same set bool behavior on the player bow. So I'm going to click on player bow, add a set bool behavior, and we're just copying the same information over. So the bool name can move, the value on enter is off, and we're updating on state instead of state machine. So state machine here, single state over here. And then the value on exit should be true. Okay, that looks correct. So let's go back out. I'll jump up here to test. And hit F to fire, and you'll see that we can't move while firing. We can reverse direction, which I think is something we probably want, because maybe when you press your arrow fire, you're accidentally charging up in the wrong direction. So this allows the player to kind of reverse their direction and fire the correct way towards the enemy. And I think that makes sense. Okay, now we need to create an animation event to fire the projectile. So that means somewhere on our player game object, we need a component which has a function to fire a projectile that we haven't created yet. So I'll do this kind of like the sword attacks as their own child game object. Let's right click, create empty, and I will call this bow attack. For the bow attack component, let's hit W to go into move mode and offset it to basically where the arrow should be spawning. And to know that, let's go to the animation tab and just look at the bow animation. Find the frame where the arrow should be firing. So right there, let's take the bow attack and just move it down to probably right around here. So this will be where we spawn the projectile. So now we need a new script attached to this bow attack. We can call it something like projectile spawner or projectile launcher. I like launcher, so that's what I'll go with, projectile launcher. Let's edit the script. At the top of the script, we'll need a public game object, projectile prefab. So the projectile that we want to spawn. Then we're going to need a function we can use on the animator events. So that's going to need to be a public function. So public void, I'll call it fire projectile. Nothing for the parameters. And if this event triggers, then we are going to instantiate a copy of the projectile prefab. So when we create the projectile, the second parameter is going to be not the transform of the parent, but the position of the parent's transform. So projectile, So we want transform.position. So for the rotation, we can just get whatever the default rotation on the prefab is. So projectile prefab.transform.rotation. I think we can just set that there. And then the transform parent, we don't actually want a parent game object that this is going to be falling under, or maybe we would if there was some kind of projectile manager in the game. But for right now, I think we can actually just leave that blank. We'll just have these three parameters. The object we're creating a copy of, transform.position for where to spawn it, and then projectile prefab transform rotation, just copying whatever the default rotation is into this new object. Okay, so if we go back out to the game, we should see a slot for the projectile prefab on our projectile launcher. So let's create our new prefab for our projectile. I'm going to go out to the base of the project. Let's right click, create a new empty. So in the base of our project, I'm going to drag this straight arrow modified I have here into the scene. You can double click on it, and then this can be the base shape of our arrow. So I was just editing something to use, kind of basing it on Kaire's RPG icon pack, the arrow 1C and arrow 2C. That's kind of where I got that from. I just made it so that it's facing forward by default, since that's more appropriate for our character to use as an arrow. So I'm going to rename this game object to arrow. Let's add a new component to it, and I'll call it the projectile component. I want to keep it as generic as possible so that we can reuse the component. So let's create the new projectile component, and let's edit the projectile script. So inside of here, we're going to have a float move speed for the projectile. This will just be a consistent speed without any acceleration or anything. And we do want to make that public so that we can customize it in the inspector easily. Let's also make a public int damage, and I'll default that to 10. So we're not going to need the update method. We're just going to need to set the velocity of the rigid body on start. So we'll need to get access to the rigid body 2D, RB, and then void awake. Let's do RB equals get component rigid body. And then on start, we'll do RB velocity. It's going to be equal to a new vector 2 with the move speed times the scale of the transform. So transform.localScale.x to make sure it's facing the right direction. And then the Y velocity, we will set that to 0 for now. Actually, though, you know what we could do? There might be a projectile where we would have wanted to have a Y velocity. So let's take the float and let's turn this into a vector for the move speed. So vector 2 move speed, and this will be a new vector 2, 3f, and then 0 for the default values. So now we can do move speed.x, and then over here we can do move speed.y. So we're going to have the projectile be kinematic by default, but if you want it to be affected by gravity, you could just make it a rigid body in dynamic mode to do that, since that will make the gravity apply automatically. But to make the movement 100% just controlled by this line here, that's why I'm going to do kinematic mode. So no other physics is going to affect the projectile. So when the projectile is moving, we do need to detect when it does enter the collider for, let's say, the player or the enemy, a target that can take damage. So we're going to need a void on trigger enter 2D, which of course means we need some kind of collider shape on the projectile. And then we need to make sure that the target is damageable. So damageable equals get component damageable. We'll check if the damageable does not equal null. And I mean, we can actually just go to the attack script and we're going to kind of want to check here for that stuff. So we can also add a knockback if we want, but basically we're just going to be calling the hit function. So yeah, why don't we actually just copy this stuff over from the attack script to the projectile script. I'll just paste it in there. And this way we'll be able to have a knockback. So let's add in a public vector2 knockback, and that will default to a vector2 0 0. And then we can do the hit function with the knockback as well. So a projectile has the option of having a knockback. If you don't want it to do any knockback, just make the knockback vector 0, which is the default. Okay, so then we need to pass in the damage of the projectile. So damage to the hit function. And then down here for the debug message, we'll also do damage. That should pretty much be it for our projectile script. Let's turn the arrow into a prefab. I'm going to do it under objects. Let's right click, create a folder. I'll call it projectiles. Double click into it, drag this in. And the assets folder, let's also make sure our new scripts are in the scripts folder. So I'm going to drag projectile and projectile launcher in there. Okay, and now we can remove the arrow from our scene. We just got to go into the prefab for the player. And on bow attack, let's drag in the new projectile. So bow attack, drag an arrow from the project window into the projectile prefab. So this projectile launcher could be used to instantiate a copy of any projectile you come up with. And that's why I left it kind of generic. So let's see how much it's working right now. I'll hit F. So it's not going to do anything yet because we haven't set the triggering event to create or fire the projectile. Let's click on player, animation, and then for bow, we need to create a animation event in here. So we already wrote the fire projectile function. We just need to call it at the right time. So that is going to be the exact moment where our arrow is supposed to be firing. So let's right click, add an animation event in the animation window. Now click on that little notch that just appeared. Make sure it's highlighted blue. Then go to the inspector and we can choose which event to call for that. And that is going to be the fire projectile. So I don't actually see it on the list here, and I think I know why. I think that for the animation event to be called, then the component where you're calling the function from actually has to be on the player. So we don't need to change too much. We're just going to need to take the projectile launcher and put it on the player. So I will drag and drop that over there. We're still going to keep the bow attack for the transform. But now on the player, we have the projectile launcher script. We need to specify which transform we're going to use for the bow attack, because now we don't want to use the player's location. We want to use the bow attack location. So let's edit the projectile launcher, and we'll have a public transform, and I'll call this launch point. And then we need to use launch point dot position when we're instantiating the projectile. So now at the bottom of our player script, we'll see the launch point transform as a slot to put into here. So launch point, we just drag bow attack right into there. We have a transform set, and that'll get used in the script. So that's all we should have to do. Let's hit play. So with that set, let's go to the main scene. I'm going to remove the arrow from here. Let's hit play, and I'll try pressing F to fire an arrow. So we don't actually get the arrow to spawn yet. So of course, now that we moved the script, we need to make sure that we add it to the animation event. So under animation, player bow, let's go to the fire point, right click, add the animation. With that selected, go to the inspector, look for the functions. So we're looking for fire projectile now. So down here at the bottom, we have fire projectile. Okay, good. And let's go ahead and test it. So I'll press play, and let's hit F to fire our projectile. So it definitely gets created, but we can see it doesn't have a rigid body attached to it. So we just have to add a couple components. Let's open up the prefab for the arrow. In the inspector, we'll add a rigid body, 2D. Gonna make it kinematic mode. So we're not using the built-in Unity physics to control it anymore. And let's add a component, which is going to be a circle collider. And this is going to be where the arrow can hit a player. So I'm going to hit edit, and let's shrink the size of the collider. And then let's also move its offset. I'm going to change the Y to 0. I'll drag the X over to the right, and then we can increase the size a little bit more. Just kind of going to the head of the arrow shape. So that should be good for our collider. Now the last thing we need to do is to change the physics layers to make sure that our projectile can only hit enemies if that's what we're going for. So I'm going to change this to be a player hitbox because I only want to hit enemies with this arrow. Now one other thing we should add to the projectile script, now that I think about it, if our character did get hit, we want to destroy the projectile. So destroy game object, and we can actually do that after the debug. I want to make sure that that's the last thing that happens so that the debug can actually run. So we'll destroy the game object after the arrow hits because we assume it can't hit multiple targets. But that's obviously an optional thing. You could have an arrow that passes through all the enemies it hits and hits each one one or more times. So for now, let's go back to the Unity game and let's see if we can fire the arrow. So I'm going to go to play mode. Let's hit F and we have our projectile. Let's see if it hits. Okay, so super OP. It is actually doing physics on the enemy, and that's not what we want. So let's look at the arrow again. And the reason for that is that we haven't set the Circle Collider to is trigger mode. So make sure you do that. We want to damage enemies. We don't want to push through them with infinite force. So let's hit play again. Going to dodge the attack, hit F to fire an arrow, and let's see if it hits. Okay, object reference not instantiated to an object something something. Okay, right. We can't use the local scale of the parent's transform because there is no parent for the projectile. So we need to use its own local scale. So transform.localscale.x on the projectile. Okay, so let's hit play and test our projectile out. So we can hit the knight. That's cool. Let's also try turning the knockback onto the arrow. So I'm going to open up the arrow projectile and let's give it a insane knockback, like 10. All right, play. And then let's try that again. So it's going to hit the knight. And boom, right off the cliff. So there's two problems that are happening right now. One is that the projectile always fires to the right, regardless of which direction the player is changing. So we need to inherit the scale of the player when we fire our arrow. And also I noticed that when we hit the knight into a wall like this, it keeps trying to switch the direction. So we should turn off switching direction when the knight is in the air. So let's take care of the fire direction of the player first. Since the projectile launcher is now a script that we're attaching to the player out of necessity for the animation, we can also use it to inherit the player's transform local scale. So let's go into the script for the projectile launcher. And when we instantiate the prefab, let's get a reference to it over here. So game object, I'll call it, let's just call it projectile. That's the most straightforward. So what we're going to need to do with the projectile is change its local scale based on the parent's local scale at the time of projectile firing. So let's do projectile.transform.localscale, and that's going to be equal to a new vector 3. So this will get kind of long, so we'll put it in 3 lines, I think. So we'll do projectile.transform.localscale. Actually, you know what? We can make this just a vector 3 variable. Less typing. So vector 3... I'll call it vector 3 orig for original, and then we'll do scale equals projectile transform local scale. So now when we're getting the values, we can just replace that down here. So we want to take the x, and then we need the original scale dot y, the original scale dot z. So for the y and z, we're going to leave that alone, but for the x, we want to multiply that by a new value. So we're going to multiply that by the transform of the player, or the character which the projectile launcher is attached to, the transform local scale dot x, and we're going to see if it's greater than 0 or if it's less than 0. So if it's greater than 0, we're going to multiply it by 1 because facing the right direction. Otherwise, we're going to multiply that by -1. So this will allow us to flip the projectile's transform based on which direction the player is facing. So flip the projectile's facing direction and movement based on the direction the character is facing at the time of launch. So as for the other problem, where when we hit the knight off a cliff, its movement's kind of crazy. Let's try turning the knight's movement off entirely when it's in the air. There would be other ways to do it, but I think this is the most straightforward. So let's say if can move and is grounded. So touching directions dot is grounded, then we're going to take the velocity and we're going to accelerate it. Otherwise, we're going to just drop the x velocity towards 0. So let's give that a shot. I'll hit play. Let's hit the knight. Okay, that seemed to work pretty well. So let's hit play one more time. Hit him with the arrow. When he hits the wall, he doesn't get stuck really because his velocity drops towards 0. It does take a split second for the hit animation to finish. which I think is all right. We could have it churn off the hit animation automatically when we're in the air, or switch to a different animation if we set that up in the animation controller. But I think this is going to work pretty good, okay. All right, yeah, I like that. Okay, the last thing I want to change about the arrow is that it moves way too slow. So let's open up the arrow prefab, and I'll look in the inspector for the projectile. Let's just take the move speed and make that something like 8. Let's go into play mode, hit F, and now we have a much faster arrow. The knockback's probably too much. I mean, I only had it like that for testing. So you could take the knockback and set it to something small like 2, maybe 7 for the move speed, and damage, I'll set that to 15, why not? Use whatever numbers you want. But we can test it again. And yeah, we can see once we have it set up, it's fairly easy to make changes for how it actually works in the gameplay. And that's very Dead Knight. Okay. So in our next part, let's create a new type of enemy. So this will be a flying eyeball. Obviously, it'll have the ability to fly and ignore gravity. We'll have to do the standard stuff like putting it on the enemy layer, setting up a capsule collider so that it can be hit, and giving it a damageable component since it is a combatant in the game. It'll have a floating movement, so we'll make it so that it can move between waypoints when it is in its normal fly movement state. And on death, we'll make it so that it can fall to the ground to die and fade out from the game. So to create our new enemy, let's go into Art, Lewis Mello, Monster Creatures Fantasy, Flying Eyeball. And I will grab the first frame out of Flight. Okay, so we can see that we haven't separated these sprite sheets yet, so we have to click on each one and go to sprite mode multiple. So now we can open up the sprite editor, slice this by the cell count. So I think we're looking at about 8 cells here. Let's try 8. Okay, that's correct. Slice, making sure that the center point is in the center there. So these frames have been created nicely for that. And let's hit apply. Okay, now we can just drag flight 0 onto the scene, and then that will be the base for our character. So let's do rename of this, and I'll call this Flying Eye. I'll go into the characters enemies folder, and let's right click, create a new Flying Eye folder to hold all the animations and stuff. Double click into it, drag the game object into here, and we have our prefab with the SpriteRenderer. So let's jump into the prefab for the Flying Eye. I'm going to immediately change the layer to enemy. I'm going to add a component. Let's do rigid body 2D. I'm going to churn off freeze rotation, and I'm going to set the gravity scale to 0. I'll add a component for our capsule shape. So capsule collider 2D, and let's resize it using edit collider to fit our character better. So I'll drag on the sides first, and then pull the top down and the bottom up to give us a decent hitbox for the enemy. Make it a little bit bigger. Okay, that looks pretty good. Okay, so we have those components. Let's add in a damageable. So this will have the health of our enemy. Maybe this kind of enemy, we want to set the max health to 50 and the health to 50. Let's just go with that. So I think if we hit play now, well, it's being affected by gravity, but I think we could fire an arrow at it and still deal damage. There's no animator on the game object yet, so I guess we need that. Add a component, animator, and that's going to mean we're going to need an animator runtime controller. So in the Flying Eye folder, let's create a animator controller. AC Flying Eye, click on the prefab, and drag in the runtime animator controller. Okay, let's hit play, and we're probably going to need to add some variables here. Let's fire an arrow at it. Okay, so hit for 0, and we see we don't have the hit or the lock velocity parameters. So let's add those in for the enemy. So trigger hit, and then Boolean lock velocity. Okay, at a minimum. Let's hit play again. Test that. So I'm going to fire an arrow. And let's find the one in our game scene so we can see hit and lock velocity was set to true. Now, the Flying Eye is not supposed to fall due to gravity. So let's take the gravity scale and set that to 0. And the inspector, apply to Flying Eye. So we can hit play. We can fire an arrow at it. It's not going to move from that as well. So we should probably set up the animations for it now. So let's set up flight, death, take hit, create clip. And I'm going to make sure this goes in the characters folder, enemies, Flying Eye. So we want Flying Eye, flying, I think is what it was called, or flight. Well, whatever we want to call it is fine. Samples to 10, bring in all of the frames, and this will be a looping animation. We can hit play, and there's our Flying Eye loop animation. Let's create Flying Eye attack. grab 10 frames. And then we need to figure out which of these attack animations we actually want to use. I think that they are 3 totally separate animations here. So we can open up the sprites and take a look at them. So this is kind of interesting. It's like a spin attack. That's not the one I was using in the reference project, but that could be cool for something. This looks like kind of a wing attack of sorts. So we could use that one as well. But the one that I used in the project was just its simple bite attack. So the player walks into its attack zone, and then it just takes a chomp out of the player. So we'll just stick to the reference project. I don't want to go too far off the original. So let's take the attack, sprite mode, multiple, sprite editor, apply, and then let's slice up the sprite sheet. So let's go to grid by cell count. Looks like 8 columns, slice, apply. And then let's bring all of those frames into the attack animation, just like this. And then we can test it. There's our attack. Okay, so now we need hit and death. So FlyingEye hit, 10 samples, take hit, and let's turn it into sprite mode multiple, sprite editor, apply, and let's slice this with 4 columns. So it's a 4-frame animation, apply, bring in the frames into the animator. So take hit 0 through take hit 4, just drag them in, test by hitting play. There's our hit animation. And then we need FlyingEye death.anim. And let's get the sprite sheet. So same process, we put it in multiple, sprite editor, apply, slice, count the number of frames. So 4 columns, apply, go to animation, make sure the samples is 10, and then let's bring all of those in. So 4 death frames, and we can test our death animation. Okay, so if we look at the animator for our FlyingEye, you'll see that we have our 4 animations here, like so. If you think you might use multiple of the FlyingEye attacks in your character, you could just go ahead and create a substate machine in advance for it. If you think there's going to be some special behaviors that should happen in the attack substate, which has been the case for our other characters. So I guess I'll just do that. Let's click on the new state machine and rename it to the attack substate machine. I'll copy flying attack and paste it into here. We'll come back to that in a minute. For right now, I'm just going to delete the attack from the main state machine. So we have flying, death, and hit. So for hit and death, we can do it kind of like the other characters, where from any state we can transition into these, which means we're going to need to make transition from any state to hit and any state to death. So for any state to death, that's going to be when Boolean is alive is set to false, and let's make it true by default. Then we'll add to the conditions, is alive is false, and then make sure that on the transition you cannot transition into self, and turn off the transition duration. Now for going to hit, we use the trigger hit in order to do that. Transition duration 0. And can transition to self should be off. Yes, it should be off, definitely. And from hit, we want to go back to flying. So flying to hit at exit time 1, transition duration 0. No conditions for that. It's something that should happen automatically. And then to go between flying and attack, that's going to be dependent on whether our character has a target or not. So if I recall, we put the has target into the night script. So we're going to need something similar inside of our FlyingEye script. So yeah, that was part of the night specifically. Okay, so for our FlyingEye, let's create a empty game child. So this will be attack detection zone. And let's add a component detection zone. You can see how when we already write these components once, it kind of becomes pretty easy to just re-add them and reuse them. So the detection zone, I think we want enemy hitbox for that, since we're determining which targets we can attack. I can double check that later. But for this detection zone, let's hit W to go into move mode. Let's put it in front of the player. So we're offsetting the transform so that the local scale thing can flip again, like with every other character. Let's add a component, and we'll do, let's say, a circle collider. Or actually, I think a capsule collider would be more flexible. So let's do a capsule collider 2D, and I'll edit the collider. Let's give it a shape. So this shape is basically determining if the player is in this zone, we should switch to an attack state and try to bite the player. So then we're going to need another empty object down here, which is going to basically be the actual attack zone. So bite attack. And let's hit W, move this over here, kind of like so. I'll add a component. Let's just make it another capsule collider. So we probably want this to be smaller than the detection zone. So let's resize this a bit. And what would actually help us is if we were looking at the attack animation. So let's switch to FlyingEye attack in the animation window and get to that moment of the bite. Okay, that's good. So let's adjust where the bite can hit. Something around there makes sense. So let's look at the detection zone. And I guess we'll move this down and this down as well. So that seems like it should be pretty okay. And then let's look at the animations. I'm going to go to flying animation. So that's our bite attack hit zone. And this is our detection zone. I think those will work here. Okay, so for the bite attack, let's add in an attack. So this will look just like the sword or just like the knight's sword. It's just, it's in the zone. We deal damage to the player. Let's make this attack kind of deadly. I'll make it 20 damage. Why not? And we'll have no knockback for X or Y. It's a lighter enemy, so maybe it doesn't need to have a knockback. Oh, and let's also make it so that the bite attack can work when it is at that frame. So let's go to the animation attack. Let's find the frame right there. Add the property bite attack capsule collider enabled. So that's going to be enabled at this frame and then disabled everywhere else. So disabled. Here it's still disabled. After that frame, we want to disable it again. And then at the end, it's disabled. So disabled until the attack is made. And then, okay, here's our hit frame. And then disabled again and disabled. And yeah, that's basically the attack there. So now we need to use this attack detection zone to determine when we should switch to the attack state on our FlyingEye. So let's add a new component. Let's call it a FlyingEye script. Create an add. Just going to close all the tabs here for a moment. So we open up the FlyingEye. So the FlyingEye is going to need to reference the attack detection zone. So detection zone, bite detection zone. I think that should do good. Then let's go over to the knight, and I am literally just going to copy the has target bit for the property in the field over from here to FlyingEye. Okay, so it'll work exactly the same way. When it has a target in there, we'll be able to switch to the attack state in the animator. So we need to reference the animator. So let's get the animator as a private variable here, animator. We're also going to later need the rigid body because we're going to move the character, of course. So rigid body RB. And let's get those on awake. So void awake, and we do animator equals get component animator. Hopefully, since we've been through this a few times, it's just like second nature. Like you're building a character, you just know you're going to need the animator, you're going to need the rigid body, because you know what each of the components do and why you need them. So rigid body, same thing. We need to get the component rigid body 2D. Okay, so we have those referenced in our script when it's active, and we have the has target variable. So now we need to set has target. And we're going to do that on update. So on update, we'll check if the bite detection zone has something inside of it, then we have a target. So has target is going to be equal to the bite detection zone dot, let's see, we can just use the count on the detected colliders, which, I mean, I guess that's fine for now. So bite detection zone dot detected colliders dot count is greater than 0. Then we have a target. Cool. Let's set that as the has target. If there is nothing, if it's 0 or for some reason less than 0 on the count, then it'll be set to false. Okay, now we can jump over here to the animator on the FlyingEye. We will add the Boolean has target, and then let's use that to move to the attack substate machine. So make a transition from flying to attack, state machine, attack. Well, actually, I don't know. When we have multiple attacks, we might want to go straight to the attack state FlyingEye directly, or we can use the state machine attack. So if you use the state machine reference here, it's going to kind of let the entry point of the state machine pick which attack it is, or you can directly transition into an exact state here. That's kind of up to you, actually. I'm thinking it might make slightly more sense to go straight to the flying attack here, since that is the specific attack we want to use. Let's also make a transition back to flying, and this should have basically no requirements here. It's just this is how we get back to our default state. Now for the flying to attack, add a condition, and that's going to be has target is false, or has target is true, sorry. Let's jump into attack, and we can see that's our entry point. So now we need an exit. Make a transition to exit, and that's going to be has exit time at 1, transition duration 0. And conditions, don't really need one here. So with the knight, there was a point in time where I made it so that you would just loop the attack as long as the knight still has a target. But then we eventually changed it so that the knight has to return out of the attack state before it can make another attack. So maybe we want to do the same thing with the FlyingEye. Maybe it needs an attack cooldown of sorts. So for now, we'll just exit the attack animation when the exit time is 1, and that should happen every time. Okay, let's see roughly where we're at. I'm going to move the FlyingEye over here. Let's move the knight up onto this little hill. Just let him do his own thing for a little while. And then let's hit play and kind of test out the FlyingEye. So I'm able to push him. That's not what we're looking for. Let's jump into the knight and get hit. Okay, cool. So that's a obviously unfair knight. So for the FlyingEye, we want to take its colliders and make them all is trigger. So is trigger on the main one. On the detection zone, that's a trigger as well. So on the FlyingEye, that is not going to be a trigger because that's the actual collision shape for the character. Or at least I don't think I want it to be a trigger yet. Maybe later we'll make changes. We'll see. Attack detection zone. This is definitely a trigger. And then bite attack is a trigger as well. So we're dealing damage or detecting when something enters it, not using it as a physics object to push things around. So let's hit play, and I'll walk in here. Okay, so we can see we can walk straight through the FlyingEye enemy. That's actually what we want. And we have an error in the console. So let's double click here and see what's happening. Oh, we haven't set the bite detection zone for the FlyingEye. So on the prefab for FlyingEye, drag the attack detection zone into the bite detection zone slot. Okay, now let's hit play and see if we can have the enemy bite at us. Okay, yeah, it definitely is. So that's pretty good. It's not dealing damage to us, though. So that's probably because the bite attack is not on the enemy hitbox layer. Let's change that to enemy hitbox. So I can hit the FlyingEye, obviously, that's good. But for some reason, the bite attack isn't hitting us. So let me see here. Bite attack, by default, that should be off, right? And then we go to the animation. Let's look at FlyingEye attack. The bite attack collider is not on. We get to here, it's enabled. And then that's where we should get hit. So let's hit play one more time and test it. Okay, yeah, I guess we just had to make sure it was off by default. And now we're taking massive damage. So one more hit and yeah, our player's toast. Okay, so that's already like half of the eye working. The only thing we need to do is give it movement. So how I want to set this FlyingEye up to move is that when it's not attacking, it's going between waypoints. So we'll need to set up a series of waypoints for the FlyingEye to move between. So back in the hierarchy of the main scene, I don't want these waypoints to be attached under the FlyingEye because their positions should be independent of where the FlyingEye is located. If you make something a child game object, then it moves with the FlyingEye. But we want these transforms of the waypoints to be locations in the game world which are static and don't change. So let's create a new game object in the scene. I'm going to rename this to be waypoints. And then I am going to set its location to 0, 0, 0, just at the start of our scene. So I don't want this position to change the position of the children game objects. And then I'm going to right click on it and create a empty game object. And I'll call this iWaypoint. So this iWaypoint1, let's position it wherever we want the FlyingEye to fly to first. So let's actually say that's kind of like up here to the right. We'll move the knight back to the left platform. So let's take the knight enemy and I'll move him back over here. And now we're just kind of getting into like level design a little bit. But we have our first waypoint there. Now, it's kind of impossible to see the waypoint by default. So what you can actually do is give your waypoints an icon so you know where they're located, which is super helpful visually speaking. So click on your waypoint, which is just a transform, then click here to give it an icon. And I want to use like one of these little small ones to just give it a dot where it is on the screen. So pick whatever color you want and just select the waypoint color. So when we select it, we can zoom in really far and we can see it's quite small by default. So maybe we need to expand the size of the 3D icons. Yep, okay. So let's make it kind of like that. So I do want to see the waypoint icon, but I don't want to see the little player input on the player. So let's find where the player input icon is in this list and just turn it off. So down here, down here, down here, player input. Click on the icon for it, and then that will hide it. Okay, great. So now we can see the waypoints, but we can also see our player normally. Okay, so now for the other waypoints, and we might want to take the exact position on them and make them more of a even number, so like 10.5 or something like that. Or you can even just make them even numbers if you want them to match the grid precisely. Or you can just make them whole numbers if you want to match the grid precisely. So like 11 and then 2 or something like that. When we want to add another waypoint, just select it and duplicate it, Control D, W, and move it over here. Set the value to 16 manually. And let's duplicate it again. And I'll move one up here to right around there. Let's duplicate it again. And actually, you don't have to manually keep setting the value. You could actually snap to the grid if you want. So let's see, if we want to enable global snap, if we want to enable grid snapping, we can click here and change it to global. And now we can enable snapping over here. So let's do that. And yeah, okay, so our grid size normal. Let's see if that works. Yep, okay, so we're snapping to the grid precisely now. That's a lot easier. So we have waypoint 1, 2, 3, 4. You can rename them if you want. Waypoint, then just copy that. Go to the second one and paste in waypoint 2, waypoint 3, waypoint 4. There's also a setting in the project window where you can change how it auto increments. So if you want, you can go up to Edit Project Settings and Editor, and then scroll down here to the bottom, Game Object Naming. So it's by default, it's like prefab 1 in parentheses, but you can have it _1 or .1. Maybe I actually like underscore, so I'll just set that there. Kind of late, but good to know. So these will be the flight locations for our FlyingEye. Okay, so now let's take our FlyingEye a little over to its flight points. So I guess I could put him somewhere like there so that you can see that at the start, he's actually not going to be at the flight points. So we'll fly over to the first flight point in a list and then cycle through them and keep looping around. So to do that, we're going to need to edit the flying script. So first, let's give it a list of transforms. So list of transform, and this will be waypoints. Guess it can be, okay. And we're also going to need a public float flight speed. So arbitrary number, but I'll just default that to 3. So let's give it a arbitrary number. I'll make it 2F for now. And then as our FlyingEye is in the flight state, we're going to move towards these waypoints at the flight speed. So the direction is going to be determined by where the FlyingEye is and where the waypoint is. So then we take that direction and multiply it by the speed to get the final vector that it moves, kind of from frame to frame. So let's create a void fixed update. So we're going to need on fixed update, if the character is alive, and if it can move, then we're going to keep using a flight function in order to update its current velocity towards the waypoints. So let's generate that down there. We're going to need the properties is alive and can move. So I am actually just going to copy those once again over from night into here. So the is alive we can get from the damageable component. So let's make sure we have that as well. Damageable. And we'll get that on awake, get component damageable, and then we can check damageable.isAlive. Okay, that way we don't need to create another property inside of here, but we are going to use the can move. So just like on the night, we're just returning whatever value is set on the parameter. And then the state behaviors that are attached to the animator controller are going to set whether we can move or can't move. Just as a quick reminder to us to set that up later, let's add it to the parameters. So I'm going to add the Boolean can move here, and then that will be what we grab in the script. This will default to true, and then that will be what we reference inside of the script. So a couple more small things. If we can't move, then I want to take the velocity and set that to 0. So rb.velocity is just going to be equal to a vector 3.0. So if we're not flying, we're not moving. Okay, so in our flight function, we are going to be flying to the next waypoint. So what is the next waypoint? We'll need a couple fields up at the top in order to figure that out. So if we go up to the top, then let's start with a int waypoint number is 0. So this will be something that we increment as we reach each waypoint, and then we'll use that to pick the next actual waypoint out. And then to get the position of the waypoint, we need to store a reference to a transform. So let's do transform next waypoint. And we'll need to set this where the script starts. We'll default it to waypoint 1. So let's take next waypoint down here to on start. So we'll have to add that in. Void start. And we'll do next waypoint equals waypoints at waypoint number. So we just get whatever's at index position 0 out of our waypoints list, and that's going to be our first waypoint. So the first location we fly to. So now that we have the waypoint picked out, we need to figure out the direction to the next waypoint. So vector2 direction to waypoint equals, in parentheses, next waypoint dot position minus transform dot position, and then we normalize that. So when you normalize a vector, it's just a direction without any kind of speed or value component behind that direction. So when you only want to have the direction, you normalize the vector. And then you bring in the magnitude or the speed component. Next, we're going to want to check the distance to the waypoint to see if we've already reached it, and if so, change to the next waypoint. So float distance is going to be equal to vector2.distance. And so here, our parameters is basically going to be the same. Direction to waypoint and transform.position. So this is like the magnitude between the 2 points, where the top bit is just the direction. And whenever we're moving towards a waypoint, we want to set the velocity based on our movement speed. So the RB velocity is the direction to waypoint times the flight speed. We don't need to put in the time, delta time. The rigid body already factors that in when it's moving. Okay, then we need to check if we're ready to switch move points. So if the distance is less than the destination reached distance, oh, I guess we could call that something better, is less than the waypoint reached distance, then that means that we are within range. And let's actually make that less than or equal to. So let's create that variable up at the top. I'm going to right click, go to definition. So I'm going to make this a public float. So let's cut this up towards the top, public float, and I think the distance for this is going to be very small. So something like 0.1f is probably good. So if we fall inside of here, we want to switch to the next waypoint. So that's going to mean waypoint number needs to increment by 1. And then we'll see if the waypoint number is greater or equal to the waypoints.count. If that's the case, then we're going to take the waypoint number and set it to 0. Waypoint number equals 0. So this is so that we can loop back to the original waypoint. If there is a count of 4 in the waypoints and our waypoint number is 4, then that means that we're already looking for a 5th waypoint because this index location starts at 0. So it goes 0, 1, 2, 3. So if there's 4 items in the list, it means that the value 3 here is actually the 4th item. So if we're already at waypoint number 4 and the count is 4, then we need to loop back to the 0th spot because there is no 4 in the actual list. So then we need to update the waypoint transform. So that's going to mean next waypoint equals waypoints at waypoint number. And then that is basically our whole flight script. Okay, so let's take this and set up the waypoints inside of the inspector and go ahead and test our script. So we have our FlyingEye here. Each FlyingEye is going to need its own custom waypoints because each enemy is going to have its own path that it needs to follow for where it's going to fly in our game. So let's take the waypoints list here and add some waypoints to it. So I think what we can do is maybe select. So you can either click plus a bunch of times, or you can set the number of waypoints over here on the right to 4. So this takes 4 transforms. So we just need to take each eye waypoint and drag them over into this list. Now don't apply it to the prefab because the prefab has no idea what's going on inside of this scene. If you open up the prefab only knows of the game objects that are beneath it. But remember, our waypoints are part of our level scene, not part of our enemy. So you have to set this up for each character in your game individually, of course. So let's go ahead and hit play and see if the flying thing actually flies between the waypoints. So it got to the first waypoint, but then it's not moving on to the next location. Let's see if the bite still works. Okay, so it still bites. So this is a problem with the waypoints themselves. So it came down here to waypoint 1. Okay, so here's the little problem. We don't want the normalized direction for the direction to the waypoint to figure out the distance. We want the next waypoint dot position here. We're getting the distance between 2 positions. So that should be all we need for that little fix. Let's go back out to the game mode, hit play, and let's watch the FlyingEye. Okay, he got to the first waypoint, now going to the second one, the third one up here, and the 4th one down here. And then he's going to take a bite at me if I jump in front of him. Or he should. That's pretty weird. Let's go to scene view and click on the guy and see why he's not biting me. Okay, he did bite me. I guess I just was not in the zone for that. So let's take a look at the bite attack. Or the attack detection zone is what we're looking for. Okay, so attack detection zone. Yep, okay, we do get the bite. So the bite is working. Maybe we need the detection zone to be a little bit bigger though. So I'm going to go in there, edit it, and let's just increase the size of the detection zone by a bit. Just because it tries to attack us doesn't mean it's going to hit us. So I don't think that's a problem. And then what we might want to consider is that when it is in the bite attack, or just in the attack state in general, that it's not going to move. So let's go into attack as the state machine, add a behavior to it, and let's set the bool can move to false on enter and true on exit. This is going to be update on state machine because this is a sub-state machine here. So let's hit play and let's jump into the enemy and let's see if we can get him to stop when he makes his attack. Okay, so it's not doing that. Let's see. So the value in the inspector can move is still set to true. Maybe it is supposed to be update on state for that instead. Okay, so when we make it update on state enter, it does work. I think that the reason why this happens is that we're going directly into flying attack from FlyingEye flying. So if we change this to be going into the attack state rather than the attack, then it should work if we have update on state machine true. But because we're making a direct transition into the attack, we actually skip over this, enter the state machine. So if I change this to flying into attack state machine, let's delete this transition for a second here. I'm going to make the transition into attack state machine. We'll set the conditions to the same. Has target true, no has exit time, transition duration 0. And then we have the set bool behavior over here. And we jump over here and let's see when we get there, we enter the state machine. Okay, and then it does stop. So that's actually very interesting to me how when you enter a state machine, but you go directly into the state, it actually skips over the state machine enter behavior. So I guess that's something to watch out for there. If you want, you could definitely just set the bool behavior on the internal state instead. So you could put it over here, flying attack, set bool behavior, update on state, and do the same thing there. But yeah, definitely watch out for that one. The state machine can be skipped if you don't go into the state machine, but rather the internal states directly. Okay, so putting aside those technical curiosities, it does look like our enemy is doing what we want it to now. It can definitely bite the player for 20 points of damage. So as things are right now, the enemy always faces to the right. So having the enemy always face the right might be okay. We could also just flip the direction based on its flight movement speed. So that might be fine too. And it does look a little bit like the FlyingEye attacks us a little too soon. Like if we just kind of bait him like this, that's a little silly. So let's jump into the FlyingEye and I'll shrink the detection zone a little bit. Or actually what we can do is just move its position over here to the left. But snapping's still on. I'm going to Control Z that and turn off snapping so that I can get a fine grain adjustment to this. And let's take a look at the bite attack. All right. Attack detection zone over there. That's fine. So if we want to flip the FlyingEye based on its flight direction, then let's go into the FlyingEye script. And I'll create a little function here, update direction. Let's generate that method. So if the transform.localScale.x is greater than 0, then we're facing the right. Else we're facing the left. Let's make sure we get some brackets up there. So if we're facing the right, we only want to flip to face the left if our flight movement is actually to the left. So if rb.velocity.x is less than 0, we're going to flip, which means we take the transform local scale and make that equal to a new vector 3. It's going to be -1 times the current value of the local scale. So let's actually get that local scale up here at the top. So let's see, vector 3 current local scale. Oh, no. So let's get vector 3 local scale equals transform.local scale. So that's easier to type. So we want to flip the x scale. So that's going to be -1 times local scale.x. And then the other values are just local scale.y, local scale.z. And we can copy this same bit down here. The only difference is going to be that we use if the rb velocity.x is greater than 0, then we're going to flip. And we only want to update this when we are running the flight function. So if the movement for some reason gets overwritten by something else, we're not going to update the direction by default, only when we're running the flight function. Okay, I think that should do all right for right now. Let's hit play and watch our enemy. So he's flying to the right, and let's see, flying upwards, and then, okay, there, nice. We have our flip direction. And because we're flipping the local scale, our bite also flips the direction, which is kind of cool and exactly what we want. So the enemy bites and flies in the direction which it's actually facing and flying. So that's really handy and cool. A little bit off on the hit collider for that bite. So we're just going to need a few more adjustments again, moving the attack detection zone up a little bit. But of course, this is just tweaking things. Let's take a look at that bite collider in the animation attack. Yeah, okay, that is too low. So let's move it upwards a bit. Maybe even all the way to here. And then just remember to disable it when you're done, because that needs to start off by default. Okay, and we can give it one final test, but that is pretty much it for our flying enemy. If you want to add another flying enemy, you just create a different set of waypoints, add them to the flying enemy just like we did before, and our enemy will be able to go around biting our player. And of course, it can still get hit and take damage. Let's take its death animation there. So the main functions of our enemy are basically working fine. It's flying, flipping direction when it needs to. The only problem is we still need to set up the death state a little bit. But as you can see, it is able to loop, so we need to turn that off. But also, we don't want the enemy to just kind of float there in midair. We want it to fall all the way to the ground. So let's hit play again, and let's see if we can shoot an arrow at it. Okay, got hit there. We don't have any aerial attacks yet. That's actually the next part. We'll be adding that in to make it easy to deal with these enemies. But yeah, let's hit them a couple times. This is a great spot to do it, because you can see there's no physics to make them fall to the ground here. So we need to set that up. First off, let's turn off the loop for the flying death. So let's go to the project, characters, enemies, FlyingEye, death. Turn off the loop there. That's half our problem. So next we need to make the character drop to the ground when it is dead. So in the script, let's go to where we have it is alive and can move. So if it's not alive, it's dead. And if that's the case, we want to make it fall to the ground. So to do that, we can take the gravity scale and set that to a value. So in my testing, I like to put that as 2 to make it fall super fast to the ground. So let's go into the game view, hit play. And you know what? Let's actually just take the FlyingEye, and I'm going to set its health to 0 by default. So damageable health is going to be 0. So let's hit play here and deal damage to our enemy. So let's take the FlyingEye health, set it to 10, hit play. Let's jump up here, and we'll hit the FlyingEye. But we can actually see the pickups are healing the enemy. That's not great. So let's click on our health pickups, and we can see I actually forgot to set the layer. So those should be on the pickup layer. So health pickup is going to be pickup. Now let's hit play, and we shouldn't see the enemy pick up any health pickups anymore. So we just need to take a swing at the enemy, and you'll see it dies, it falls to the ground. Now it's stopping here because of the collision shape. Not really a problem, but let's see. If we go into scene mode and click on the enemy, let's see if we can show that collision shape. So you can see that the capsule collider, it is touching the ground. That may or may not be a visual problem for us. So for right now, let's actually just take the FlyingEye and let's add the fade remove behavior, 0.5 seconds. And let's go up there and hit him. Maybe since it's fading away, it doesn't really need to. Okay, so let's hit play one more time and take a swing at the enemy. So we can see that it just kind of falls and fades immediately. Maybe what we want to do with the fade behavior is attach a little bit of a delay to it. So in our fade remove behavior, I'm going to add in a extra delay. So if we hit play and we go take a swing at the flying enemy, you'll see that it fades as soon as we attack it. So what we can add to the fade remove behavior is a delay, an optional delay, so that it doesn't start fading immediately, or you can increase the fade time. So I'll try adding a delay. So in the fade remove behavior, let's add in 2 variables and say private float fade delay elapsed, and I'll set that to 0f. And then we'll have public float fade delay is equal to 0.0f by default. So in our update, we're going to have a if. So if fade delay is greater than fade delay elapsed, then we're going to increment that. So fade delay elapsed plus equals time.delta time. Else either we don't have a delay or it's already elapsed, so then we resume our normal fading functions. So this just means that whatever we set this to is going to be how long it starts for the normal fade to occur. So if we come back out here, let's set a fade delay to 0.25. I'm going to hit play. Let's go ahead and take a swing at him and see what happens. Okay, so you can see it was a little bit delayed there. Let's try with 0.05. So let's hit play. I'll come up here and take a swing. Okay, so yeah, it's definitely delaying it now. One other thing is that when the enemy dies, it doesn't fall straight to the ground. It falls kind of to the right. So I want to take the RB velocity.x and set that to 0. So let's go to the FlyingEye. When we get here, I'm also going to take the rb.velocity and I'm going to set that to new vector 2 rb.velocity.x, and that's going to be 0 and rb.velocity.y. Okay, so let's test it one more time. I'll hit play. Let's jump over there, hit the enemy. Okay, now he falls straight to the ground and then fades away. So this is pretty much working as intended. So the only thing we might want to adjust is that making it so that when the FlyingEye hits the ground, it's actually above the ground and not kind of falling into it. So to do that, we need to set up another collider that only exists when the FlyingEye has already died. So let's take a look at the death animation, and we'll look at this frame right here. So 0, 2, and we need there to be kind of like a collider that will go right across here and stop it from falling further at that point in time. So I'm going to jump into the prefab. Let's keep that death state up there so that we know what to work with. And I'll add a child game object. So I'll call this death collider, I suppose. And then in the inspector, let's add a box collider 2D. Yep, okay, that should be fine. You could probably get away with the edge collider too, but this is fine. So let's take this. I'll move it down here. For the position, I'll leave that set to 0, 0, and let's edit the collider and move that down here so that this box will sit on top of the ground. So I'm just going to kind of stretch that to the size of our character. And this is not a trigger collider. So let's actually take a look. In the animations, we want flying. All right. So we go into the death state. And I'm just kind of seeing if this collider makes sense as it is. Maybe it should be a little bit bigger to the right. Okay. So let's edit this and I'll just pull this out here. Let's be very generous with this shape of this collider for the death state. Okay, something like that's good. Like, as long as it covers the main body, I think that should be okay. Okay, so this collider is going to be disabled by default. So turn that off. And then in FlyingEye, let's go into the FlyingEye script. I'm going to edit the script. Let's add in a public collider 2D, and I'll call this the death collider again. And then when we get down here, we'll do death collider.enabled equals true. Now for all of this, this is being set on every fixed update frame. So a better place to put it would be to respond to an event from the Damageable component that we haven't created yet and move it down below. So I'm going to cut this code, get rid of the else, and let's move it down here to the bottom. And this is going to be, let's see, a void on death. And then we'll paste that in down here. So on the Damageable script, I'm going to create an event. So public unity event. And I guess we don't really need to pass a parameter because this is going to be a localized event. So we already kind of know which character was dying. So let's say damageable, we can just go with death. So damageable death event. So on FlyingEye, we want to call the on death when the damageable death event happens on the damageable component. So if we go back to the start, we can add in a void on enable, and that's going to be damageable death plus equals on death. So we'll set up the on death function to call in the inspector. So now we just need the damageable death to be called inside of our script. So when we set is alive to false, I suppose that's when we can call the event. So if the value is false, then we can call damageable death.invoke. Okay, And now what this means is over in FlyingEye Damageable, we have this death event. So we can add a new function to be called to it. So Damageable death, add, and we're doing this on the inspector. So we take FlyingEye, and then from the FlyingEye script, we do on death. It's probably still a private function. So let's go into flying and take that and make it public so that we can call it in the inspector. Okay, so now once again, drop down, and then we look for on death. So now we only need to call all of this once, which makes sense. We shouldn't need to update the velocity every single frame, or the gravity scale every frame, or the collider to be enabled every frame. So the last thing we need is to set that death collider. So death collider to right here. I might want to make sure this shows above the waypoints. So if you want to reorganize it in the script, you could just cut and paste it above the list of waypoints. Okay, and let's see if that resets the link between the collider and the collider. Okay, and since we didn't rename the variable, the box collider is still attached here, so that's good. Let's go back out. So I'm going to test everything. Let's hit play, and let's hit the enemy. Okay, where is that collider stopping? So let me take a look at the animation again. We have the death animation. We come down to here, the death collider, and we have the edit the transform. Maybe it's too big. Yeah, maybe what we actually need is for it to be above here. Yeah, that would make more sense. Okay, so now let's go in and hit the enemy. Okay, now the collider's working nicely. So it's just a position adjustment for the collider. We can test it one more time. Arrow. Okay, hits the ground nicely. So that actually makes the FlyingEye death a lot better now. And so that will pretty much wrap up what we need to set up for the FlyingEye character. Being able to fly around between waypoints, bite at the player, and fall to the ground on death, and actually have a collider where it lands right on top of the ground properly. So we're at the point in our game where it would be really handy if our player character was able to hit the FlyingEye while jumping, because the FlyingEye, obviously, is sometimes above the ground and would be hard to hit with a ground sword swing or a arrow that just goes left or right. So to combat aerial guys like this, we're going to add in 2 aerial attacks, an attack 1 and an attack 2 for the air, which means we're going to need to set up some new colliders for those aerial attacks, and we'll set up the statistics to have new damage values for those attacks. So in the prefab for our player, let's go to animation, and then I'm going to create a new clip here, which will be player air attack 1, and then let's put that in characters, player right in here, save it. I'll change the samples to 10. And now let's go up to the art folder, RV Ross Adventurer Individual Sprites, and let's find our air attack. So we have air attack 1, which has 4 frames here. Let's grab those 4 frames, and I'll drop those into the animation window. So if we zoom in, we can hit play and kind of test our air attack. So let's go ahead and create air attack 2 now. So create clip player air attack 2, and we'll go ahead and hit save, change the samples to 10. Let's grab the 3 frames for air attack 2. So we can hit play, and we can see our air attack 2 playing out right there. So to continue setting up our attacks in the same manner we were before, we'll just create a couple more child game objects to hold all those attacks. So with sword attack 3, for each of them, make sure that the colliders are turned off. So I'm going to take that collider on sword attack 3 and turn it off. So let's go ahead and right click on player. So I'll actually duplicate sword attack 3 twice here, and then let's rename it air attack 1, and then air attack 2. So for air attack 1, let's go to the animation window, go to air attack, find the animation frame at 0, 1 for where our hit collider should appear. And then let's go to the inspector and enable our polygon collider so that we can see it. Hit edit and adjust the points for our sword swing shape. So whatever you feel comfortable with is good. I'm going to try to go roughly around the outline of the sword swing without making too many points. Make sure that they don't cross over each other so that you don't get the red line to show up. So everything should be green here. And maybe I'll bring this out a little further. And that should be good for our air attack 1. So I'm going to turn off edit collider. I'm going to disable the collider by default. Let's go to the animation window. I'll add a property. Let's find air attack 1, polygon collider. Enabled. We're going to make sure it's off on frame 0 and then enabled on frame 1. After that, disabled again. and all the frames except for where it says 0, 1 should be disabled. So there is our first air attack. Now let's jump to air attack 2 and do the same thing. So I'm going to find the hit frame, which is in this case on frame 0. Let's go to the inspector, click on air attack 2. I'll hit edit collider, and then let's bring this over to where it makes sense for our sword attack to hit this time. So this should be more of a upwards shape. And let's just grab those lower points to be right about here. Maybe we do want to be able to hit on the lower end as well. So that will roughly be our shape. We can come up here as well. Okay, that looks pretty good to me. So let's go to the animation window, add property, scroll down to air attack 2, polygon collider enabled. You can see it's disabled on frame 0 by default, so we want to check that to enable it. Then go to frame 0, 1, disable that, and make sure it's disabled for the rest of the shape. Now we can change this to some default animation and just go through all of the polygon colliders on the attacks and make sure they're all disabled by default. Okay, next we just need to set damage for our air attack. So we can see that on the ground, sword attack 1 does 10 damage, sword attack 2 does 15 damage, and sword attack 3 does 25 damage. So you can kind of use whatever values you want for your air attack. If you want it to deal more or less damage, that's fine. That's up to you. I'm going to put 12 for the first attack damage, and I'm going to set 0 for the knockback, at least for now. We can always add a knockback back in later. But the flying enemy ignores knockback the way it's been scripted anyway. If you wanted to add knockback to the flyer, you would just do something very similar to how we set up knockback on the knight, where during the knockback, new rules take control for how the velocity should be set, and then you would disable the normal flying for that period of time. But for right now, we're just going to see if we can get the flyer to take damage from these aerial hits. So I'm going to set the knockback to 0 and the damage to 18 on the second attack. So it's 12, 0 and 18, 0. One last thing to double check is that your air attack transforms are over to the right and roughly centered on the polygon collider shape. So when we reverse our direction, it's going to take everything here and bring it over here when our scale on the parent object goes to -1. So we do need to still have that offset over to the right. So now that we have the attacks, we need to set up the animator on the player so that we can transition into them. So if we open up the player's animator, we have the ground attacks, player bow, but we need to set up a air attack substate machine, which will be similar to the ground attack substate machine, but we can only get there when we're in the air. So let's right click, create a substate machine, and I'll put it up here above air states. Let's rename it to air attack. I'm going to grab these two animations, Control C, jump into air attack, Control V to paste them in. Let's make the default entry point the player attack 1. Go back out, and I'll delete these two animations from the main base layer. So now we need to be able to get to air attack. We can still use the attack trigger, so we don't need to re-script anything about pressing a different key to go to the attack. It's just going to go to an air attack if we happen to be in the air. So from air states, we're going to want another exit transition here if we use the attack trigger. So let's right click from player rising to exit, player falling to exit, click on the transitions. So has exit time is going to be off, transition duration 0, and the condition is going to be the attack trigger. And that's the same thing for both of them. Has exit time off, transition duration 0, and then we hit plus and go to attack. Okay, now that we have a way to leave our air states, we go back up to the base layer. Let's make the transition from air states to air attack. Right click on air states to make transition to air attack. I guess for now we'll just use the air attack machine directly, which means that we'll go into the default state in the air attack. And here for the condition, we add a plus and make it the attack trigger. For air attack back to air states, make transition back to air states, state machine air states. And this will not have any conditions, so it will happen automatically when we leave the air attack substate machine. Okay, let's jump into air attack now. And we can move this base layer piece over here. So when we come up from the base layer, we go to the entry, which puts us in air attack 1. Just going to kind of reorganize things and make it a little bit clearer to understand here. So essentially, our air attack states are going to look just like the ground attack states. So we need a connection from each of our attacks to the exit on exit time 1. So if the animation completes without the attack trigger being set again, we leave the air attack state. We leave the air attack state machine. So right click, make transition to exit. Air attack 2, right click, make transition to exit. Click on those. exit time 1, transition duration 0. Click on the other one, exit time 1, transition duration 0. Now air attack 1 to air attack 2, make a transition over here. The requirement, if we add the condition, is of course the attack trigger. The exit time is going to be 0.75 and the transition duration is 0.25. So just like with the normal attack chaining, we will exit from the air attack 1 starting after 75% through the animation if we have the attack trigger set. So it's going to look for the attack trigger. If it's set, we move on to attack 2. Otherwise, if it reaches the end of the first animation with no attack button being pressed, we just leave the air attack state and we resume falling or rising in the air states substate machine. So hopefully that all makes sense. Basically, we're just doing a repeat of ground states to ground attack, except now we're in the air. So whether we do a ground attack or an air attack depends on if we were coming from the ground or the air. So let's go into our game and give this a shot. I'm going to jump, press left click to attack. Let's try doing a combo. 1, 2, 1, 2, 1, 2. Okay, you know what I think is going on here? It's that our transition duration is set to 0.25 seconds, not percentage. So turn off fixed duration for this. It should be percentage. Okay, so now you see 75% through our air attack 1. We transition into air attack 2. Okay, let's hit play and test it. So 1, 2, 1, 2, 1, 2. So 1, 2. Okay. Looks more correct. Let's try hitting 0 here for the transition duration. 1, 2, 2, 1, 1, 2, 1, 2. I think we do want the transition duration 0.25%. Let me just test that one more time and make sure this is working correctly. Yeah, okay. I think that's correct. Okay, so let's test if we can hit the flying enemy with it. Oh, yep. I was so confused because he died so quickly. I forgot to set his HP back to 50. Let's go to FlyingEye, and yeah, he should have 50 health. Poor guy. Okay, let's hit play, and let's go after him again. So we have our 12 hit and our 18 hit. So that seems to be working just fine. So let's hit play and give it one more test. We definitely can hit with the attacks, but I do notice our jumping is a little bit clunky at the moment. Maybe we don't have enough aerial movement control for our player. So easy fix. Let's go into player, the prefab, and I'm going to take the air walk speed and let's put it to 5 for testing. So let's hit play and give it one more shot. Our character is now way more flexible in the air. That might actually be too good at flying. So let's go into play mode and test with the increased movement speed. We can see our character is now really flexible in the air, maybe too flexible, honestly. But we can use this at least to test a few hits on the enemy. So what I do notice is that if the enemy is in the attack state and then we hit him, just like I did there, then we immediately switch to flying hit without exiting the attack properly. And we can see that lock velocity is set to true and can move is set to false. So the can move on exit never actually occurred. So to make sure that the lock velocity and can move actually gets set, I'm going to need to add the set bool behavior to the flying hit. So let's take the flying hit, add set bool behavior. We'll do can move. Let's say update on state, value on enter is false, value on exit true. And then set bool behavior, lock movement, value on enter is true, value on exit is false, update on state. Now I think you could definitely make the case that because using this any state transition kind of circumvents the normal exiting of a state machine, that using this might be kind of screwy. And maybe it would be better to have direct connections from each of the states where you can be hidden directly to this so that you exit the state machine properly. I think it's kind of arguable which way is better, but since we already set things up this way, I'm just going to make sure here that those values get updated properly. And so the second Boolean is actually lock velocity. You got to be careful about the naming. So let's hit play and give it a test. I'll jump into the enemy and attack him while he is attacking. But now we can see that our Booleans get updated properly so that we don't accidentally lock the enemy from being able to move after leaving the hit state. So that's pretty much going to be it for setting up the attacks and movement for our player as well as our knight and FlyingEye enemy. Hopefully at this point you have a really good idea of how to set up enemies that can be hit, animator controllers, transitioning between animations, and all that good stuff. So we're getting pretty close to the point where we might try to test a build and run of the game. But when you're in a full screen build of the game, you would have no easy way to exit the game properly. So let's set up the game so that we can press the escape button at any time so that we can exit the game even if we're in a full screen view. So kind of similar to how we have the player input component on our player, let's add a component where we can take these same actions, but the UI side of it rather than the player input side of things, and then use the UI mapping in order to respond to the escape button being pressed and use that to exit the game. So to keep things with how we have it right now, I'll add a player input component to the UI manager. So with this, we'll take the player input actions, the same one that we are using on the player itself. Let's click here and add this to the prefab as well. And let's actually edit on the prefab for the UI manager. This time though, we're going to take the default map and change this to UI. We'll change the behavior to invoke Unity events. And now let's double click on the actions, the player input actions, and look at the UI action maps. So I'll add a new action to the UI actions. Let's hit escape. And I suppose I'll just call this escape. So the path here is going to be keyboard. And then let's do location of key and look for the escape key. And we would want to use this with at least the keyboard and mouse control scheme. So let's take the player input, save asset, hit the X. Okay, so now we want to expand events and we'll look for UI. And then we're going to need to create a new function to call when the escape action is pressed. So let's do that in our UI manager. I'm going to edit the script. And then let's go down here to the bottom and I'll create a new function. So this will be public void on exit. And we're going to take a import action, callback context. And we want to check if context.started. So when the context is started, we want to exit the game. So I'll actually call it on exit game. I think that's more appropriate. So this next bit, I'm going to copy paste and then we can talk about it a little bit. So the first thing you probably notice is that we have these hashtag if and hashtag end if statements. So this if hashtag means that the code in between the if and the end if will only run if we're in the context specified here. So you can see that we have different contexts. Unity editor, which would mean that we are running the game inside of the Unity editor, or if we have a development build of the game, which when you build your game, you can do a check mark for development build, which means that you can have all sorts of debugs, which means that you can have all sorts of debug messages print to the combo while you're testing the build of the game. And then when you're in the official build of the game, it just wouldn't apply if you specify with a hashtag if like this. So inside of here, we have debug log. So we're saying the name of the object, the type of the object, which I think would come out to UI manager, the class. And then after that, we're saying which function that we're running, which in this case is on exit game. So it'll say something like UI manager of type UI manager is running the method on exit game. So we get the method name with system reflection method base get current method dot name. And this will only run if we're in the editor or the development build. So it's a good way to check that this onExit function was at least trying to run. So then we have some more if logic down here. So if we're in the Unity editor, the way you get the game to stop is you tell the editor application is playing and you set that to false. Now that's different than other builds of the game. So if you have a standard fully built Unity game, Unity standalone, so that would be if you're playing the game on Windows, on the desktop, or Linux, or Mac, or whatever. And then I have a third one down here, Unity WebGL. So you can use Unity WebGL if you wanted to be able to play your game inside of the web browser. Now, getting the game to exit from the web browser is a little bit screwy. Application.quit might get the game to technically stop, but it doesn't make the screen go black or anything. So my way around that to stop the music and everything else is to change to a different scene. So in that scene, there's just nothing but black space, no music or anything. So if you want this load scene to work, then let's go to scenes, create a new scene. I'll call it quit scene. So make sure the string name is the same. Double click into the scene. I'll take the main camera and let's change the background type to solid color, the color to black. And we need to add this scene to the build of our game. So file, let's see, build settings, add open scenes. So this is really important. We have the scenes for our game. If a scene isn't in the build of the game, then it can't be opened. So any levels you want to be able to actually be playable, make sure those are in the list here. So to add it, you just open the scene in your inspector, come in here to file build settings, and add the open scenes. Make sure it's in the list somewhere. You may also notice that for the scenes in your build, they do give an integer value. So you could reference a scene by its integer value. Generally, I prefer to use the string name for it though. And then down here, you can see the different platforms you can build for, Windows, Mac, Linux, the default easy option, and then WebGL here as well. So if you see an option that's grayed out, then you might need to run the Unity installer again and make sure that you add the different build targets to your installation of Unity. So if you want to build for Android and you're installing Unity, you need to make sure you check the little box for Android build settings or build package, and same for iOS and everything else. Okay, let's go back to our gameplay scene, and I'm going to grab the UI manager. So we have the events created. Let's go to UI. I'm going to go down to escape, add the new function to call here. UI manager, drag and drop that, then click on the drop down, UI manager, on exit game. Now we can see that I'm editing this in the gameplay scene, so I need to apply this to the prefab. So go up to the top for player import, click on the 3 dots, modified component, apply to prefab manager. Okay, just to make sure that anytime you use the prefab manager, this is already set up. So now let's hit play, and then I'm going to hit the exit key, and it's going to exit the game. We can also see in the console that we had the UI manager being called here for exit the game. So we know that the exit function was working. Let's actually do a quick build of the game and make sure that it's working there as well. So I'll do File, Build Settings. Let's make sure we're in Windows, Mac, Linux. If you want, you can check Development Build so that you can still access the console debug messages and that kind of stuff. Use this for testing, not when you actually distribute your games. So let's do a build and run. I'll create a new folder inside of the project here. Let's see, new folder. I'll call it build. Now notice this is outside of the assets folder. Definitely don't build your project in the assets. That would be bad. So any folder outside of that is probably okay. So let's go out to build, select folder. We don't need it to be accessing Unity services for right now, so we can just hit yes to continue and just let the game build and then run. Okay, so here we have the build for our game in full screen. We can see development build in the bottom right, so we can test everything. Note that the font size doesn't exactly scale up, but it's okay for right now. And everything else seems to be working just fine. So let's hit escape and test. Okay, so our game exits when we hit escape. That's what we were looking for. So we're pretty much getting to the end as for the basics of building our platformer game, but it's a little boring to play without any sound or music, so that's what we're going to be focusing on in this video. So if we want to add music to the game, it's as simple as right-clicking in our gameplay scene, creating an empty object. I'll call this music, I suppose. Add a component, and we're going to be looking for a audio source, not sound, audio source. And for music, we would want play on awake to be checked here. Generally, you would also loop the music if it's in a scene like this, just playing one loop over and over again. And so we need to select an audio clip. So to find our audio, let's go to Assets Audio, which we downloaded at the start. And we'll go to Music, 10-bit Battle. Let's see, Assets for Unity. So you can see in here we have 2 assets here, the intro and the loop. So let's try just testing with the intro. I'll drop that into here. Okay, so now we can go ahead and hit play, and we'll see that the intro part of our music is going to play. Now, generally, music wouldn't be separated into 2 parts like this, but we can make a workaround pretty easily, so that after the intro is played, we switch to the loop part of the music and continue playing that over and over again until we exit the scene. So to do that on our music game object, I'm going to add a new component. I will call this music player, which will be a new script. We'll create an add. So let's make sure all of our scripts are in the scripts folder. I'll go to assets, and let's take FlyingEye and music player, and I'll move it into scripts. So now back on the music object, let's click edit script for the music player. So our music player is going to play the intro music followed by the loop music when the intro is done. The simplest way to set this up is going to be to have 2 audio sources, one set up with the intro, which is going to be played when the script starts, and then the second audio source will have the loop, which will already be set to loop, and we'll play that when the intro is done. So I'm going to have 2 audio sources, public audio source, and we'll say intro source and loop source, suppose. So then we need 2 lines in the start method, which is going to be intro source dot play. So when the music player starts, our intro source is going to start playing. And then for the loop source, we want to queue up the playing. So we want to use play scheduled, and this is going to require how long we're going to wait in order to start playing the loop source. So we want to start with audio settings.dsp time, So that's the current time in terms of the audio system components. And then we want to add the length of the intro source's clip. So that's going to be intro source dot clip dot length. And the length is measured in time since we're talking about audio. So we tell the loop source to start playing, taking the current time and adding the end of the clip length to it. So these should sync up. When this is done playing, this one's going to start playing. So back in our Unity editor, you can see we need two audio sources. I'll drag this intro source into the intro here. And then let's add component audio source. So the second audio source is not going to play on awake, but it is going to loop. Let's go into audio, music, 10, battle 1, assets for Unity. So we need the loop. Let's go to the object here and drag the loop into the bottom audio source. So loop, bottom audio source. Okay, it's there. Now, the one on top is set to play on awake. So I am going to turn that off for right now and make it so that the music player script is going to be responsible for playing this audio source. The last thing we need to do is drag the loop source into the loop source slot. Okay, so now we should have this set up. Let's go ahead and test it. So just need to let the music play for like 10 seconds and see if it keeps looping with the loop audio source. So let's hit play. Music starts with the intro. So let's give it a second. And let's give it a second. So I believe that this is already past the point where the intro source would have stopped. Yep, it just keeps going on and on. So our audio is now working for the scene in the game. So that's great that we have the music, but now we want to add sound effects that occur when our animations happen. So when a knight takes damage, or our player swings the sword, or one of the characters die, we want to play certain sound effects. So what would be a good way to do that? Well, the way I like to is to go into the animators of our characters, and then we will create a new state behavior. So the thing about state behaviors that makes it so great is that we can have something like a sound effect play when we reach an animation state. So when the player gets hit, or the player dies, or it makes an air attack or ground attack, we can have a sound play at those exact same times. Okay, so let's start by going into ground attack, and I'll click on attack 1 here, and let's add a new behavior. So let's do a new play one-shot behavior script. So first I'll take the script into assets, and let's move it into scripts. And then inside of scripts, I'll make sure I move it into the state machine folder as well. Okay, so back on the animator, player attack 1, let's go ahead and edit the script. So I'm going to uncomment onState enter, onState update for doing a delayed play, and then onState exit. These other functions we don't need, so I'll get rid of them. So we're going to need a public audio clip sound to play. We want a public float volume, which will default to a full volume of 1. To play the one-shot sound effect with. And then I'm going to port 3 booleans. Public bool play on enter equals true, let's say. And then play on exit equals false. Play after delay equals false as well. So those would be the 3 times we can play the sound effect. And then for when we do a play after delay, we'll do public float play delay, and I'll default that to 1/4 of a second. We'll have private float time since entered equals 0. And then once we play a delayed sound effect, I want to have a private boolean delayed sound played, or has delayed sound played, which is false by default. So first off, if we're going to play the sound on enter, so if play on enter, then as soon as we come into this state, which has the script attached to it, we want to do audio source dot play clip at point. And we're going to need some parameters for that. So that's going to be sound to play. For the position to play the sound at, we'll use the location of the character. So if the character's swinging a sword, it makes sense to play the sound coming from that character's position. So we'll do animator.gameObject.transform.position. So the position of the animator's game object. And then float volume, we'll pass in our parameter from up there at the top. And then that's all we need for that. So I'll just copy paste that to the exit, and we'll do play on exit. So that's how you would do play a sound effect on enter and on exit. So then the slightly more tricky bit is when you want to have a delay. So when we enter the state, we definitely want to make sure time since entered is 0, since this is the exact time that we entered the state. And we'll just double check and make sure that has sound played is false. It should already be false, but we'll just make sure. And then down here, if we are trying to play after a delay, so if play after delay is true and has delayed sound played is false, so let's add the little exclamation mark there, reversing that. So has delayed sound played, but not true. Then we can increment the timer. So we'll do time since entered plus equals time.delta time. And then we can do if time since entered is greater than the play delay, then we'll play the sound. So let's just copy this line up here, playing the sound, and then we'll say that has delayed sound played is now true. Okay, and that should be it for our sound player. So now we just use this same script anywhere that we have an animation that needs to play a sound. So we have our attack 1 here. We need a sound to play, the volume, and we'll do play on enter, not play after a delay. So let's go to the sound effects that we brought into the project. So sound effects, let's see, attack. So into sound effects, I think we want battle and slash. We can give that a shot. So I'll just drag the sound clip into the audio clip slot, and that should be all we need. I can double click here. So let's go ahead and hit play and see if we can get that sound effect to play. I can barely hear it, but I think it is there. So what we might realize is that our music is way too loud. So on the music object, I can take the audio source and let's lower the volume. I think in the demo project, I added something like 0.05. So let's go to audio source down here as well and make it 0.05. So now let's go ahead and hit play and start swinging the sword. Okay, yeah, can hear it now. So now we just need to do the same thing for the other attacks to make sure that they also have a sound. So let's go to animator. I'll add a player one-shot behavior to attack 2. We can click here to search the project for the sound effects. So I think it was swing or sword or slash. It was slash, actually. Okay, so just add it there and then that's done. And let's go to player attack 3. Add a play one-shot. Okay, let's search for slash and that's that. Let's hit play. 1, 2, 3. We have 3 sound effects that are playing. And of course, you can feel free to switch that to a different slash effect if you want the sound to be different for each attack. So let's add in a bunch more sounds to different states in our game. In air attack, I'm going to go to attack 1 and we'll have it play the slash sound too. So play one-shot behavior, slash, go to attack 2, play one-shot behavior, and we're going to do slash again for all of the characters' slashes. Then we should probably have one for player bow. So this is where we'll have the delay, I think. So add behavior, play one-shot behavior, and we'll do play after delay. Let's see if we have a bow sounds. So I'll click on the sounds to play, and let's just kind of go through the list. I don't remember exactly which one I was using, but there should be like a fire or something. Maybe I was actually using wind, I think. So the 25 wind sound effect. Let's hit play and test that. So we'll come over here, fire the arrow, and you can see that the sound effect plays after the animation actually starts there. So there's a delay to it. Now, to get the timing right, we might need to change the delay a little bit. So let's do 0.35. So let's hit play. And now the sound effect plays at a much more accurate time to go along with the arrow being fired. Okay, so that's an example of play after delay. Let's go to the base layer of the player. So player hit, we can add the one-shot behavior. I think there is a hit sound effect, so I'll just use that for the player. Player death, let's add a sound effect. So I think there might be a death sound effect, enemy death. Is there one for player? It doesn't look like it. Okay, so we'll just use the enemy death for the player, just for right now. And let's hit play and get hit a bunch of times. Yep. Okay, so we have the sound effect for the player getting hit from the knight's sword. Maybe the knight needs to do more damage. It's taking a while to lose. So I'm actually going to go into the knight enemy. Let's take the sword attack, and I'm going to make it do 25 damage. Okay, let's hit play, and now let's get hit again. So that's 1 hit, 2 hits, 3 hits, sound effect playing each time, and 4 hits. And there we have our enemy death sound effect playing as well, which works all right for the player as well. So all of the sound effects on the player are working pretty nicely. Let's add in sound effects to the knight animator as well. So in the base layer for knight death, let's add a one-shot behavior, which of course the sound effect is going to be enemy death. Knight hit, we will add a play one-shot behavior. The sound effect is going to be hit. For attack, let's add in a one-shot behavior. So the sound effect I was using for this, I think, is Ice Explosion. I don't know if it was Ice Explosion, but we'll try that. So let's hit play, and okay, it was. So the attack has nothing to do with actual ice, but I think it looks pretty nice for a giant sword swing like that. And then we need to have sounds for the flying enemy. So FlyingEye would go to the animator. Let's add in for the death, play sound effect, and we'll do death. FlyingEye hit, play one-shot behavior, hit sound effect. And in the attack state, let's go to FlyingEye attack, add a sound effect, and let's find a good sound to use here. So it's literally a bite, so let's use the bite sound. And let's hit play and kind of test it out. So that's pretty much all working just fine. Might want to take the music and tone it down just a little bit more. So I'll make it 0.04 and then 0.04 down here as well. So let's do one more build and run of our game, and then we can give it one final test because we're pretty much done at this point. So there's our made in Unity. We enter the game, music playing. Let's fire some arrows, get hit by the enemy, do some sword swings at him. Let's defeat the knight as well. Get a health pickup. Oh, for the health pickups, we could also add in a play sound when we picked up the health pickup. We'll do that before we wrap up the course. So if you want to add a sound effect for something like a health pickup where there's no animator involved, let's do that really quickly. Adding an audio source to the health pickup prefab. Pick a audio clip. Let's use heal 2, and then we need to reference that inside of the health pickup script. So edit script on the health pickup. We'll get the audio source here. Audio source, I'll call it pickup source. So on awake, we'll find that audio source. So get component audio source. And then if this is not null, then when we come down here to heal the character, let's come down here. If it was healed, then we're going to play the sound effects. Okay, so if the pickup source is not null, normally what we would just do is you would do pickup source dot play. But we have a special circumstance here, which is that we're about to destroy the game object. So if the game object is destroyed, it can't play the sound effect. So what we would actually do is a lot like the play one-shot behavior. We can just create a new audio source with audio source play clip at point. And then that won't be destroyed when the game object is destroyed. So let's do audio source dot play clip at point. And we're going to do the pickup source dot clip. The position is going to be, let's say, the game object transform position. And the float volume is going to be the pickup source dot volume. So in a sense, we're kind of creating a copy of the audio source at the same position, but outside of the game object. So this way, we'll be able to play the sound effect when the health pickup is picked up and successfully used and destroyed. So let's hit play. Let's get hit. And I'm going to jump up here to play the sound effect. So there's our heal sound. And maybe that's a little bit too much of a magic heal. So we can change the sound effect if we want. Let's see if there's anything else here. Use item. Maybe that's what I was using before. Let's hit play. And let's jump in here. Okay, yeah, that's a little bit more appropriate. So that brings us to pretty much the end of the course. We have just about everything working. Knockbacks for the player, knockbacks for the enemy, the ability to take out the enemy, sound effects, music, pick up items, jumping animations, all that kind of stuff. Enemies that follow waypoint paths. So I decided that we'd add in one more bonus part to set up some extra UI elements and make a quick fix to the knight, basically adding the death fade to that, which should only take a second. So let's start with scaling font size. So if you've seen the build version of the game and compared that to the in-editor version, then you might notice that the font seems much bigger in the editor when we hit play like this, compared to our build version of the game. So it's actually very easy to get our UI elements to scale up with the size of the screen. So if you click on the canvas element, and let's bring out the inspector from the right side, there's this thing called the canvas scaler. So by default, we have it in UI scale mode, constant pixel size. We want to change that to scale with screen size. So there's a few settings here, such as the reference resolution, which when you're designing your project would be the base resolution that you're designing for. So if you build everything at, let's say, 1280 by 720p resolution, then you would want to put in here 1280p by 720. Now, during the project, I don't think I really had a setting on the game view for free aspect, but we could have made it 720p and just use that as the base for a resolution. And then if we put those numbers into here for reference resolution, it'll scale up and down depending on if it's higher or lower than that. So the reference pixels per unit is also a setting. So when our UI gets converted into game units of 1 pixel per unit, then it's going to use this value for scaling up and down. If we shrink this to 16 to match the rest of our project, then 1 unit, of course, is going to be a lot smaller, and therefore the UI elements are going to be a lot bigger. But I want to be consistent with our project, so I'm just going to use 16 as the reference pixels per unit. Okay, so I'm going to take these values, hit play. We'll test it out in the game view. So we have a good size there for our text, but let's go into File, Build, and Run and see if, proportionally speaking, our text is the right size compared to everything else on the screen, which is what we're really looking for, consistency and scale. So let's boot up the game and get hit by the knight. Okay, yeah, and we get hit. It looks pretty much exactly how I want it there. So yeah, that's basically the whole trick. You scale with screen size and make sure that you do this for any canvas that you want to scale up. So this scene has a canvas, but you might make other game scenes that have their own canvases. If you want, you could create a prefab out of the canvas so that you could reuse the same canvas in other scenes or levels in your project. So to do that, so if I wanted to do that, I could just go into UI and then let's rename this canvas in the scene Game Canvas. And I'll just drag it in here as a prefab object. So if I want to put the same, if I want to have the same settings in a different project, I'll just drag that into the scene hierarchy. And that's pretty much it. Okay, so now let's actually add a health bar to our character. So on the screen, we want to display how much health our player currently has, what its max health is, and we also want a slider bar to represent that visually. So let's jump into the prefab of the game canvas, and let's add a child element here. So it's going to be right-click UI slider. So you can see the slider has the ability to press on it and move it left and right by default, but we're going to remove that handle and we're only going to set the value on the slider through code. So first off, I'm going to rename this slider to be a... So first off, I'm going to rename this slider to be health bar, since that's what it's supposed to ultimately be. Let's bring it into the UI of the project. I'll go to scene view. Okay, so we're looking at the game view. This is where we would have it on the screen pretty much. We want it to be anchored to the top left of our screen though. So I'm going to click here in the rect transform where you have center and middle. So I'm going to hold Shift and Alt to set the position and the anchor to the top left hand corner. Just like that. So now you'll see our health bar pops up here in the top left. Let's offset it by a bit. So I will give it 50 on position X. And I think we need -50 on Y to make it move down. So based on our frame, I think that is a decent position to have it at. So we can use that. Now to remove this little handle, let's expand the health bar. The handle slide area, we don't need that anymore. I'm going to delete it. Okay, yeah, let's open the prefab and we'll delete it from inside of the prefab. So now for the health bar, the parent object, we need a target graphic here. So I'm going to click on target graphic and the fill area. Okay, so we can zoom in and it's already looking a little bit different here. So let's go to scene view so that we can see more details about it, like the gizmos and that kind of thing. So I'm going to double click on health bar and we can see the outline frame of the rectangle of the health bar. So next we want to take the fill child that's at the bottom here under fill area and set the width to 0. And then we want to switch to the rectangle tool. So that's right here in the scene viewer. And we want to stretch. And now we're going to want to stretch the edge of our fill to the fill area. So pull this out all the way to the right. So with the rectangle tool, select the fill area. And we want to pull this out to snap to the edges on both the left and the right. Okay, so if we do all of that correctly, now we can go to the health bar and let's manually adjust the value. And you'll see that our slider bar can fill from left to right. So all we need to do now is have a script which can basically set the percentage of how much health the player has compared to what its max health is. And that will be our health bar. And then we'll also have text underneath to show the number version of that as well. So let's add some placeholder text under the health bar so that we can also set that when we create a script for the health bar. So I'm going to right click and then I'm going to go to UI, text mesh pro. All right. And this is a child game object, so it's under our health bar. I'm going to shrink the text way down. Let's say something like 24. Let's also center it vertically and horizontally. And I'm going to position it below our health bar. So let's kind of get it like that. We can take a look at game view and roughly see how it's going to look. Our health bar is actually really quite tiny. So we're still editing in the prefab mode in context. So I will take the health bar and let's actually just increase its size. So let's take the prefab for the health bar and I'm going to make it quite a bit bigger. So 320. So let's go back out and just make sure we're in the prefab for the health bar. I'm going to take the width and let's set it to 320. Let's be in game view so we can actually see it. And then the height, let's put it at 60. And the text, let's move it down below. Maybe we actually want to use the rect tool for this so that we can kind of snap it to the center and the other edges. So I'll pull the bounds of our text out here to the left. And let's pull this text box down a little bit more. And let's select from the font asset the M5X7 SDF font we have for the game. I'll put in some placeholder text and say health 100 out of 100. Let's put the value to 50% for now so that we can kind of see what it's going to look like. I'll take the normal color and let's just make that green. Okay, and then the background color should be a little bit darker than that, but still green. So let's see, I think that's the pressed color. Let's go here and select a darker green. Nope. Okay, so to fill in the background color, we click on the background child game object and let's select a color, a green, but it's going to be a darker green than what we had before. So something kind of like that should work pretty good. Let's go to game view and take a look at it. I'll hit play to test as well. Okay, and we can see that our health text is way off center from the parent. So we're going to have to click on text TMP and let's actually anchor it to the center of the parent. So I'm going to click here and let's do Shift Alt and click on the top centering position. Then I'll take the alignment and put it back to left. Okay, I guess the anchor didn't get set there. Hold on. Shift Alt, click here. So I'm going to adjust the bounds of the box again with that rect select tool. And let's see. Okay, I want to move it, let's say 100 pixels negative off the top. This is just kind of a numbers game. So okay, negative 60 seems good. And now I'm going to make the alignment right aligned. Okay, that might kind of work, but it's still a little messy in the main game view. I think if we jump out to the main scene, the values in here are not matching what's in the prefab. So I got to click on the game canvas. Let's click on the health bar. And let's see if these values are different. There's our problem. If we click on the text TMP, we got to reset these to the parent's prefab defaults. So I'm going to right click here, revert. Let's see. And then also the health bar itself is way smaller than it's supposed to be. Okay, so I gotta change the width and height values here. So let's do that and then apply that to the prefab again. And then let's double click the prefab, make sure that's still set up correctly. Not sure why that didn't apply before, but as long as we get it there. So it should be looking much better now. Let's take the text and increase the size. So 48. Okay, that might be good. Let's go to the game view. And if we're looking at the frame of our game, it's roughly kind of like this. Let's hit play and see how that goes. And let's check the build of the game and check how that would look. It's a little bit big. So I'll shrink the size, the height to 45. Let's make the width to 80. I'll apply that to the prefab. I see that's updating the game canvas prefab. So later we'll copy and paste the same values to the health bar prefab. So the text here was a little bit big, so 42 might make a better size. If we look at the scene view, you can also move it up a bit. So negative 45 or negative 40. We also want to adjust the size to match the width of the health bar itself. And if we go to game view, I think that's quite a bit better. So to make this text a bit more visible, I'll jump into the prefab and then let's add a background to the text here. So we can right click on the text TMP, go to UI panel. I'll rename this to be, let's say, text background. I'll go to scene view and let's change the color. Make it less transparent, somewhere around here. And the background color can be something like a grayish black. Okay, so we actually want the text to be behind the background. So I'm going to move the text background up here, and then I'm going to make the text the child of that. Okay, that's a little better. And then let's go to the text background, and let's increase its size. So for the text background, I'll change the anchor to top center. Let's increase the width and the height, something like that. I can hit W to move it up to here. And then the text TMP box. Let's see if we can resize this to fit the text background. So with our text box, I'm going to take the yellow bounds and move it inside of the text background panel. Okay, yep. Let's just make sure that the text doesn't show outside of the text background. And the text, I think I do want it centered vertically. Let's also offset it from the right a little bit. So right offset of 10. That's looking decent. Let's go back out and take a look at the game view. So if we look at that, that's okay. If we hit game, then we can see it's actually outside of the box. So once again, got to go to the text TMP and then reset it to the prefab values. So health 100 out of 100 there. Let's take a look at the game canvas. So down here, the text background. And also the text size down here. Let's reset that to the prefab as well. Okay, I just got to be careful about those values that differ between your main scene and the prefab values. So let's hit play real quick and give it a quick test. It's pretty hard to read the text values there. So let's jump into the game canvas once again. Let's take the text. Oh, it shrunk down to 42. Interesting. Oh, it shrunk down to 24. I did mean that to be more like 42. Then the text background will increase the height to accommodate for that. And let's look in scene view and just make sure that it's matching the bounds. So right about there. Okay, back out in the hierarchy. So now we can hit play. And that's looking pretty okay. We do want to turn off the ability to highlight the health bar though. That's a little bit weird. So let's click on the health bar and turn off interactable. So now if we hit play, we shouldn't be able to click on it or hover over it or anything. But it is using the disabled color. So let's make the normal color the disabled color. So I'll click on the dropper and then go up here to the normal color. And then just take the transparency, the alpha, and make that 255. Okay, now when we hit play, it should be just the same as before, just we can't hover over it. Okay, so now that we have a decent health bar and a health text area, let's create a script so that we can set these values at the start of our game and also when the player happens to take damage. So I'm going to click on health bar. Let's jump into the prefab and let's add a component to it. So I'll call it health bar script, create an add. So let's edit the script. So what we need the health bar to be able to do is to have some reference to either the player directly, or we could use a Unity event in order to respond to the player specifically taking damage. So we could adjust our damageable events so that when a character takes damage, it passes the object itself on that event happening if the character taking damage was the player. Another way we could do it, which is probably more straightforward for now, is that we can have our health bar get a reference to the player at the start of the script. So we can take our player object. Let's go into the prefab, and I'm going to change the tag to player, which is one of the default tags. So what we can just do is we can find the object that has the tag player, check if it has a damageable component on it, and then if so, we store a reference to it. So what we can do is find the object in the scene that has the tag player, look for its damageable component, and then just keep track of the values on that damageable component inside of here. So in our start function, we want to do GameObject.find GameObject with tag, and then the tag is going to be player. So let's put that GameObject player over here. And with the player, we can get the damageable component on it. So I'll do damageable player damageable up here at the top. After we find the player, we want to set the player damageable equal to the player.getComponent damageable. And then we're going to need a reference to our TMP text element down here. So we could do a public tmp underscore text, I believe it is. And let's do the health text, or health bar text. I like that better, actually. And we're also going to want to reference the slider itself. So public slider, and you'll have to do control period using Unity Engine UI. And we can say health slider. So when our value changes or at the start of our script, we'll set these values. So let's do health slider dot value equals, let's say calculate slider percentage. And then we'll take the health bar text dot text, and we'll set that equal to whatever we want it to say. So this can be health, or actually like HP better. So let's do HP, and that's going to be plus, let's see, player damageable dot health, and then plus a forward slash plus player damageable dot max health. Okay, that's good. So to calculate the slider percentage, let's add in that function. So we need a earned current health and then int max health. So we'll just return the current health divided by the max health. Maybe we didn't need a custom function for that, but whatever. So to pass those values in, we'll just get the player damageable dot health again and the player damageable dot max health. Okay, so that's fine for on start to set up the UI at the start of our game scene. But we also want to hook into the event so that we only change these values when the character actually takes damage or heals. So let's say update on, okay, and you know what? I'm going to take these out to an awake method. So void awake and just paste it in there. Just because if those aren't set up in awake, I think it might cause some problems. Having these values set on start is just fine. So we got to hook into the events on the damageable component. So void on enable, and then we'll do, let's see, player damageable dot, what are the events inside of it called? Okay, we can go to the damageable script and find out. So up at the top, damageable hit and damageable death. So these events won't really work for us. Let's create another one inside of here. Just when the health changes, we can do like a health changed event. So public Unity event, and let's say int, so health changed. So we'll come down here to where the health is set. So health changed question mark, just to make sure it's not null. And then we'll invoke it with the current health value and the max health. Okay, so now we can reference this event over on the health bar. So player damageable dot health changed. We're going to need to add a listener, which is going to be, let's create that down here. Private void on player health changed. So the int new health, int max health. Let's come back to that in a second. Let's just make sure that this gets called. So add listener on player health changed, and then private void on disable. So if for some reason we're not using the health bar anymore, then we want to remove the listener so that it never tries to call the on player health changed function in the script. So player damageable dot health changed dot remove listener, not remove all listeners, but remove listener on player health changed. And then when the health changes, we can update the values just like we did on start. So I'm going to copy paste these down here. So let's see down here. I mean, we already have the reference to the player damageable technically, but we can just use the values we got right here. So new health and max health. And then down here, we'll do new health and then max health. So this should do a decent enough job for us. The only thing we need to do is make sure in the scene there's only one game object with the tag player. So we should also check that the player was actually found. So if player is null, then we can do a debug log message, which will say no player found in the scene. Make sure it has tag. Then let's put player in single quotes. And that will be our debug message, just in case we forget to have a player in the scene or it doesn't have the tag player. Okay, now back out in our Unity editor for the health bar. Let's scroll down and find the script So we need a slider. Let's drag the health bar into there to get the slider component, and then the health bar text, we drag the text TMP into that slot, and that should pretty much be all we need. So let's see if everything actually works. Let's go into game view and take some damage. So it is updating over here, but the value on the slider is not correct. So that's probably just a calculation error. So let's see, we're trying to set a float, and we're using the current health divided by the max health. This is probably because we're dividing two integers. So if we have a value of like 5 divided by 10, it's going to give us an integer value and just round down to 0. So there should be a math function for this. So to get around that, let's change the parameters into floats. So if we pass a integer in, I believe it will automatically convert it into a float, and then we're dividing two floats here, which means we're going to get a decimal value representing the percentage. Okay, so now let's go ahead and test one more time. I'll hit play, we get hit, and now our health bar updates to 0.75 value. So the float conversion is working. We get hit one more time, and at that point, our character actually dies. So let's hit play one more time and watch that the HP updates properly, and also the slider bar moves to the left as our health drops. We can also jump in here and see that when we heal, it's also updating since we created that on health changed event, not just using the damageable or on damaged event. So that's pretty much it for the UI part of this tutorial. So let's just do a couple quick fixes and probably wrap up this last video. Let's hit play, and I'm going to try hitting and killing the knight. So let's take him out. Yep, and you see that he doesn't have the fade on death. So we created the script for that. We just need to make sure that the knight has that. So in the knight's animator, let's go to the death state here, add the behavior, fade remove behavior, and we could just have fade times 0.5. Let's hit play. Okay, and now he's fading correctly. Let's just test with the eye as well and make sure that will properly die. Okay, good. So the last thing I noticed is that the health pickups can be picked up when our character is fully healed still. So let's hit play, and I can jump into that, and you can see that the health pickup is removing, even though it's not supposed to. So let's go back out to the main scene. Let's find the health pickup, go to the prefab for it, and that's going to be a script issue. So let's edit the script on the health pickup. So the reason in onTrigger enter for the health pickup that the object's destroying itself, even when the character doesn't need to get healed, is because this if right here is only applying to the next line of code. So I think that would mean that this won't run if the character wasn't healed, but this if has no brackets, so the destroy happens either way. So to fix it, we want to do curly brackets here, pull all of this inside of there. Now this if statement, if pickup source, is fine because we only need it to apply to the next line, but just be careful about that if you don't already know. Now another thing I'm just going to do is put a double check to make sure that if we're even going to attempt a heal, that the target is damaged. And we could just do that by checking the health and the max health on the damageable. So we'll do and damageable.health is less than damageable.max health. So now we have two layers of checks. We have this Boolean down here, and we also have this check that the health is less than the max health, or else we won't even look at this code. So now this should be fine. If we go back to the Unity editor, I'm going to hit play. Let's jump into the health pickup, and it's not doing anything, which is what we actually expect. We don't want it to be picked up. Now that we are, and when we do need to heal, and we jump into them, of course we get the health pickup as expected. Okay, so that's pretty much it for this UI and fixes video. It's probably going to be the last one for the course. So if you got to this point, thank you for watching to the end for my 2D platformer crash course tutorial.